Well, thank you so much for signing up for this course. I have put in a lot of time and effort in creating this course. And my hope is that every minute you spend on this course, it helps you for many years to come, because I strongly believe that this new world which we are entering in, the world which is powered by AI, it is just beginning of a new start. And more AI will become prevalent in our daily lives. And this course will help you not only navigate that new world, but also thrive in it. So let us first start with what is the promise of this course. Well, since you are spending time and money on this course, I just wanted to begin with very clearly stating what the promise of this course is going to be, so that there is 100% alignment in what you are expecting out of this course and what I'm about to deliver. So, what is the starting point? The starting point for this course, while I have created, is that anyone who has absolutely no prior knowledge about any kind of AI, let's say if you were living under a rock, you have never even heard the term AI, this course is designed for even that kind of audience. So you have absolutely no prior understanding of how AI works. You don't know what it is and what is generative AI, which is I'll be referring to as GenAI, because that is the most prevalent name for it, sort of an abbreviation. So you have no idea about it, then this course will walk you through that. And what is the end point I'm seeking? That after you go through all the modules of this course, where would you get at? The aim is that, one, you'll get a very good bird's eye view of what are all the components involved in the latest AI and generative AI landscape. So you would be aware of different things. How are they connected together? Also, what was their historical evolution, so that you do not have just an idea about what different components are involved. You can also backtrack and have a sense of evolution, that how we got here, where we are getting. And once you have an understanding of how we got here, what is the current landscape, then naturally you can get a sense of where we are heading. So all of that I'll try to explain in this course. And another important thing is familiarity with terms. I think this is the biggest barrier anytime you are trying to learn anything new. There are abbreviations and acronyms and a lot of terminology which sort of, when your mind hears, is sort of automatically shuts down, because you don't know what is RAG, you don't know what is model fine-tuning and all of that fancy stuff. I'll try to explain all those terminologies, what do they mean, in a very clear, intuitive way, so that when you are having a discussion or when you are planning a roadmap, you can very clearly understand what those terms means, how are they connected, what are their benefits, pros and cons. All of that you'll have a very clear grasp of by the end of the course. So starting point, you have absolutely no idea. Ending point, you can have a very knowledgeable discussion about generative AI, about AI. You can plan anything according to that knowledge. And then I plan to do it without involving any scary stuff. So there are no math equations being discussed. I won't be asking you to install any fancy stuff in your laptop so that there are complicated setups. No programming, coding. I've tried to keep it as intuitive as possible without including any scary details which you might have difficulty understanding, especially if you are a beginner. And I hope that the course is so easy for you to go through. that it sort of feels like you're watching a documentary, or you won't have to spend a lot of time understanding what's going on. I've tried to keep it a breeze through course so that you have absolutely no problem going through it. By the time you're done going through it, you have a very clear idea of what is the landscape of AI, how we got here, where we are heading. Okay, so before we go any further, I wanted to set the stage by explaining a little bit about me, that why I think I am capable of teaching you all this and why you should even listen to me. Well, first of all, I've spent significant amount of time in this field of AI. I started working on actually natural language processing problems in 2016 and have been working on those problems and generative AI solutions since then. So it's about 10 years. And all those years, I have seen how things have evolved over time. So we started with things which were very limited in terms of their capability. And then with passage of time, we have now tools which are very fancy. So I've seen all of that, and I've worked on it hands-on pretty much every single day of my life for the last 10 years. So I know a couple of things. Second, I am currently working as a senior staff data scientist, and I've worked in some of the biggest corporations in the world, Cisco. I previously worked at Meta, Wells Fargo. And at all these companies, I had an opportunity to learn about these AI models. I haven't had an opportunity to deploy these into production to see how they get actually used in real life. So it's not a theoretical knowledge which I have acquired through reading books. I've actually been implementing all of that. And one of the best things about working in big tech companies is that, besides getting a good pay, is that you get to learn from the very best, because they generally have like very senior architects who are there if you need any help. Also, a lot of these AI solutions, they need a lot of compute power, which is very expensive. Not everyone can afford it, but these big tech companies, since they are investing a lot of money in it, they are able to afford it. And also, they have tons of data. So think about petabyte size data, where there are billions of records in hundreds, thousands of tables. And once you have that kind of massive data set and enough compute power available, there is a lot you can do with all the fancy AI tools. So I've been dealing with a lot of that over the last 10 years. And in terms of what does this senior staff data scientist actually mean? Well, generally, when you start your career in data science, you start at junior data science position. And then after promotion, you become a data scientist. After that, you become a senior data scientist. And another promotion, and you now become a staff data scientist. So now you are basically sort of supervising and managing a team of data scientists. You're not people's manager, but you are that technical sort of experienced people who people consult and who design the system. And then another promotion, and then you become senior staff data scientist, because now you are supervising a team of staff data scientists. And whenever they get stuck, they ask you for your opinion. And then you design the solutions which are big enough. So this is the trajectory I've sort of gone through in the last 10 years. And also I have a PhD in AI. So not only I've been implementing these solutions, I've been learning about them. And of course, during the PhD, I've gone through a lot of research, and I still read a lot of research papers because I have to implement a lot of them in my daily life at work. And also, I've been writing some research papers for last couple of years. So this basically, all this means that I have been spending a lot of time, pretty much on daily basis, understanding, reading different AI concepts, and also teaching them. I have a YouTube channel where I have about 8,000 subscribers, 100 plus videos, and I like teaching different AI data science concepts in a very easy to understand way. And that is why I think that you would benefit a lot if you go through the rest of the course, because I have tried to cover a lot of things in a very easy to understand way. Okay, so now let's go through what are all the modules this course is going to comprise on. We start with Introduction to Generative AI. There we'll cover what is AI, what is generative AI, what can you expect from, how are these two different, and it gives you basically a glimpse of what are day-to-day things where even if you do not realize you are using AI and you are being a consumer of it. And then I begin with a little bit of history. I think this is a very interesting chapter to go through because I've tried to weave in a lot of interesting stories about how we got here and what were different milestones we had to go through, who were the key contributors who people have not even heard their names. And even when they thought about and explained about what AI can do in their day, people sort of ridiculed them. And it is only sometimes centuries after that we realize that what they have explained and what their contribution was actually was very, very useful. Then we sort of take a step back and think about what is the bigger picture. What are different components of AI involved? What are different kind of generative AI models? What are their capabilities? All of that we go through in the bigger picture section. Then this is a chapter about prompting, since this is sort of the very basic thing you should be familiar with. If you want to use these AI tools effectively, prompting is the fundamental and the easiest thing you can get on, definitely the lowest hanging fruit. So this is a chapter about that. Then how do we customize the AI models so that they could actually do some specialized tasks which you want it to do? How AI is being used in creating art. So here we'll be talking about GANs and some other fancy stuff. How do you enhance AI knowledge besides what it already knows using some of the material which you have? For example, your own knowledge base. It could be for a company or any other document you wanted to consult. So how do we do that? That is where RAGs come in. Again, if you don't know about this term, don't worry, we'll cover it in detail. And then some advanced GenAI capabilities. We'll be talking about agentic frameworks. How does that work? And lastly, how we can use AI responsibly and what are the potential drawbacks if it is not used correctly. So we'll cover that towards the closing. And then there is a bonus module where I'll be explaining what you can do after going through this course, and also some cheat sheets and a lot of bonus stuff which you can go through, which will be a useful toolkit you can have after completion of this course. Well, welcome to the first module of this course where we actually start going deep into what is AI, what is Gen AI, how are they different. So let's first begin with explaining what the module objectives are. So we'll be looking at what is AI's impact in the modern world. You might already be aware of it, but we'll sort of go into a little bit detail here and then define the terms. What is AI? When we say AI, what is generative AI? How are they two different? So basically just explaining some of the terminology we are using so that we are all on the same page. We see some real world examples of how AI, and specifically Gen AI, is transforming the world in the field of business, in the field of science, and we'll see multiple avenues where it is basically a game changer. And then what is the career elements of it? If you want to switch job, what are the other opportunities it opens up for you? If you want to excel in your current job, what are the how it can basically empower you even in your current roles? What are the growth drivers for the Gen AI? I mean, why we just saw recently a boom of AI in the last 2-3 years? Why it didn't happen before? Where are we going? So going through that, and then demystifying some of the concepts at a high level about AI, so that it is very easy and intuitive for you to understand anytime you are learning more about AI and generative AI. So all of that will go into this module. So let's first talk about what kind of future is unfolding in front of us right now. We can see that AI is basically reshaping and redefining what can be done in pretty much every industry. And its influence is pretty much on par with personal computer revolution. I've been old enough that I know, especially growing up in Pakistan, there weren't a lot of people using computers. And even when I, as a kid, wanted to get a computer, an objection I would hear pretty much every day is, what do you need it for, right? So 30 years ago, we were at a stage that why you need computer was a hard to justify question. And where we have come now is that if for some reason the Wi-Fi router goes off, pretty much every person sort of starts asking what happens. It's become so much part and parcel of our life. And this is what AI is going to be, the same kind of transformation. It's not that some tasks get automated because of AI. It's how we operate. Again, think about an example of the banking industry was operating 40 years ago, especially in parts of the world where computers were not prevalent. I remember going to banks with my father as a child. There were a lot of clerks, a lot of files. They have like big giant storage of old files. Everything was manual. If you give them money, they give you a manual receipt. And where have we come now? Because of the advancements in the adoption of computers. Now there are 100% digital banks. I have an account in one. There are no branches. There's no paperwork. It's just everything you need from a bank can be done through your phone or computer. The same kind of transformation will happen because of AI. It's hard to pinpoint that what the new world is going to look like when we delve into the world of AI more and more. And the impact on different sectors is huge. We can already see what is the impact on medicine, what is the impact on education, art. A lot of diseases now can be cured because we'll have better vaccines, we'll have better antibiotics, we'll have better medicines to cure those. In education, we can already see that pretty much anything you want to learn about, most of the LLMs now, most of the ChatGPT-like tools, they can actually act like a virtual on-demand tutor, which are not only immensely knowledgeable, but they are available at your fingertips 24/7. Anything you need. And see that how that is impacting education. And then now we'll have tools like ChatGPT, the large language models, the generative AI models, actually scoring candidate scores. In terms of art, it can create pretty fascinating art. Actually, let me quickly show you. I've been recently playing around with this Gemini VO tool. So this is for video generation. And I asked it to basically create a woman who looks at the shoes which are unused and want to put its listing on to basically sell those shoes. And let's look at what it has generated. I think it's pretty fascinating. Let me see. So this is just an 8-second clip, but it tells you where we are going with generative AI. The women here, it looks, if I do not tell you that it is created by AI, there is no way, just by looking at the clip, you could find out that it is not a realistic clip. Every small texture, the sunshine coming through the window, the expressions on the face, hair, clothes, the scene in the kitchen. It is just so real. Also, if you try this microphone mode on any LLM tool, when I say LLM is large language models, is basically generative AI ready for you to use. The way it talks, it is very hard to distinguish that if it is a person talking or a bot talking. And if you combine all of this, it basically means we are almost at a stage that you can write these kind of prompts and you can create a movie. And it will be very hard for anyone to distinguish that if this movie was created by AI or by some other person. So this is what kind of impact it has on arts, right? Previously, it used to take sometimes millions of dollars to create some good movies. Now you can do it pretty much free by having some prompts. What kind of impact it will have on the world. Same goes for a lot of other things. Nature conservation. Now you can basically pass in 24/7 satellite imagery of forests and it will get processed in real time by some AI tool. And they will tell you right away if anything unusual happens. And a lot of other automations in every single aspect of our life. It definitely increases business efficiency because even per recent studies, about 50% plus code, which is written at bigger tech companies like Meta, is created by AI. Developers' code efficiency goes up at least by 55% as of today. Because when you look at about coding, for example, as a task, the main bottleneck there is that first you have to think about what kind of approach you want to take at a high level, and then you have to implement it, right? So these are two bottlenecks, thinking about the solution, implementing it with code. AI can help you with both. It can help you brainstorm, figure out what the architect should look like, what your approach should look like, and then it can code also. So from that perspective, it's like a big, big efficiency gain for all aspects of business, including coding, for example. Then we have scientific advances. I previously touched on it a little bit. Google's AlphaFold, they're predicting that they will be able to significantly, and when I say significantly, it's think about something which used to take us 10 years, now can be done in a week because we have so much compute power available to us. And that means that any problem in our protein structure caused by a disease, these tools will be able to run all the simulations and pattern recognition, and we'll be able to detect it. And the best part is that there are very few things which only go in one direction. Time is one example. It just goes into one direction, never goes in the other direction. Technology is also such a thing. It always goes into one direction. So if you are standing here today, worst case, 10 years from today, you'll be still standing at the same spot. There's no way you could go back. But most likely, you will further advance. And as you will go through the rest of the course, you would realize that in technology, the advancement is not linear. For example, it's not that if we are here today and this is year 1 and then this is year 10, and then let's say we say that we are at level 1 of technology and this is level 10 of technology, it's not that we'll gradually go with time here. It is actually exponential, like this. So every single year, we make much more progress than we made in the last year. So things are already at a very impressive stage. We are further going to see tremendous progress in it in the years to come. Another thing I wanted to highlight is that it has immense individual empowerment focus. Because pretty much most of the LLMs, ChatGPT, Claude, Google Gemini, they are available for free. Of course, it's like slightly limited version, but it's available for free. And even if you want to get a paid version, it's not that it's cost you arm and leg to get it. So it is accessible. You don't need fancy computers to run it. It runs on your laptop. it runs on your phone. And it basically means there is unlimited amount of knowledge available for every single person on planet who has any kind of device. And if I were to give a contrast of how things were 30 years ago, so someone who is studying at Harvard would have access to Harvard's library. Of course, they have paid a lot in tuition costs and other costs. Someone who is living in a third world country, they won't have any knowledge. So there was this big discrepancy. If you are born in a small village in Pakistan versus you were studying in Harvard, the person in Harvard has just access to so much knowledge. The person in Pakistan doesn't have enough knowledge. Even if they want to do something, they cannot do it because they don't have enough knowledge. Now this basically makes everyone equal. The person studying in Harvard has no more access to knowledge, at least theoretical knowledge, than the person who is in any small part of the world. I remember in early 2000s, so let's say 22 years ago, mainly my father was thinking about how we can basically contribute towards the people of a village we actually belong from. And one of the things we thought would be most beneficial, which we actually did as well, was to set up a small library. So we basically gathered some books. People donated. We got a bunch of books. We set up a small space in the village so that people could come there. And if they can read, they can benefit from those books. And the idea was that knowledge it's a superpower, right? And the best way you can empower someone is by giving them knowledge. Now, you don't need those kind of small libraries, which have 100 books, 200 books. Every single person who has access to any smart device has unlimited amount of information available to them, on demand, 24/7, almost free. And this is the kind of future we are going towards. So now let's talk about an elephant in the room. You, I believe, have already been sold into the idea of that AI is the new future and learning about it is definitely beneficial. Now let's talk about the question. Is this course for you if you're new to tech? Let's say you have no understanding of coding, you don't have a lot of mathematical knowledge. Is this course for you or not? Well, first of all, as I said in the very beginning of this course, I have created this entire course into it's like no scary stuff is added. It was slightly difficult for me because I have some prior knowledge about some of these fancy things, and sometimes there are blind spots. I might think that you know something, but you don't know. So I've tried to run it through some people, the outline I've created. I've also used Gemini and other LLMs extensively to basically go through, just to make sure that anything I'm saying is not advanced for anyone who is newcomer. So that's that. Also, I've been a big fan of Richard Feynman. And Richard Feynman had this popular saying that if you cannot teach a concept to a fifth grader or small child, basically, even a complicated concept, if you cannot teach it to a small kid, it basically means you do not fully understand that concept. Because everything, even the advanced most concepts, there is an intuition behind it, which any person with reasonable intelligence, even a kid, can understand. And it's only that when you boil down a lot of technical fanciness into something which is intuitive, that is when you fully understand the concept yourself. And this is that approach of intuitive explanation through analogies, through stories. It's been the best kind of learning I personally had. And whenever I'm trying to teach something, I try to boil it down into intuitive explanations, into smaller stories, into some analogies with real world, so that you get a good sense of what things intuitively mean. And once you understand things at an intuitive level, then adding in more complexity is just very easy. For example, if I intuitively explain to you something, later on, even if you look at the mathematical equations of it, Because you have intuitive explanation, it becomes very easy thing for you. Similarly, if you want to look at some tool which might be a little complicated, or you're trying to implement it through programming, if you have the intuitive explanation, if intuitive understanding of the thing, coding using tool, it becomes just so much easier. So that's going to be the approach. Intuitive explanation with analogies and stories as much as possible, while keeping away any scary stuff. Also, the focus of this course is very much on practical implementations, practical applications, and I'm a firm believer that you don't have to be an automotive engineer to drive a car. There are people whose jobs are to create those cars, and for you to benefit from that invention of the cars, you really don't have to be an automotive engineer. The same had been true for AI, because there were a lot of tools which were created by these big tech companies, by big researchers, and then the rest of the people were basically practitioners of those. And I generally used to think about 10 to 90 ratio before, even in the field of data science and AI, people who are actually implementing and whose job is to do AI, 10% of the people used to be the ones who were creating those solutions. 90% of the people were basically practitioners. They know about those tools and how to use them. So this was 10 years ago, let's say 2016. In 2025 and 2026, this is 1 to 99. Now there are 1% of the people who are creating the tools. It's 99% who are practitioners, because those tools which these 1% create, they're just so much powerful. And they're so much easy to use that a lot of people can use them. Now you do not need fancy programming to interact with these LLMs. You can basically explain to it just like as you would explain to any other person, an employee you have hired, what to do. It understands your natural language, conversation, instructions. You can talk about it, you can write about it, and it understands. So you do not really need to know the deepest details of backpropagation, again a fancy word, to be able to use these large language models or LLMs or these generative AI solutions. So to answer this question, is this course for you if you are new to tech, or if you don't know programming, or if you don't know math? The answer is 100%. This course is essentially designed if you do not have any prior background. You can still benefit from it, and hopefully it'll open up a lot of new opportunities for you and ways of thinking which you didn't have before. So let's say if you are using this course to basically use more of AI and augment your expertise in whatever field you're currently in, generative AI is 100% a very, very powerful tool. It amazes me that even today, this is May 2025, even today, when I talk to a lot of people, I had recently a conversation with a nurse, a person who is doing accounting, different people from different aspects of life. And when I talk about different AI solutions, they're like, yeah, I've heard about it, but never used it. I cannot tell you that how much they are being left behind every single day when they are not using generative AI in whatever they're doing in life. Generative AI can boost you, whatever work you're doing, significantly if you learn to use it properly. And there's a famous saying that AI will not replace your job. Someone using AI will. So think of it from that perspective, that if you do not use AI, how much you can be left behind. And let's look at some examples of how AI can be used to basically gain expertise, to basically become efficient in whatever you're doing. If you are working in marketing, I have some experience with marketing because I've worked in some organizations within our companies which relate to marketing and customer experience, etc. There is a lot of stuff which you do every day. You brainstorm slogans, you get ad visuals, summarize research with AI, all of that stuff you can do much better, much faster, much cheaper if you use AI. If you are a writer, it can help you overcome writer's block. The biggest problem most writers had is the biggest enemy of creativity is generally the blank page. Once you have the blank page and you want to write something, it's creating the first draft it takes 90% of your mental bandwidth. 10% then you can improve and iterate on it. AI can help you write the whole thing within seconds, the first draft. When I was creating the outline for this course, AI helped me come with the outline, with what I should say in every module, what the different sections should look like. Of course, I had to do a lot of back and forth and iteration, and I cannot just rely on what AI had spit out. Maybe we'll get to that stage sometime later. But AI can create wonderful, wonderful first draft if you clearly communicate it to it that what do you want. And that is prompt. We'll cover that later in the course. If you are writing any sort of dialogues, I think it's very useful to have generative AI as your sort of writing partner, because then you can say, okay, if this person said this, what do you think the other person should say in this context? It will come up with amazing ideas. And then you can get critical feedback with AI. Even if the AI has written the first draft, you can ask another AI, okay, if this is the draft, what do you think? Where do you think it can improve? And if you have written something yourself, you can ask, okay, can you please critique? An example I previously gave when I come up with the final sort of outline for this course, I asked an AI tool to basically critique and say that if I just wanted to make sure that the course is very beginner friendly. So I asked the AI to critique it. Is there anything in this outline which might not be very beginner friendly? And then it identified some spots. So very, very powerful tool. And one thing which is sort of my personal favorite and very impressive is that researchers, even in the field of AI, because I've been doing a lot of research in AI recently, even in the field of AI, when new research is being done, AI is helping do that research. So if you go to any new AI conference or journal publications where the latest state-of-the-art research is being presented, you would see that pretty much everyone is acknowledging that AI played a significant role in crafting that research. So AI is so much powerful now that it is telling us what to do next as well. And this is mind-blowing. So any current path you have, whether you're a doctor, accountant, nurse, writer, marketer, whatever, if you are not fully leveraging generative AI, you're missing out big time. Now let's talk about how you can basically get started on a brand new career by riding this wave of AI. AI is opening up a lot of new paths, a lot of new job opportunities. So it's fundamental to understand that AI is not just eliminating jobs. It is creating a lot of brand new jobs. And the demand on anything which is AI is just astronomical. So we are seeing that AI researchers, machine learning engineers, data scientists, all those jobs, they have been recording double-digit growth for last many years now, even when the rest of tech jobs especially have been going down. Anything which is related to AI is basically booming. There are a lot of jobs. According to Bureau of Labor and Statistics, BLS in the US, for AI research related roles, computing and research, I think it recorded 36% per year growth, which is way higher than average. And we can also see that the kind of salaries these AI people are getting is very, very impressive. And this basically tells that there is a lot of demand and not enough supply. Also, there are a lot of new emerging roles. So now we have, besides conventional machine learning engineers, we have AI specialists, and this could be industry specific in future. Banking AI specialist. We now know that there are a lot of automation engineers roles coming up. So these are the roles where people basically have a good understanding of an industry and what are all the automation and AI tools available, and then you marry these two to bring in efficiency into every aspect of that business. ML engineer, prompt engineer. Prompt engineering is basically, we'll cover a lot through about prompt engineering in the later section module. So all these things, and then there are other roles. There are data labeling, data storage, a lot of new roles they are opening up. So again, AI is not just taking the jobs. Since the world is changing, it is creating new kind of jobs. And I don't want you to look at AI as something which is your enemy. It is a very big shift in how we operate. But overall, humanity will benefit from this because we as a human species will become more efficient in utilizing the resources which we need for our day-to-day life by having better medicines so that we could cure our diseases, by having more food availability, by stabilizing the planet we are living in. These are all the shared resources which we need as human beings. With the help of AI, we'll become more efficient so that we can get more of that in lesser amount of time by spending less money on it, so that all of us have more of food, better shelter, better planet, better environment available to us. An interesting story I heard about that in 1920s, when tractors were becoming popular, there were a lot of newspaper articles about how they can take away jobs from people because farming was one of the highest employed profession back then. And by having tractors, a lot of those farming jobs would have been eliminated. What we have seen over the last century is that by having more automation, by using more tools, humanity generally has become better because now we have better roles available. In 1925, no one would have heard about or even thought about the roles of WordPress developer, right? Or prompt engineer. But now we have those roles available. So I'm a firm believer that by introducing more technology, we as a human being species, we become better. So it is for our benefit. It is not something negative which takes away your job. It takes away your job, but it makes you more efficient. And maybe it gives you another kind of job. But it is very important to know that the person who survives through any major shift and any major change is the person who adopts. The people who do not adopt become dinosaurs. They go extinct. So this is the course to basically explain to you the dynamics of AI so that you could fully embrace this new shift instead of trying to run away from it. Because realistically, there is no profession which will not become significantly impacted because of this AI impact. Again, to double down on what are the risks for people who are ignoring this wave of AI. Well, first, it reduces your competitiveness in whatever you're doing significantly. Again, it is not AI which will replace your job. Someone using AI will. And I firmly believe that in any job you are currently doing, as long as you are a knowledge worker and not just lifting bricks, AI will significantly help you become much more efficient at whatever you're doing. Even the most creative jobs like writing and painting and coding, AI can do a significant chunk of it. So embrace AI, otherwise you will become at least 50 to 60% less competitive even today against someone who knows how to use AI for their job. And the person who is using AI is since almost 100% more efficient, they can get promoted. If there are new job opportunities for the same role, the person who is using AI is much more likely to get hired because they know more, they are more efficient. So if you don't bother about AI, you're definitely missing out big time on future job opportunities and career growth opportunities within your field. Also, you are missing out a brand new field. And this is a field which is expanding very fast, which means there will be a lot of new roles getting created. And there will be very less supply for those roles because it is just so new. People have to learn brand new thing to get into those roles. And it is similar to the oil industry growth 100 years ago, when oil was what people needed and there was expanding need for oil. Anyone who was working on any sort of oil related industry, they benefited a lot. So data is the new oil, and AI engineers are the new refiners, people who make that oil useful, make that data useful. These are anyone who is working on any kind of AI role. So if you ignore this AI wave, you're big time missing on all those career opportunities which are already created or about to get created in the coming years, because we'll see more and more job opportunities coming into this area. Also, you would be unprepared for AI-driven changes. And these will be big changes which are very hard to forecast, because when things come to a certain level, they just change the whole ecosystem significantly. An example could be retail businesses 20 years ago. If they did not embrace, for example, internet, see what happened to them. Barnes and Nobles, one of the biggest bookstores in the US, you can see what happened to them, because as internet got evolved, competitors like Amazon came in. So Barnes and Nobles now is basically taking a very small share of the book industry, which they were previously commanding. And Amazon, as you can see, it is just growing so much. So these kind of seismic shifts you miss out if you do not understand AI, if you do not use it effectively to become better at it, and if you do not get new kind of career opportunities which are related to or aligned with this new growth of AI. So now, as we have talked about why AI is essential, let's define the term. What does AI actually mean? So as we know, AI stands for artificial intelligence. And what does that mean? So the definition of AI in simple terms is that AI is basically systems and machines performing tasks typically needing human intelligence. So if an AI has intelligence like a human, then that is called artificial intelligence, because and intelligence is a human feature. So we are trying to mimic that using computers. That is artificial intelligence. And AI should be able to do human-like AI tasks. So things like problem solving, language understanding, decision making, building a mind from code, all of that, what is the goal of AI. And as we will delve deep into the next module about history of AI, we'll see that even from the very beginning, from centuries, people have had this vision of, there was this charm about how can we create human-like intelligence. And that had been a goal for centuries. It's only now that we are seeing it coming to a point that it is becoming actually good enough. And we'll again go through it in the module about history of AI. But there is this Turing test, which is basically, can AI become so good that it is indistinguishable from human intelligence? And the video I showed you about AI generating a video, again, let me quickly for you here. 8 second long, but very impressive. So this is AI creating art, which is very hard to distinguish whether a human created it or AI created it. So that is where we are getting. That's the goal. And then AI is basically used in your day-to-day life, even when you do not fully realize it. You might not know that the email service, for example, Gmail you're using, how much AI it is using. You might not know that your Facebook news feed, because I've actually worked on it, the coding of it, the building models of it. You might have no idea how much AI it is using. Every single component of it is driven by AI. Your bank transactions, they are being monitored by AI. So AI is already pretty much everywhere in every aspect of your life. Anything digital you're touching, it is generating data. That data is being analyzed through AI. So you're already surrounded by it, just like a fish is surrounded by water. It might not realize it, but you're also in the same way surrounded by AI. And then generative AI, GenAI, is basically a subfield of AI because AI is a broader term and there are many subcomponents of it. Generative AI is probably the biggest one already. So there are other components of or subfields within AI like computer vision, robotics, but generative AI is the biggest already, and it is going to become so much bigger in future. Okay, so now we have covered what is AI. Let's also now define generative AI and why it is a game changer. So generative AI is basically original content creation. So it generates things. It focuses on creating new original content. So that is where the word generative comes in. It generates brand new things. That's what generative AI comes in. And it is a big leap from data analysis, which most of the predictive AI previously was using. So if you want to, for example, if you have sales data, then you can use AI to predict how much sales are you going to make in the next month, in different countries, in different seasons. All that kind of predictive stuff you can use with AI. You need tabular data for it, which is recorded and kept somewhere. This goes beyond that. So now we have internet crawlers which crawl through every single page of internet. And the way crawling works is that you give it a starting point, for example, Wikipedia, and then it finds all the links within that, and then it reads those pages, and then all the links within that. And these crawlers, if you give it some starting points, it basically crawls the entire web because everything is connected. Everything is linked to other pages, and it crawls everything. And it learns from all of that. So big leap away from the data analysis where you give it a data set and then you ask it to predict something. It is basically, generative AI is basically now at a stage that it sort of acts like a small kid. And if you give it enough information, it just becomes so much smarter. How it is actually done, we'll go through that in the later modules. And AI's creative power is amazing. I just show you the video it created. So beautiful. And see where we have come, right, in last 2 decades, perhaps. Even last 1 decade, because when I started working in AI in 2016, we were nowhere near. It was mainly you feed in the tabular data and then you get some output. I have been working in NLP extensively. It is called natural language processing. So basically, how do you use human-like language, if it is written words or something similar, to basically train some machines? I've been using the latest advents, the latest research on that since last 10 years. It has now become so much powerful that with simple prompts, you can basically create movies. I mean, what could be more elegant and powerful example of that? And then the key differentiator between AI and generative AI is that it opens up new applications and possibilities which we could not even think about before. So that is what generative AI is and how it is different and a subfield of the AI. Okay, so a question might come to your mind that if there had been a lot of AI research going on for so long, I mentioned centuries ago, people sort of envisioned that how we can create human-like intelligence. Why it is now that we are seeing these tremendous possibilities? Well, the thing is that a lot of things were needed for AI to basically improve, and it is a convergence of those factors. All of them have come to that point that now together they can become a superpower like AI. There are three things mainly. One is that you need a ton of data to be available. Second is you need compute power to process that data. And the third thing is algorithmic innovation. You need sophisticated enough algorithms so that you could analyze those data. And this is what I was briefly touching on, that why my experience of working in big tech really helped me, because big tech companies, not every company has a lot of data. Big tech has that. Computing power they have because it is expensive. Not every company can afford it. Big tech can improve it, can afford it. And since they have the best talent, the best AI researchers, they have the most innovative algorithmic innovations available to them. So you need these three factors. 1, 2, 3. Data, compute, and algorithmic innovation to come together so that you could use AI and so that you could build AI, which is fascinating enough. And we had seen almost an explosion in all these three things recently, because there are a lot of things going digital, which means they are producing data, and the storage is cheap enough that we are capable of storing a lot of data inexpensively. And then the compute power is also going down every single year. The compute power is going up every single year, and the cost is also coming down of it. So it's becoming more and more affordable. And then new architectures, new algorithmic innovations, we'll touch on some of those in the later sections, like innovation of transformers. How does that help in making the most sense out of the data we have available? And just to quickly show you what kind of data trend we are showing for all these things. So data is the number one thing we need to train these AI models. I previously told you that now there are web crawlers who crawl the entire web, and that data gets fed into AI. So how much data are we generating globally? So this is a chart starting with 2010, so not long time back. And this is where we have already come. You can see the growth is not linear, it is exponential. So a linear growth would have been something like this. So if we were to take a linear growth pattern, it will have like this. But this is not what we have. We have an exponential growth. And based on this, what is the data? How much data can you expect in 2026? If it was linear growth, it would have been something like here. But in the case of exponential growth, it will be like this. So notice the difference. All this big delta comes because of the exponential growth. So we are going to have a lot more data in the future years. Let's look at the GPT parameters. So this is basically how much parameters or how much compute intensive, in other words, your latest AI solutions are. So for ChatGPT, a famous AI solution, this is the number of parameters since they first launched GPT-1. This I believe was 2018 or 2017. And this is where we are 2025. So you can see that how much it has increased. It was about 200 million parameters. Now we are talking about 1.7 trillion parameters. So almost 10x increase in the number of parameters in the last 7 to 8 years, which is pretty impressive. And this is powered by, because now we have very efficient compute resources available. So there is Moore's law, which basically states that every 2 years, the processing power of the transistor, it basically says that number of transistors on a chip of the same size doubles and the price basically become half. But it basically means every 2 years, processing power goes up by 2 times. So this is 200% growth every 2 years, and the price is decreased 100%. So the price become half price, and compute is doubled every 2 years. And what does doubling mean? It means, just to give an analogy, they say if you have a piece of paper, it is not very thin. Let me see if I have a piece of paper. For example, if you have this piece of paper, it is not very thick. But if you double it, if you fold it, now you have double its thickness. It is still not very thick. But if you double it 50 times or something like that, you have its thickness so long that you can travel from the Earth all the way to moon. Just 52 times doubling, this is what it does. And if you double it one more time, 53 times, then it is all the distance starting from Earth to the moon and then back. This is the power of doubling. And our transistors, our compute power is doubling every 2 years. And the price is also decreasing. Which means if you extend this line further, very soon we'll have 10 trillion parameters available to us. And it is a known phenomena that if you have more data and if you have more compute power, just if you have these two things, the performance of the AI, it significantly improves. Even if you have no innovation in algorithmic solutions, if you just have more data available to it, and if you have more compute power available to it so that it could process that data, the output increases. So we can see that if we are at 1.7 trillion parameter models, very soon we'll have 10 trillion parameter model. And if we are currently at, let's say, 170 zettabyte of data, very soon we'll have 1000 zettabyte of data. And that means the power of the AI, which you are currently seeing, is going to become 10 times more powerful than it is today. And on top of that, the sophistication of the algorithms is also improving every passing day. If you look at number of publications, number of new research publications, number of new patents filed in the field of AI, it is much more than they were 10 years ago. And companies are spending literally millions of dollars to hire better AI talent, which means the people who are already in AI are getting better salaries and more opportunities to innovate new things, which means that a lot of new people want to get into this field because there is so much demand and better pays and all of that. And this all means there will be better algorithmic solutions available to us in the coming years. So going back to this slide of the 3 factors which we need data, we need compute, and we need algorithmic innovations. They have come to a point now that AI has become so much powerful. And through these charts, I've shown you where we are going with it. And if you look at these 3 things together and the pattern, you can see that AI is definitely going to become 10 times smarter, probably in the next 5 to 6 years, which is almost scary. Okay, so before I conclude this module, I wanted to leave you with a food for thought, which is, can you be a little more mindful and try to see what are different aspects of your life which are driven by AI. And there are bonus points if you could see what is potentially driven by generative AI versus conventional or non-generative AI. And the reason I mentioned potentially because a lot of solutions are using a hybrid. For example, if you look at the Netflix recommendations or YouTube recommendations now as well now, it is not only looking at the tabular data of what you have seen in the past, what people like you like more, it is also looking at the content of the movie or the content of the video you have watched and see based on that what are the similarities. So basically, a lot of these solutions now use both. But in most cases, you'll have a sense of what kind of AI solutions are just using tabular data or non-generative AI and what is using GenAI. And just think about pretty much every application you are using, how much of an AI it is using. For example, I'm recording this with a camera. It is able to focus on my face. How is it able to do it? Even when I change the location of my face, because it is using AI. The mic I'm using, it is using noise removal so that it could cut out some of the background noise. How is it able to distinguish between the two? It is using AI. So think about pretty much every aspect of your life. How much AI are you consuming? And when you are a little bit more aware, you would realize that you're basically drowning in AI. Everything around you is using some sort of AI. And if you are aware of how that AI operates, especially the generative AI, then that is a superpower because then you can have a sense of behind the scene working of what are different components of AI which might be used. And having that knowledge, it helps you become better at whatever you're currently doing. And it is an immensely useful thing if you want to make a new career in the field of AI. Okay, so it was a long module. Let's quickly recap what we covered. So we covered how AI is reshaping our worlds. What is the impact of AI and generative AI in pretty much every aspect of our life? We covered how Gen AI basically creates new things and how it is so much empowering and useful. We covered that how you can get a career edge by using AI. We defined some of the basic terms like what is AI, what is generative AI, how are they two distinguished things. We covered what are the factors which are leading to the rise of AI and what could potentially look like the future of AI if we continue on that path. And then how AI is basically all around us. We are surrounded by AI just like a fish is surrounded by water. And how you can spot them in pretty much every daily application you're using. So I hope this was a useful module. Now we'll transition into the next module. So we'll go over a little bit more details into the history of it, how we got here. And that is going to be a very interesting chapter because there will touch on some very interesting stories on the key people and the key innovation which help us get to a point where we currently stand. I hope you're liking the course so far. If so, I have a question for you. Would you consider sparing a little bit of your time to help me and a lot of other people who are thinking about buying this course? If the answer is yes, please click on the link below and leave a written, audio, video, however you are comfortable, honest review of what you think about the course. It'll take you a minute or two of your time, but that'll be a big favor for the community. Okay, so welcome to module 2 of this course. This is my favorite part of this course because here we'll be going through some stories, some interesting historical anecdotes about what were the events or what were the people who led to the AI advancement and because of which we are standing where we are. So this chapter, this module will be filled with those stories. I really I'm looking forward to going through those stories with you. I hope you also enjoy the time you spend on this module. So, starting with high level, what we'll be covering in this module, we'll trace AI's history, starting from hundreds of years ago, how people envisioned what the AI should look like or what the artificial intelligence should be able to do. We'll go through some of those. AI and especially NLP, which is natural language processing. Basically, how does computer or any machine understand natural language? Natural language processing. And then we'll go through some of the biggest changes. Mainly, we'll see that how people started with some rule-based system, and then we try to make more rules till we get to a point that we realize that rule-based system cannot take us to real intelligence. And that's when we went towards learning-based AI and how that evolution happened. So we'll touch on that. We'll try to go through what are some key innovations which actually enabled us to use this learning-based AI approach. We'll go through neural networks, transformers, how they got invented, all of that. And then once you go through the history and you realize where we are, then I think it's very natural to think, okay, where we are heading? What does the future look like? So we'll touch the future trends as well. And then also debunk some of the myths people have around AI, mainly that AI has been something which started a couple of decades ago, and then it's just consistently been rising. That's not been true. We have been a lot of ups and downs. So we'll go through all that interesting stories and anecdotes and milestones throughout this module. Okay, so now it's time to delve into some of the stories. We'll see that how this fascination of humans happened around how can we replicate human life. And that includes building an intelligence which is almost similar to human intelligence. And what does the journey about that look like throughout last centuries? So there's an interesting story about Talos, who was a bronze guardian of Crete. We find many mentions of it in Greek mythology. So we are going back thousands of years. And this was a giant robot-like structure. They would call it automatons. And its task was to basically protect the people living in that area. And it had many similarities to what we would call or consider a robot driven by artificial intelligence. It was built by metal, and it would revolve 3 times around that area, basically guarding it against any infiltrators who had any intention of harming the people. And it could throw stones, and it was very giant, as you can see in this picture. So in Greek mythology, this is one of the first instances which we have captured, where there was an idea that there is a non-human species which humans can use for their benefit. And how a robot-like structure, which has like a very structured routine of going through the parameter 3 times a day, and then identifying people who have some ill intentions, and then systematically trying to eliminate those. These are all characteristics of basically robots. And it's fascinating that we find the mentions of stories like this as long as 2,000 years ago. This is another interesting historical story in Jewish folklore about golems. These were small creatures built of mud and clay. And again, their job was to protect the Jewish community from anti-Semitic attacks. And the recurring theme here is that we have a non-human creature, which is created by humans, and which is capable of defending and protecting and aiding human beings, just like others human can. So humans have always fascinated about creating another creature which is just like them so that they could use it for their benefit. And as we trace back, we can see that some of the earliest work done was in early 1800s by a guy named Charles Babbage, and he's considered the father of modern computing. He basically created a logic machine which was able to do a lot of mathematical computations. And he also gave an idea of analytical engine, he called it analytical engine, which could go beyond mathematics and have some sort of intelligence so that there are rule-based systems based on which it can make some intelligent decisions, just like human does in most cases. He died in about 1850, and then some of his work was carried over by Ada Lovelace. She was sort of the first programmer because she took that analytical engine concept and tried to implement the first algorithm for that. Unfortunately, she passed away at a very young age of 36. And then that work which she started about implementing the analytical engine, which Charles Babbage had initially envisioned, that didn't lead to nowhere. And after that, for many decades, people didn't realize the importance of work which Charles Babbage and Ada Lovelace had done. It is only after a decade that people saw that what kind of work they had done, and then they took it forward. And we can see that people like Leonardo da Vinci, even in around 1500s, had envisioned about some sort of intelligent machines which could help and aid human beings. So Leonardo da Vinci, though he's known for great pictures like Last Supper or Mona Lisa, very few people know that he is one of the earliest inventors about the concept of robot. So in literature, there's a mention of that he designed what is now called Leonardo's robot, which is basically a rule-based system which could help human beings with a lot of tasks. So this we are talking about 1500s. So you can see that more than 500 years ago, people had envisioned some sort of intelligence which is coming to a point to help and aid human beings. Okay, so now we have some idea of how people started thinking historically about building some sort of intelligence which is mimicking human intelligence. Now let's look at the birth of NLP. So NLP stands for Natural Language Processing. So basically, the way I'm talking, the way you're listening, this is all natural language. So how does we allow computers to process that and make sense of that? And it is a very, very difficult task, because if you look at how computers work behind the scene, it is basically passing off electricity. So computers think in either there is passing of electricity happening or not, which is either it is 0 or 1. That's all computers think about. And when you think about the nuances of human language, it is just so much difficult for it to be communicated to computers in 0 ones. So we saw that in the very beginning, people try to come up with rule-based NLP systems, so that if there is a mention of something, then do this. And a very interesting example of that is ELIZA. In 1960, ELIZA chatbot, the earliest version of chatbot, was launched by MIT. And it was a Rogerian therapist. So Rogerian therapy basically means that whatever the patient says, the therapist basically returns back the same thing. So the patient had more time of introspection and going through and processing the same information which they have in hand, expanding on that, and that basically helps with the therapy. So MIT created this Rogerian therapist, which was basically a rule-based chatbot. So it would try to understand different keywords For example, if you say, I am sad, it knows that this is a keyword which is about emotions. So then it'll say, okay, why are you sad? Or till when, from when have you been feeling this feeling of sadness? It has certain rules based on if it is a feeling, then do this kind of stuff. If you mention, for example, the word mother, then it would know you're talking about a family. So it'll come up with follow-up question. Interesting. What else can you tell me about your family? If you say, I'm mad at my mother, for example. So it had these rules built out by MIT folks. And whenever it couldn't identify some strong keyword, then it would resort to generic phrases like, tell me a little more about it. That's interesting. And that led to this kind of back and forth conversation you could have with that bot, Eliza. And what really surprised people who created it, or who were aware of its inner working, that people started, the users who were conversing with this bot, Eliza, started feeling a very strong emotional connection, and it was actually helping them heal and process their thoughts, etc. To a point that Weizenbaum, who was the architect of this, was surprised that one day, according to the story, her assistant was chatting with Eliza bot, and Weizenbaum wanted to see what's going on, and the secretary said that I want some privacy because I'm talking about some personal stuff in a private session with this therapist. So people actually started thinking about this bot, which was driven by rule-based system, to actually be very useful, and it looked like there was a lot of sense of connection getting established, which is pretty fascinating. So we started with this rule-based system, and then we gradually went towards statistical natural language processing. What does it mean? So basically, we fed in the human language. For example, if there is this phrase of, I am good, then machines will try to break it down between different words. I is a different word, am is a different word, good is a different word. And then they will try to make some prediction based on the usage of these words to see to whatever task we are talking about. For example, if we are trying to teach machines what is a spam email versus what is not spam email, then the machine, when you, at the time of training, when you give it a lot of data and tell whether it is a spam, it is not a spam, they'll try to learn, okay, any word, anytime there is a mention of the word good, for example, it is a spam. Anytime there is a mention of this word, it is not spam. And it was, of course, not this binary, because even in spam examples, a lot of times you'll have the word good. Even in the not spam examples, you'll have a lot of occurrences of good. So then it will go into the probability that if there is a word good and am mentioned, then combined there is a probability of, for example, 0.6 that it is a spam. So this is basically a very high-level version of how does statistical natural language processing work. But we were going beyond that rule-based system of identify this keyword, then do this. So there was some intelligence coming out of statistical natural language processing, but there were a lot of challenges, because in human language, there is a lot of ambiguity. The context matters. There is sarcasm. For example, if I say, that movie was great, I just wasted my 3 hours. So here, the great word doesn't actually mean that it's good. I'm being sarcastic. So there was this opposite thing. Also, for each word, there are different meanings of it. For example, the word run, in English Oxford Dictionary, it has about 463 distinct meanings. So when I'm talking about the word run, it's very difficult for machines to interpret what does this word actually mean. And this also led to a lot of problems with machine translation, because it had been a key aim for a lot of these machines to be able to interpret the language and being able to translate it into a different language. So then, because then you every system can talk to another, one person can talk to another regardless of that language barrier. So they have been trying to spend a lot of time trying to see if they can translate. But that led to a lot of problems, again, because of these nuances of human language. An interesting story is that machine was once asked to translate this popular biblical phrase, "Spirit is willing, flesh is weak." So it was translated into Russian, and then from Russian again it was translated back to English. And the translation came up to be "vodka good, meat rotten." So it was too literal at translation. Another example was they translated "out of sight, out of mind." So this phrase, when they tried to translate into Russian and translate it back to English, it turned out to be "invisible idiot," because they literally translated "out of sight" means invisible and "out of mind" means idiot. So there was that kind of problems, because of which people very quickly realized that they cannot go far with statistical based learning approach. And another very interesting milestone here was the paper by Alan Turing in 1950 about Turing test. So Alan Turing was a famous mathematician and scientist, and he suggested this Turing test, which he called imitation game, but it is now commonly called Turing test. And the test was very simple. The test was that if there is one person, this is, let's say, examiner or detective, person C, its job is to communicate with two people. One is a machine. So this is a machine and this is a human. And they can only communicate through text. It could be words written on computer or on a paper. But they can this examiner or detective can communicate with machine as well as human. And the job of the machine is to basically fool the detective into thinking that this machine is actually a human. And the job of the human is to basically convince the detective that it is a human. So the test is that how many times machine is able to imitate the functionality of a human, which means it is able to reason and argue good enough that this detective is not able to understand which one is machine and which one is human. And this is what is called imitation game and Turing test. And in the 1950, when Alan Turing talked about this test, his prediction was that in the year 2000, about 30% of the time, machine would be able to convince this detective that it is a human over the period of 5 minutes interrogation. And it looks like it took us a little more time, but we are getting there of passing the Turing test. Okay, so now let's talk about what kind of solution researchers came about when they thought that this rule-based system or statistical approach around NLP won't take us so far. So that led to neural network revolution. So when researchers realized that they cannot go very far with these rule-based or statistical NLP approaches, they started studying how does a human mind work? Because again, the goal is to create human-like intelligence. the more inspiration we can draw from human brains, the closer we can get to that goal. Similarly, as Wright brothers, when they wanted to have something, create something which can fly, they saw, okay, what is already flying? Birds. So throughout their experimentation around creating the first plane, the inspiration was coming from birds. Similarly, as we are trying to pass that Turing test, to create that human-like intelligence, the goal has always been draw inspiration from human mind. How does it work? And then try to mimic it through machines. Neural network is basically the same thing, where we draw inspiration from brain and try to make it learn from examples, just like how human mind does. So to give a brief glimpse of a very high level non-technical glimpse of how does neural networks work, so we start with human mind. So human mind basically works based on neurons. So we have billions of neurons in our mind. Every single neuron has an input, and that information goes through this, and there is an output. Sometimes that neuron gets fired, which means the information gets passed. Sometimes it doesn't. So there is that. And then when you connect it together, billions of neurons, then that's how human mind works. So we try to mimic the same functionality. In earliest research, as soon as 1946, we see that there was some research talking about how can we mimic this neuron combination method of creating intelligence. But of course, there were a lot of problems back then because we just did not had enough data available that we could to teach machines. We did not had enough compute that we could put together billions of these neurons together and see how it works. So that is why for a very long time we didn't see much advancement till recently when we had enough data and compute power available. So to mimic the same thing, we do the same neuron type structure into machines. So we have input. So this is computer connected to this and this and this. And then they are also connected together, and then there is an output, just like a human brain does. And ultimately what you get is some mesh even more complex than this coming together to mimic the functionality of a brain. Now, each of these connection has a weight, which they call it also parameters. So that is a parameter which defines that if the information will be passed on to the next layer or not. And there are billions of these neurons connected together in modern, for example, GPT AI versions you see. In latest ChatGPT version 4, they have about 1.7 trillion of these parameters, which basically means 1700 billion parameters. And we are going to have more of those. So this is basically the way neural networks work. And the fascinating thing about this is that the one way to build an intuition around it is that, let's say if you want to teach machine how to identify a picture of a dog. If you want to identify dogs in any given picture and you want machines to do it, let's first of all figure out if you can build some rules around it. What kind of rules would you build? Because dogs are of all sizes, big and small. If you say, okay, if the shape of the ear should be like this, then it is a dog. But how does it identify when is the ear starting? You will have to create a lot of rules. And even it will fail so many times. But the good thing about neural networks or this learning-based approach is that at each stage, this is called layer. Let me use a different color. At each of these layers, it is learning a different feature about the input you're giving. And it is defining the features itself. As, for example, here, after you show it, let's say, 50,000 images where dog is present or dog is not present, and you tell it where is dog, it will automatically understand, okay, maybe shape of an ear is an important feature. But again, what feature it comes, it's a black box. You cannot fully understand, but I'm just trying to explain how does it work or what our understanding is. So for each feature, it will have a layer, and it'll say, okay, maybe this layer is shape of ear, and maybe this layer is about what does the tail look like, and so on. So it'll learn all those patterns, and the deeper the network, the more powerful it is. That's why we want to have it as many parameters, as many layers, as many neurons as possible, and then feed it as much data as possible, and then it just becomes so much smart that it is mind-blowing. So we want to have deep layers so that we could allow it to learn complex parameters. And with this, all of this neural network-based approach, we are going away from creating the words, identifying different words, and then what is the frequency and what is the probability, all that statistical NLP, to creating some embeddings, which is that we give it a sentence and then it creates some encoding of it. And that encoding is just a very high level of representation of what that sentence means. And because from 1945, when people talked about this, we didn't have enough data and we didn't have enough compute power available. There was not much progress till early 2000s when we started having some data and we had enough compute power that we could see that this actually works. So all this time is actually called a period of stagnation or AI winters, where there was all the AI research, it was not very much encouraged. They were not invested in. And it is partly because in 1940s and 1950s, people were very excited about computers and what they can do, and there were some overblown promises. For example, in 1957, there was this prediction that machines would be able to beat chess champions in the next 10 years. But it actually took 40 years. And in 1997, first machine was able to beat the chess champion and became the world's first AI champion. So people were very fascinated about what AI can do in 1940s and 50s. But then because of these problems with compute and data availability, we didn't see much progress. So that gap of about 50 years, there wasn't much research done in the field of AI. And a big credit goes to people like Lee Yacun and Jeffrey Hinton and Ben Geo, that they, despite not getting a lot of encouragement, still felt like that AI could do wonders, and they kept doing the research, and because of which we are able to see significant breakthroughs in the recent years. And that's why they are called the godfathers of AI. So overall, this journey hadn't been very smooth, but thanks to the people who have been still investing time and effort into creating the sophisticated algorithms, that we are seeing the AI revolution we are currently seeing. Okay, so you might have already heard me say a couple of times LLMs. What does it mean and how does that help? So we saw that how we initially came about having some artificial intelligence, then how does it impact natural language processing? And now when we are talking about generative AI, it is mainly large language models. So how does that breakthrough happen? Again, we started with some rule-based systems. Then we tried to create some statistical approaches around word frequency. And then we realized that there is not much progress we can make, so we have to rely on using some neural networks. And the way neural networks were working was mainly it was called sequence-based modeling. And which basically means that you give it one word, and then one word, and then one word, and then it tries to basically make sense of what's going on, and you feed in that data into some neural network. But it had some problems. And the biggest breakthrough came in 2017 when this paper, Attention is All You Need, was published by Google. And this was a game changer because it said that instead of doing things in sequence when we are reading text, we can have machines identify what are the important things in that text and then allow machine to give attention to those. And that attention led to a bunch of big things. One, we were able to treat not every single word or phrase with equal importance. So the machine started focusing more on the text which was actually important. Think of it as machine actually highlighting the important stuff first, and then someone going through it. It would just make even a job of a human being much easier if you have some important text highlighted in a book you're reading. So it was basically going through the same concept. And it was a big breakthrough because machines had a big problem understanding how different things relate with each other, especially if there is a lot of text in between. For example, if I say he and then some words and then was talking about something, and the machine realizes here that he is an important part, and then the next thing, whichever I'm saying, isn't important, even if they are far apart in the text, because both of them are highlighted as important components, when we just look at those, we know that there is a relationship between these two. So because of trimming out or giving less attention to a lot of stuff, machines were able to concentrate on few things which were important and giving more attention to it. And that led to significantly less use of resources, because now you don't have to give equal weightage to a lot of every single word. But also, because now, let's say if I give you one page and you highlight there are 20 phrases in it which are important, now you can basically parallelly process those 20 phrases. Because in the sequence-based modeling, you cannot really parallelize things, because to process this word, you need to process the prior word and the word before. So things have to move in sequence. But once you break it down into components which are important, then you can parallelize it. So it took less compute power to process it. The results were better, but also now you can parallelize it. So on many fronts, this opened up a lot of opportunities of what machines can do. So this happened in 2017. And I know sort of vividly because I've been working in the space at that time. I hadn't started my PhD, but I've been working in the space. I was reading the paper, and when this came about, I still remember going through it, and I didn't fully realize what kind of impact it would have on the future, because now most of the models like BERT and GPT, which we use, they are all created because of this attention mechanism based approach. The other thing which was very important was that there is a thing which is called scaling laws. Scaling laws basically means that if you have more data and if you have more compute, then the ability of the AI model to perform better would logarithmically increase. So we know there is a clear correlation. In recent days, we have seen that there is a lot of availability of natural language data. An important project here is called Project Common Crawl. This is basically an open source data set where they have crawled the entire web and have the data available. So having that petabyte scale data available for being trained to machines, this is phenomenal, because if you look at it historically, the biggest source of information were used to be libraries. And the biggest library is Library of Congress, which had, I don't know, hundreds of thousands of books. But these common crawl-like projects, where they're crawling the entire web, this is thousands of times bigger than the entire information you have in Library of Congress. So this is basically a giant leap for humanity to consult, process, and learn from a ton of data, which was available to us. An important transition which happens was that previously, when we were using natural language processing, whether it was rule-based or it was using neural networks, most of the time the task we were giving it was that, okay, now you give a prediction whether, for example, if this text is spam or not, the example I previously gave. But then they thought, if it is becoming good at prediction, why not ask it to predict the next word? So if you look at, for example, ChatGPT or any LLM or any fancy AI you're using, behind the scene, it is doing a very simple job. A very simple job. Given a piece of text, what do you think is the next word? And then it spits out the next word. Then after you have the next word, then you try to predict the next word. And then you keep going and going. And this is what the machines are doing. And it is very interesting to note that if you have given it enough data to learn, and if you have enough compute power, then it can basically learn a lot. And even a couple of years ago, 2-3 years ago, Guardian published an op-ed article, which they said was mainly written by GPT-3. So it is very interesting that even 2-3 years ago, LLMs were good enough that with some human feedback, they were able to come up with an article which can be published in The Guardian, which is one of the best magazine and newspaper out there. So its human-like capabilities are very mind-blowing. And also, what researchers are noticing is that there are some emergent abilities which they have not anticipated machines to learn, and they have not given like specific data or examples or feedback. But as you throw in more data, machines are able to learn some very fancy things, and coding is an example of it. And also doing arithmetics, if you give it some mathematical problem. All those emergent abilities are something which LLMs are not specifically trained for, but they are doing an awesome job of it. So this transition from AI to NLP, and within NLP using deep learning or neural networks, and then using large language models, which were basically built upon that attention network. Basically the journey which we have traveled, which has enabled the current LLMs, whether it is ChatGPT or Google Gemini or Claude, all of them are using these attention-based networks and a ton of data to give you the answers which just look like human-level intelligence. So I covered this in the previous module, but still wanted to quickly touch on this. We know that there are 3 things which LLMs or AI needs to become smarter. It needs data, it needs compute, and it needs better algorithms. And in the previous module, I showed that the amount of data and compute and better algorithms we have is exploding exponentially. There's like this kind of exponential growth happening in all three of them, which means that in the future years, we'll see the intelligence the machines have also growing exponentially, not linearly. So that leads to a question of where are we heading? We already know that 2 years ago, Guardian is able to write an op-ed article with LLM. We know that about 3 years ago, I think it was published by Oxford. There was a research published by Oxford where they showed that it is when they compared the performance of doctors versus machines trying to understand the diagnosis on X-rays, it was equally good 2-3 years ago. And I just showed you that if you give a right prompt, AI can generate a video, like cinematic movie style video, which is very difficult to distinguish from something which is created by Hollywood. So this is where we already are. So where are we going? When I say that there is going to be exponential growth in future, where are we heading? So one thing which is becoming more and more obvious is that the future is multi-model, which means that machines not only will be able to take text input, they can also take audio input, which means you can talk with it. And 2 days ago, I think, Gemini launched this that now you can have basically video on and you can show it a video and also you can talk about it and it can answer questions based on what you're seeing in the real world. So multimodal, text, image, audio, video, all as input, all as output. This is what the future is going to be. Your model is not something you open a chatbot and you ask a question. It's something which is seeing what you're seeing and then basically giving you explaining to you whatever question you have. Meta has recently been spending a lot of money into getting those Meta glasses. There is like very seamless integration of camera and some AI capabilities so that whatever you are seeing, machine is also seeing. Whatever you are hearing, machine is also hearing. And then when you combine it with the intelligence it has and the kind of information it can provide you, not only in the form of text, but also the glasses would be able to talk to you. So you can basically hear in real life. They can also already, Meta glasses have this capability that when you're seeing something, for example, if you are in a museum and you're looking at different things, the glasses, when you look at an object, they add some visual clues to it. What does it mean when it was created? So it is basically, it is mind-blowing where we are going. Another thing, smarter agents. AI won't just be a tool, it will basically become teammate. And that means that for example, if you're doing a coding today, a lot of times I would have to like copy the snippet of code which I want to improve. Or if I want to write new code, I'll just go, for example, in Gemini and say, can you write this code and then bring it in. But it is already happening, but it'll happen more so that LLMs are part of your ecosystem. So they know your entire code base. If you're writing a book, they already know the entire book you have written so far. And then based on all that information, it will be helping you create more. So it's basically just like a teammate who is very familiar with all the context you need to further assist you. And that will significantly help. Also, AI will be everywhere for everyone. And the example I gave, for example, when you have that Meta glasses, or in a lot of cases, right now we have very giant LLMs which are very expensive to train and host. So you need internet connection to talk with those big, giant, large language models. But in future, we'll see these models will become smaller, and they will be specialized for specific tasks, which means it is like a very small model, which is hosted in your machine, but it is very intelligent for a specific task. That means that you can put it in any small thing. Even your small security camera could have an LLM of itself, so that it could distinguish what you're saying and do some fancy stuff. Also, trust and alignment. There is going to be more and more focus in how we use all this technology responsibly, because this is just like any other technology. It is, if not used properly, could be very dangerous. So when human beings had electricity, it's very powerful to change our lives. But again, if you don't use it properly, it's very dangerous. Another powerful example is nuclear energy. It's very useful, but also very dangerous. It can destroy whole humanity. AI is similar. It's very useful, but could also be very dangerous if not properly used. So we'll see that there will be more emphasis on how we can responsibly use this awesome tool and weapon we have just got. Towards the closing of this module, I wanted to share with you my personal first sort of aha moment while working with LLMs, and the context being I've been working on different kind of AI things since 2016, and I was on leave in Pakistan in October 2022. And before that, I had spent about 2 years working on models like BERT, which was state of the art back then, and I was trying to create a chatbot. And that was a very difficult task in, for example, 2020, because you have to use BERT, and then I was training it on company database, and then for each question I have to provide some training data on, if this is a question, then here in the knowledge base, this is the answer, and then trying to make it work. But it was very frustrating and very difficult. 2022, October, a friend texted me that try out this ChatGPT free version just launched. And I asked it a couple of questions like informative, what is the capital of this? And it was giving right answers. And then I said, okay, that's pretty good. That's pretty good. And then I started asking it some sort of philosophical question. What is the meaning of life? That kind of questions. And that kind of answers it was giving, and I could see that it is generating word after word, so I could see what is the underlying technology. I hope now you can also see what it is doing behind the scene when it sort of creates that word after word, and it looks like a wonderful answer. And that first experience of asking about philosophical question, and it giving a response, and then I asking a follow-up question, and then it again giving a response. I think that was very like a key moment I'll still remember, where I was sitting and what phone I was using to interact with it. And since I was trying to do the same thing before, I could appreciate that how big of a milestone it is for all of us, the whole humanity, that we have machines which are now intelligent at that stage. And this is 2022. It's been about 3 years now. And the kind of progress we have made in the last 3 years is also very impressive. So I am very bullish about the trend we are seeing. I'm pretty sure that we are going to see exponential increases in future as well. And this is something, if we use it responsibly and try to take good advantage of it, it could be a life-changing thing for all of us. Now, before we conclude this module, I wanted to share with you this good interactive timeline tool. It is very good that at a high level you can see that what kind of progress we made over the course of centuries. So you can see there is this timeline here, and you can see what the contributions of Ada Lovelace were with respect to analytical engine, Charles Baggage's work. We can see when the first computer was launched at University of Pennsylvania, all of that. So if you want, give it a try to see that how we have come across all these two centuries and what progress we have made across all these milestones. Awesome. I hope you enjoyed this module as much as I had fun recording it. Quick recap on what we covered, because we covered a lot. We first saw that how it had been a human fancy to create another species which is as intelligent as human beings. And we saw that that kind of vision even started like thousands of years ago. And then even in 1500s, we saw that people were talking about how they can create some sort of robot to help assist human beings. And then we saw that how NLP evolved significantly, starting from a rule-based system and then statistical approaches, which are also sort of rules, but a little more complicated, to coming to mimicking human brain of neural networks. And then how we went through the phases of AI winters, when for about 50 years, we weren't able to make much progress because we didn't deliver on the initial hype we created in 1940s and 50s. And still, the work of some people who were passionate and driven enough that they were able to continue the research, even when the world was sort of discouraging it, how that led to significant progress we are currently able to make. We talked about attention is all you need paper, that how big of a leap it was in the field of NLP. And I'm sometimes impressed by the title of this paper, because it makes a very bold claim that attention, as long as you have attention, that is all you need. You don't need the entire pages and pages of sequential data. You can basically pick some important words, and by giving the right attention to it, that's all you need. We also talked about how the convergence of massive data sets, GPUs, and new algorithms, when they came together, how they became such a powerful source of fueling AI we are currently using, and what is the trend? What does the trend look like? As we have more data, more GPUs, more algorithms, more compute power, and we can see that it is going into smaller multi-model future where there will be a lot of models integrated into our real life. And that is going to be a future where humans are basically cyborgs. We are basically humans whose whole world is aided and augmented by the intelligence of machines. So overall, very exciting world where we are heading towards. And I hope that this course takes you one step further into understanding how that new world works and how you can thrive in it. So that is all for this module. In the next module, we'll talk about the bigger picture of what are the different components of AI, and especially generative AI. How do they all come together to work on different components of intelligence we are seeing? And I'll see you in the next module. Welcome to the module 3 of this course. If you have made it this far, I really want to congratulate you, because statistically speaking, most of the people who start the course, about 10% complete the first hour of the course. We have clearly come much deeper into the course than 1 hour. So if you are still here and still learning, I really want to appreciate that fact that you are a dedicated student and you are much more interested and willing to learn than majority of the people, maybe 90%. So I really want to thank you for coming so much into the course. And now we are going to unpack a lot of details which we have captured previously at a high level. So far we covered why is AI important, what is generative AI, and how it is changing the world. We covered briefly the history of how we came here at this stage and where we are heading. Now, in this module, we are going to touch on what is the bigger picture. What are the different components of generative AI? How do they learn? So I'm very excited to go deep into this module and unpack a lot of details which we covered previously at a high level. So just to cover at a high level what we are planning to learn in this module. First, we want to again give you a little bit glimpse of what is generative AI, and then what are different components of Gen AI which are changing the world in terms of text, audio, video, and how we are sort of engrossed into these different manifestations and different components of generative AI. We'll cover why this matters, and then what is behind the scene functionality of these text, images, video creation models, and how they are impacting different aspects of our world. And most importantly, we are going to go a little beyond the buzzwords of LLMs and chat LLMs. We'll go a little bit into the details of grasping the fundamentals of how do they work, how do they learn. So this is going to be a little deep dive. I won't go into like much technical details or mathematical, but trying to build the intuition around what are the different components and how do they learn, and then how do they come together to basically transform our lives. So we have a lot of interesting stuff to unfold in this module. And with that, we'll go into the next lecture. Okay, so now let's look a little closely. What is generative AI actually? So we saw in the historical recap that we started with rule-based systems. Then we tried to come up with some statistical approaches about what is most likely to be the next word, for example. And then from there, we realized that it is very difficult to capture language with rules or with statistical approaches. So we need to mimic the functionality of human mind. So we then came to deep neural networks to mimic the functionality of the mind. And then we started feeding it data into sequence. For example, if it is a word, this is a cat, then we started feeding these into a sequential way into these deep neural networks. But still, with that, we were running into challenges. So the next step was to use attention into the important components. So now we say, okay, cat probably is the most important word here, so let's give it attention. And that we came to LLMs, large language models. So this have been our journey so far. And that led to us predicting the next word and actually start creating the word. So in generative AI, one, it generates. So that's why it is a distinct, more important component of overall AI. Also, it creates original content. And originality is the key here, because just trying to predict the new word is not something very new. Even in 1950s, we had Markov chains, and there we were trying to see that can we use our learning about something to try to predict the next word based on some text the machine has previously seen. So what they tried in Markov chains is that, for example, they will show the machine some data about kids' books, and then based on that, given a word or sequence of words, the machine will try to predict the next word. For example, if you say, okay, cat, what is the next word? And because the machine has seen some text, the kids' textbooks, it will say, based on that, cat, the word most likely is sat. Okay, if cat and sat, then what is the most likely word? On. And then on the. And then cat sat on the, what's the most logical next step, next word? It'll say mat. So you'll get a series of words like this, cat sat on the mat, because this is the kind of data on which you have trained. But this was very shallow. This output was very shallow, and once you see that where the conversation is going, it'll basically be going nowhere. You will have these strings of words together, but to get in a sentence, it won't just make any sense. So this was not new. We tried to predict the new words, the next word before, but the amount of data on which the machine was trained was not as much because we did not have enough compute. And the learning mechanism of the machine was not sophisticated enough to learn the nuances. But with this deep neural network, along with attention mechanism, now the machine's mind is capable enough that it can actually learn very sophisticated pattern. So now when you have this kind of advanced machine trained on much more data, you're still trying to do the same thing, trying to learn the next word, but now it is very intelligent. It looks into the context, and the word it is predicting next is just so much better. So this is all about generative AI creating original content, and it is very original. It can actually understand the patterns so well that the content it is generating is actually very, very good. And this is now becoming a digital creator, which is a creative partner for anything you're trying to do. I previously covered the example where The Guardian published an article which was mainly written by some large language models, generative AI. And this manifests that if machines can create so good quality that the article, with some human input, of course, can be published in top-notch publication like The Guardian, and this is 2-3 years ago, then what we can do in future, it's amazing. It is marvelous. So it can definitely create content almost as good as average person, but with a little bit more training, it is definitely going into much better territory. The other thing to highlight here is that since it is trying to predict the next word, the kind of variety it can introduce into the content is also very beautiful. For example, even if I am an expert poet, the kind of poetry I will produce would be very similar to the rest of poetry I've created, right? Because I'm a human and I've learned things in different way. But the thing with machines is that because they are trained on so much bigger variety of data and they're trying to predict the next word, their creation is similar to, you might have seen some examples where there are some poets, you give them a keyword and based on that they'll create a poem or they'll write a song. It is similar to that because you can give it a prompt and based on that it can go in totally different direction. So that opens up variety. So not only they are generative, but they are very, very creative in different ways, much bigger, much better than humans. And this means that you can basically use this power to interact with any digital information. Any person who is not like very tech savvy, doesn't know how to use computers, doesn't know how to use sophisticated smartphones, Now, this technology of generative AI, it is opening up doors for them that they can use technology even without being very good at usage of technology. You can just open up any Gemini, ChatGPT, anything. You can just ask them in any language the question you have, and then it tries to do that. The way I think about this is that in 1980s, we still had computers, but mostly you have to use command line interface to give computer commands. So you would open up a terminal, you would say, okay, do this, and then it would do that. So you need to learn a lot of commands, and kids or people who are not very tech savvy were not able to do that. But then the good thing about Mac and Windows computers were that they created a user interface. So now you have mouse, you have folders, you can drag, drop, click, and that just made the interaction with technology so much easier. And that led to a big improvement in terms of how many people were able to use computers. And this is the next step. Now you are even going away from mouse and clicking, and you can just talk just like you would talk to a human. And the beauty of this thing is that every human being knows how to do it. Because be it a small 3-year-old child to a 90, 100-year-old person who's not tech savvy, the moment you can converse with machines with language, that just opens up access to technology to everyone. And that is sort of the beauty of it. So now coming to the brief historical recap, we had the entire previous module dedicated to this. So I'll just very quickly touch on this. But as I explained, we started with rule-based, and Eliza, the chatbot, was the prime example of that. And then we came to statistical approaches, and then deep learning and attention networks, so we did all of that. The end result is that now when you ask machine cat, it is intelligent enough that it just doesn't know what is cat, that it's an animal. It is intelligent enough that it fully grasps the concept of cat, that what is cat, what does it eat. It has all that information. And it has understood it so well that if you ask it to draw a cat, it will draw a cat. A cat which it has not seen before. So the cat it will draw, it will create, it's not something it has previously seen. It understands it so deeply that it can even draw it. So that's how far we have come. And again, just to give a contrast of conventional AI or analytical AI to generative AI, in the analytical AI world, we were trying to classify things, predict things. For example, who is more likely to watch this kind of movie? And there are many other examples of that. With generative AI, we're trying to basically do the same thing by predicting the next word. But it can generate, and to generate, it needs to have a very solid understanding of how things are working. Just to illustrate things with an example. If, for example, you might have seen some competition shows, right? For singing, for baking, there are all sort of competition shows where there are some people who are trying to create stuff, and then there are people who are judges. Now, unless it is a competition about something which is very sophisticated, for example, if it is a competition about baking, then the audience, the people who are judges, they don't have to be a very good chef themselves. They can be ordinary people to be able to judge the quality of the baked product. So our previous analytical AI, it was at that level. It just has to be good enough to understand what is good, what is bad, so it can classify things. That is an easier task. But to be able to generate, you have to be on the other side. you have to be the baker itself, the person who creates. To be able to create new thing, you have to fully, deeply understand the thing itself. So that is why generative AI is so much powerful, and it is the next step in terms of where we were with the AI before. So with that said, now let's move into what are different components of generative AI. Is it just text, or what are some other things we are dealing with? So that's where we're going to touch next. Okay, so what is sort of the family or key components in the generative AI? Let's try to unpack them a little here. So to begin with, we have conventional large language models. This is the phrase which we have used so many times already in the module. I hope you sort of understand what it means. So this is basically very large models trying to mimic the functionality of brain. They have deep neural networks as well as the attention mechanism, just like humans. And then they are super smart because they are trained on very large amount of data, and they can, based on that, they can create text. Some examples are ChatGPT, Google Gemini, you have Claude, and there are many others. So they are very good at writing, summarizing, translating texts, etc. And the analogy of that is maybe a very well-read student who has read like hundreds or maybe thousands of books. So that person not only has a good grasp on some facts, they also understand the nuances of language, they know grammar, and even how different entities are related with each other. So this is what your large language models are. Now, the cousins of that are image models. And some examples are Midjourney, DALL-E. These are some examples where you can give text input. For example, create an image of a person who is in mid-40s, Caucasian, white male, feeling sad, standing in some surrounding, whatever you want to define it. And it can create those pictures. And you can also go the other way around. You give it a picture and you ask it to explain it to you. It can do that. So these are your image models. And they're also very powerful because they are trained on a similar kind of data where you went through the entire web and then you say, okay, this is the image and this is the surrounding text around it, sometimes image captions, etc. And then the machines learn the pattern of, okay, what does it mean if there's a mention of cat word around an image, and it has it. And once it has seen millions of examples of that, then it tries to develop what does cat mean. And then when you come to tools like this, and you should definitely try them if you haven't already, then you can ask it that create an image of a cat, and it basically understands what is a cat, what does it look like. And this is marvelous because if you take a step back, let's say if you do not have a human mind-like sophisticated machine to be able to learn that, it is almost impossible to come up with a list of rules to teach a machine what does a cat look like, because cats are small, cats are big, they are different colors. There's just so much variety. And the image of cat can be taken from different perspectives. It can be taken from top, side, left side, front. There is just no way you can create so many rules and define the rules in such a way that you are able to identify the image of a cat with some sort of tools. So this is what your image models are. They are very good in terms of capturing the understanding of what is the representation in picture of a text. Then you have generative adversarial networks, popularly known as GANs. So these are generative adversarial networks. And the way they work is, maybe let me begin with a brief anecdote of how Ian Goodfellow sort of discovered them in 2013-14. The story goes that this guy, a Canadian-based excellent researcher in ML, has written a very good book around deep learning. If you are interested in more, that's a good book, very good book. I would recommend. So this guy, a researcher about ML, had sort of a bar argument with someone, and with a lot of back and forth. After that argument ended, he had this thought that to be able to have an argument with someone and to continuously have an argument, you basically learn about the concept even more. For example, if I were to have an argument with someone that honesty is the best policy, for example. Now, I might have some idea that this is a reasonably good fact, but if the other person is trying to come with some adversarial arguments that this is not true or whatever, then to be able to defend it more, I have to go into more details and understand it even more. So the idea he came up with this is that how about to make our machine more intelligent? We create another machine and then let these two machines fight together. And this is where the adversarial networks part come in. And the way they work is that they basically create two machines. So let's say this is machine 1 and then this is machine 2. The task of machine 1 then is to create some art, let's say an image or a poem. It can be anything, some art. So this creates art. And the task of this machine, M2, is see if it is fake or not. So M1, machine 1, it creates some art. It gives it to M2. M2 says, no, your art is fake because I think this is the part I have figured out is wrong in your art. And then that feedback comes back to machine 1. And then machine 1 says, okay, so my art is identified as fake, which it actually is because it is not coming from human. Because of this, let me improve and create better art. So then it creates more art. And then it gets feedback on that. And this cycle of feedback, it's just machines. You can ask them to do it as many times as you want. And with time, what you see is that both these machines improve. M1 becomes good at creating art, which is very hard to detect if it is good, fake or not. And a machine 2, who is basically a judge, it also becomes very smart in detecting what is fake or not. So these two machines, as you sort of put them together to fight, with time they become very, very smart. And this is an example of reinforcement learning, which we would see that is another domain of machine learning. It's sort of out of scope for this course, but reinforcement learning has been a very phenomenal way for humans to teach machines, to basically teach anyone, right? This reinforcement learning, it stems from behavioral therapy, reinforcement learning. And the key idea is that how do you teach a human, for example, a baby, the moment they do something good, you reward them. This is how you train animals as well, right? How do you train a dog? You let dog do whatever they want to do. The moment they do something which you want, you just give them little reinforcement, some reward. And what you would see is that if you keep doing it, the dog or the child or anyone, they would do more of the stuff which they get rewarded for, which they get reinforcement for. So this is the same idea here. Whenever the machine gets a feedback that, okay, this time M2 was not able to detect I'm fake. That's a good thing. That means I should further go into that direction. And this is how we sort of put together two machines, try to learn together. And you'll see as you go into literature of AI, you would see different examples of these reinforcement learning. For example, if you want to teach machine how to play tic-tac-toe, this is the game where you do this. You One way is that you show machine a lot of previous games. The other approach is that you create two machines who play tic-tac-toe together against each other. And then you give them a signal, okay, this time you won. If you do make this move, you win. If you make this move, you don't move. You don't win. And you lose. And then you machines just play against each other so many times, 1,000 times, millions times, billion times, and then they become just so much smarter because they know, okay, what kind of move in what situation generally leads me towards winning. So same idea here. And because of this generative adversarial networks, we are now able to create art, which is very difficult to distinguish if it is fake or not. And that leads to dilemma of deep fakes. We are seeing them becoming popular, and we are seeing them becoming so good that it is very hard to distinguish. And that leads to an ethical dilemma, which we are going to talk more about in module 9 of this course. But GANs, or generative adversarial networks, are becoming so good in creating deepfakes that it's very hard to distinguish what is fake versus what is not. Which means there are images coming up of people which are fake, and you can create as whatever picture you want to create. You can even create the voice of a person speaking whatever you want them to speak. So it leads to big ethical dilemma, which we're going to further uncover in module 9. And this doesn't stop here. So it's not that you have LLMs, you have image models. There are many other generative AIs. Pretty much anything you can think of where a human has to generate, it can do that. So you have 3D rendering models. You have video models, voice model, music, poetry, anything, any form of art. Machines can now create. It can even create science now. If you ask it, okay, create some experiment. If I want to test this, it will help you do that. Machines are helping, as we covered in the previous module. Machines can now even write research papers about what we can do next, and then propose experiments with which we can validate those hypotheses. So any form of art, any form of science, machines are capable of doing it. How good they are, that part can be debated. But can they do it? The answer is like a very resounding yes. So that leads to the discussion of how do they actually learn about creating not only text, images, videos, poetry, 3D models, you name it. How do they learn to be able to do it? And that's what we're going to cover next. Okay, so now let's try to understand how do these large language models actually learn? And it is actually learning because they're able to understand like very nuanced patterns, just like a human tries to do. So let's try to unpack a little. How do they learn? So the one thing which we know is that very soon, I mean, actually not very soon, it took us more than maybe 100 years to figure it out, but we realized that we cannot go very far with rule-based systems. We also realized that even if we try to have like a simple statistical approach in terms of predicting, for example, the next word, like Markov chains, which I just covered, then we cannot go very far. And because the idea was to have human-like intelligence, this has been the gold standard. human-like intelligence, then it was always helping us to go back to how does human mind work? How does a human learn? And what we learned there is that humans learn because they have a brain, which is a machine which can process and learn patterns. So there you have brain, and then you have information. And if you have better brain, maybe like a high IQ brain, and if you have more info, then that leads to smartness. So the bigger the brain or the better the brain, the more smart you would be. The more information you know by reading books, having some actual real world knowledge, the more smarter you become. So smartness is basically a function of having a learning machine and data. So this is what we learn. And that's what we have been trying to focus our attention to for last many decades. We're trying to improve the brain by having these algorithms like attention mechanism and deep neural networks. And then we are also trying to feed in more information. And the idea is that we want to become as smart as possible. And we're trying to mimic the child-like learning. How does a child learn? We're trying to mimic that, so that one day we have a machine which can pass the Turing test, which I previously covered. That it is smart enough that it can create something that even a human is not able to understand, that if it is coming from a human or a machine. That's Turing test. And we want to get to that. And that's pretty much the entire focus of AI for last at least a century. And it reminds me of the alchemy moment. Chemists and humans generally have spent at least last 2,000 years, because that's where we have the literature, of this fascinating idea that if we can somehow create gold by using some chemical components together, if we can create gold, then that would be the ultimate success, because anyone who can use some lead, some carbon, etc., and then put them together into lab and create gold, that person would become the richest person of the world, like very fast. And this idea of creating gold is what is known as the alchemy moment. Many books written around it. Humans did not have any success with that. But pretty much any important chemical breakthrough you had, it came from those alchemists who were trying to create golds, because they very deeply studied all the naturally available material. They tried to create every single combination of them so that they could create golds. They did not create golds, but they uncovered a lot of other interesting patterns that significantly contributed towards the advancement of science. So that was the ultimate goal of creating gold. This is the ultimate goal of creating intelligence, which is just like human. And we are, since trying to create human-like intelligence, we go by having a machine and data, and that's what we are trying to basically train it on. And when you train the machine on some data, it then basically learns patterns. Again, the example is that if you train the model on a large amount of text, which we do, then it discerns patterns like, okay, if you say king and then you say queen, these two words are sort of similar. So it learns that king is head of monarchy, male, queen is female, similar concept. It tries to understand that if you say peanut butter, for example, and then jelly, these two things sort of go together because this is what people sort of eat during breakfasts. So it learns those patterns. And the word trained is important because you would hear ChatGPT, for example, or GPT in general. So what does GPT stand for? GPT stands for Generative Pre-trained, and then there is T stands for transformers. Generative because they generate. Pre-trained because they are trained on massive amount of data. And then transformers because they focus their attention networks and they focus on the things which are important. And because of these three things together, you have GPTs. And when you have chat GPT, that's something you can chat with. We'll come to what does the chat component is. But these are trained on massive amount of data. I talked about web crawl, that it is basically open source data where you crawl the entire web. Every single page on the web you crawl, and then you try to feed that data, big, massive amount of data, to these machines to be able to learn. Because we are able to feed unstructured data, non-labeled data, because conventionally we have to label the data. For example, if you are trying to teach machine which customer in a bank is more likely to not pay their loan, default on the loan, then you need to have some training data. So this is the customer information, defaulted or not, and this is the next customer, defaulted or not, and so on and so forth. And then you give that pattern data. It is structured, it has labels, and that's how machine used to learn. But now, considering you can just dump any information, text, images, video, on the machine, and you have enough compute that machines can actually process them, this is just opening up a lot of windows of opportunity. So text crawl, I talked about. It is so big data that even as of today, it is like hundreds of petabytes of data. So what is a petabyte? It's like 1000 KB is MB, not actually 1000, 1024. And then you multiply it with 1000, and then you get gigabyte. And then you multiply it with 1024, and then you get terabyte. And then 1000 times more, and then you get petabyte. So we are hundreds of petabyte. That means we are approaching almost zettabyte, because every single month we are adding about 3 to 5 billion new pages. Every single month, 3 to 5 billion new pieces of information added to that data set every single month. So this is how fast the data is growing, and this is how much we can feed into these models to be able to learn anything which they can. This is very fascinating. So once you feed that into them, then they learn a lot of things. They learn the facts. You can ask what is the capital of France. It would know that because it has seen it so many times in a lot of data. You can ask it about grammar. It learns how do you properly use grammar, and just like human does, not by learning rules, but actually seeing them, how they come across in practice. And they are trained, as I said, on billions of sentences. They have read like all the books. Consider a very intelligent man how many books can a human read in their lifetime? Even if they read one book every day, how many books they can read? Maybe thousands, 10,000s. But these machines have read like so much more. And because of that, they're like just so much smarter as well. And then it is not only constrained to text and books. We are going beyond that. So it learns objects, videos, images, descriptions, colors, styles, anything. It learns the pattern of all of these. And the fascinating thing is that when you give an LLM a picture, for example, it cannot see it just like a human does. For example, this picture, if I show it to you, you can see it's like a cut of watermelon. But machines see it as pixels, a series of 1 zeros. So here, for example, I've shown it's like maybe 1, 2, 3, 4, 4. It's maybe like 16 by 16 pixel, and then for each pixel there is a value. It associates a value to each color, if it is red, white, whatever. And then that information is what machine sees. So you see a watermelon, machine sees something like pixel number 0, or you want to say it 1, but because these are 0 index, so it'll say, okay, pixel number 0 is white. So 0 and then white, and then it's like maybe coded like FFF, and then pixel number 1, FFF again. And then all of this is basically binary. It is either 0 or 1, and then that is the input to the machine. And by looking at that input of 0, 1, 0, 1, 0, 0, 0, 1, and onwards, if it is able to tell that this is watermelon, this is very mind-blowing and very amazing. So I just want to give a little alternative perspective here, that there are a lot of people, even some very big AI researchers, who say that AI is actually not as smart as you think. And the term you would hear is that it is basically a statistical parrot. It has learned some patterns in the data and just tells that. It does not have human-like a conscious of what is right, what is wrong, what is the purpose of existence, etc. It does not have that conscious deep level thinking. It is just that it has seen patterns of, when you say this kind of thing, then the next kind of thing is something like this. And that is not actual human-like learning. It is just learning statistical patterns. And I'm amazed sometimes when I'm using any of ChatGPT, Google Gemini, Claude, whatever, that it actually come across as very, very intelligent person, as if I'm talking with someone who's expert of the field. And it does not really come across as sort of something which has learned statistical pattern. But the argument on the other side, and this is a very good book to read if you want to read more on that. The argument for the other side is that just like as we had ELIZA experiment, it was a rule-based chatbot. But when people interacted with it, they really got a feeling that they were talking to a human being. And what is happening behind the scene is that if a person is intelligent, then they perceive the other person as intelligent as well when they're having the conversation. It reminds me of a quote from Bruce Lee that a wise person can learn something even from a fool. So if you are wise enough, then you would find nuggets of wisdom even when you're conversing with a fool. And this is what is happening when you are talking with the LLMs. They are not as smart as you think, but because you can, even when they have put something in front of you and you can connect the dots and think that they are beautiful, even when what it actually said is not as intelligent, for example. So again, this is just basically an alternative viewpoint I wanted to present after praising so much the AI, that if you want to understand more, that this is a recent and a very good and very easy book to read to see that what the alternative perspective on that is. So with that, you have, I believe, a good understanding of how does large language models learn. But just to give a little distinction, when I talk about Claude or Gemini or ChatGPT, these are not just large language models which are trying to create new words, predict the next word. They are trained for chat. And what is it and how does it work? That's what we're going to cover next. Okay, so let's talk about chat LLMs, which is basically another advanced use of large language models, which we previously covered, who have the ability to chat. And let's see how they sort of learn that. So we start with an LLM which is intelligent enough that it has read a lot of books and all the material in the world, and they understand basic nuances like what is king and then what is queen and how do they sort of differ from each other. So it has a very good understanding of all of those. So that's your large language model. Now you want to further train it so that it can like converse and it can chat. And chat is a lot more nuanced and sort of difficult to train thing than just trying to predict the next word and trying to develop the deep understanding of what are the different concepts. Because in chat, it has to be a conversation style tone. So how do we do that? Well, just like we train an LLM by giving it a lot of data, again, we have to give some data, but we cannot just throw it at it like this is all the Wikipedia data and learn how to chat. We have to give it some examples. So an example could be that if we have to create, for example, if we wanted to train how to summarize, then we'll say, okay, this is the text, summarize it. And this is an example summarization. So we give it a lot of examples that if someone says, okay, go summarize this, then it has seen a lot of examples. Similarly, if we say, okay, this is the text, go translate. We have to give a lot of examples of translation. And by giving it a lot of these examples, now the base LLMs can now do these tasks because they have seen a lot of examples of that. So this is a high level of how these LLMs learn to do different things, and you can actually chat with them and ask questions, and it basically learns all of this. And a very fundamental concept here is, and you would hear this keyword, RLHF, basically, which says, RL we previously see, it is reinforcement learning. Reinforcement learning. And then HF stands for human feedback. This is basically the mechanism we use to teach LLMs on how to chat. And the basic idea is very similar to the one I previously showed of generative adversarial network. Because we want to provide feedback for reinforcement learning, we want to provide feedback to the machine, but we need to provide it a lot of feedback. And it is very difficult for humans to basically sit with machines and give that much feedback. So we create two models. One is an LLM. Let me create different color here. So this is an LLM who is getting trained. Training that LLM. And then we have a different LLM. This is an LLM, and this is a judge. And we try to train the judge because it is easier to train a judge to be able to distinguish between different outputs of an LLM and see which one is good. And we train the judge by some human input. So there is this human, which is giving it some examples so that LLM judge is trained enough that when the LLM training gives two output, if you ask it any question, for example, what is the purpose of life? So it gives you two answers, answer one, and then answer two. And then LLM judge, because it has seen some examples from human, will say, okay, maybe answer one is correct, better than answer two. And then based on whatever task LLM, which is getting trained, is tasked with, it will create more outputs. And then LLM judge would give it, this one is better, this one is not. And then again, we are essentially pitting these two machines together to be able to learn and work together to get improved as much as possible. And because LLM judge is getting continuously monitoring and feedback and more examples from humans, from these humans, it is actually going in the direction we want it to go. And the end goal of this is that we want to have a conversation which is natural in flow, which is very context-oriented, so that when you are asking a question, okay, what about these? It understands what does these mean. You are talking about something which you have talked previously about. So being context aware and being conversational in language, these are all the nuances which we are trying to teach. And again, these are the three core components of reinforcement learning with human feedback. So there are human rated responses, and one LLM keep creating the content, the other one keeps judging it and providing feedback, and based on that, the LLM which is getting trained become better and better with each example. And you might have seen it if you have used any other large language chat LLM like ChatGPT and Google Gemini, that even sometimes it gives you two responses for the same question you have asked. So if you ask it a question, it gives you two responses, and then say, okay, which one do you think is better? And then you pick one and say, okay, thank you. Because it is learning based on that. Same thing. It creates multiple options, understand which one is better, and then that is its learning process. So this is how they're trying to learn about how do they converse. So this ability to have a conversation is becoming the number one use case of these large language models. Because now you can have a conversation. It reminds me of a recent ad by Google Gemini. The way they are trying to present the application, which is Google Gemini, is more like a therapist, a friend, so that you could just turn it on and you can talk whatever you want. You can share ideas, you can get feedback, you can ask about any information. So that's becoming the number one use case as LLMs are becoming more widespread and powerful and popular. And the end goal of the chat is that it should be helpful. If they have any question, they want to summarize, translate, ask about any information, it should be helpful, and it should be safe too. Because as humans interact and share details, that information they share should be safe. It should be private. Also, the LLM, the chat LLM, should not say anything which is abusive. It should not give any recommendation which can hurt the person. So it should be safe. For example, if someone is having a therapy session that in my life is sort of not going in a good direction, the LLM should not give any negative suggestion like, okay, go commit suicide or something like that. So it should be safe. And then it should have coherent interaction, just like as you would have human, which means it should have some component of memory. It should understand what you talked about before. And even the new LLMs, for example, Google Gemini, etc., they want to personalize the content which you are talking about by getting more information about you from the chats as well as other data sources, so that when the machine is trying to talk to you, it is like very, very customized to who you are, what your current problems are, what you're currently doing. So that is the goal, and this is how these models basically get created. And they are very powerful. We will see some example use case of how these large language models, they differ and provide like much more value as compared to the previous statistical approaches we had. Okay, so now as you have hopefully developed some understanding of how do large language models work, what is chat, LLM, etc., I just wanted to share a personal anecdote, a little problem I've been trying to solve previously and now recently, and how does having these large language models help a lot. So the problem I was trying to solve is, for example, if you have a customer account information and your company sells to other businesses, so you have customer database, which has company 1 information, then you have company 2 information. This could be Coca-Cola, Amazon, Pepsi, whatever, and company 3 information, etc. And this is your customer's record. And now let's say your company acquired another company. Or let's say if you got some information which you want to pull from internet about other company details. But then in a nutshell, you have another data set which also has company informations. let's say this is a database which has, for each company, what is the publicly available URL or number of employees. So you have any kind of the data. It also has information about company 1, company 2, company 3, etc. And your goal is to basically join these two together, because then you can get more information, whatever this other data, this green data set has. Again, if it's becoming confusing, basically you want to be able to match two databases so that you could enrich them by for each company. So you can pull information from both these database sets and merge them together. Now the challenge here is that, let's say if you have in the red database, you have company name as Coca-Cola, and in the green data set you have Coca space Cola, and then you have Inc. Now these two won't match on exact string match, so you have to do some stuff to be able to match it. And this is a thing which I worked on in 2016-17, and I created a lot of like rules and stuff around removing the spaces, making everything lowercase, removing important, like insignificant words like ink, but then there are so many variations of it in different companies, different countries, and then how would you know which one is this? For example, it could be the Coca-Cola Inc. in another database. So removing all those words, standardizing them, it was becoming a big, giant list of rules, which I had to sort of teach machine to be able to link these two databases together. And then there was even bigger problem of, for example, if you're talking about a subsidiary, because I think, let's say if, I think Fanta is, if I have somewhere the mention of Fanta, and then it is Coca-Cola on the other side. Coca-Cola owns Fanta. How would you know these are the two sort of same companies? Still, you cannot solve it for 100%. But now with LLMs, I can just ask it, hey, this is the Coca-Cola and this is Fanta. Are these two companies together or not? And it is able to do it. How? Because it has seen so much data already. It knows the language patterns. It knows the information about the companies, that Fanta actually belongs to Coca-Cola. And what is Inc. is not important word, these not important word. This is where it should give attention to, again, attention mechanism coming into picture. And without any rule-based defining, you can just give LLM, okay, this is, these are two companies, what do you think they are together or not? Or given this company and these list of candidate companies, do you think it matches to any one of them? And it does a fantastic job. So this is just an example use case which might not be obvious on how these LLMs can help you solve so many problems in so many variety of ways. Okay, so coming towards the closing of this module, I want to really encourage you to have some sort of hands-on activity and engage with some LLM. If you have not already, you should definitely use Google Gemini, ChatGPT, whatever, they're all free. They are extremely useful. And to take it even one step further, try to use some video generation LLM. I showed you an example of Google View in which I tried to create a woman who's trying to look at baby shoes and trying to list them it on phone. It was very mind-blowing. So try to see what you can do. There are many LLMs which let you do that. There's Adobe Firefly, Google View, which I showed. OpenAI also has Sora. So see what you can try, and try to interact with them, give them some prompts, and that might not be like useful for you to like actually do some project, but it will show you that how smart they have become, in understanding what you mean, right? So if you give it instructions, it can actually present that in video format, for example. This is mind-blowing. And B, it is becoming so much good at creating fake art which looks natural that the output video, in this case, if you were to show it to some friend and ask, is it AI created or not? It is highly likely they will not be able to tell the difference. And that is thanks to generative adversarial network. Because our LLMs have become so smart at fooling others into thinking that the fake art which they have created is actually real, that the art actually looks very, very real. So this is an invite for you to basically try any of these to see firsthand what these large language models are capable of. Okay, so that brings us to the end of this module. I hope you had a good time learning a lot of interesting stuff. So what did we do? We covered different family elements of these generative AI landscape. We covered text-based language models. We covered digital artists like image models. And then what is the unique structure about GANs? How can we basically put together two machines and then ask them to fight with each other so that both of them can become smarter with time? And how that's so basically a very cool technique of reinforcement. And then what does the learning process look like? So we saw that how they are trained on massive data sets like a common crawl, and then how it is able to identify different patterns through conscious understanding of going through this massive data set and understanding, okay, what does this thing mean and what is associated with another thing. For example, if you say, okay, mic and camera, it understands that these two things sort of go together. So how does it able to do that? Then we talked about chat LLM, which is becoming the number one use case of these large language models. This is how they actually become very, very useful. Before chat GPT was launched in 2022, end of 2022, the initial versions of GPT, which is the underlying technology, which is the underlying LLM, it started around 2017, 18. So for 4 years, this technology was there, but people did not fully understand the usefulness of it. Only when they saw the chat GPT, it sort of took the world by storm. And then people realized, okay, this is like a very mind-blowing thing, an innovation. I shared with you my personal experience when I first used it. Being a person who's been working in this field, I was totally amazed. So we talked about chat LLM, how we got there, how they are trained, why they are different. And then we basically laid some foundation of their learning mechanisms, and then what are the core concepts like reinforcement learning, like RHLF, which I previously covered. And this foundation which we have built will help us go into the next modules where we'll further sort of go a little bit into details of how you can use these LLMs for some advanced use cases. So thank you so much for staying with me throughout so far. I hope what I've covered so far is interesting and valuable. And what we are going to uncover next is going to be even more useful, hopefully. Thank you so much. Welcome to Module 4 of this course. So far in the course, we have built around what is AI, what is GenAI, what is the history of it, and then we covered about what are different components or aspects in which generative AI is becoming part and parcel of your life. It is like base LLMs, then you have chat interfaces with them, and then how they are even useful for creating text, and how they are even useful for creating images and videos and a lot of stuff. So we saw basically the usefulness of it. Now this module onwards is how you can actually use them to get the maximum value out of this greatest invention of the modern day, which is going to transform our lives in future. So the next couple of chapters, the next couple of modules are basically about how can we extract the maximum value out of it. What is the overview of this course? First, we'll understand a significantly important component of how do we use these generative AI LLMs. Prompt engineering. What is prompt engineering? What are the effective components of creating prompts which actually work and deliver value? Then what is at a deeper level anatomy of a great prompt? Why these prompts are important, and then how you can basically interact with AI using these prompts to get precisely the information you want out of them in the way you want the information to be presented. So this is what this module is going to be about, and I am really excited on what we are going to uncover here. So before we go into more details, again, like a very high level, very quick recap of what we have covered. So we have covered about large language models. We know they are basically textual brains, but they are not a small brain. It's like a very, very big brain who have been exposed to a lot of information to mimic human-like intelligence. And these are giant brains. A little interesting aspect here, which I didn't cover previously, was that since we are always trying to get as good as human intelligence, and we talked about there are two components. One is brain, basically processing power, and then we have information, which is basically data. So for information, we have exceeded how much information a human can get. Machines can get so much more information. The bottleneck here is the processing engine. Without going into too much detail, but human minds have about 100 trillion synapses. So we talked about neurons and how they are connected together. Humans have 100 trillion plus synapses. This is just a rough estimate. The latest LLM has 1.7 trillion parameters. So for analogy, we can consider a synapse in human brain to be equivalent to a parameter in an LLM. And the thought process is that once this 1.7 trillion becomes 100 trillion, then it still might not be like fully equal to a human brain, but it will be sort of approaching that. And at the speed with which this is progressing, it is estimated that maybe in the next 3 to 4 years, we'll get to the 100 trillion. And if the brain of the LLM is as good as human, and then the information it gets is even much more better quality and much more than what human can get in their lifetime, it is very possible that we sort of see similar kind of intelligence as humans. Anyway, coming back to the recap of LLMs. So we talked about vast textual brains. We talked about how they became powerful by just focusing on relevant information. So we talked about attention mechanism, and that is what in GPT's transformer is about. It is about attention mechanism. G is generative, P is pre-trained, and text is attention-based transformers, which is focusing on relevance. And then we talked about how did we train the chat LLMs. So we started with base LLM, and then we trained them further on chat, like question answer capability. So this two-step process made us made us available the chat LLMs, and they look pretty powerful, pretty useful. And how do we get the maximum value out of this? This is what this module is about. Okay, so what is prompt engineering actually? It looks like a fancy word, but what is it actually? It is basically asking the AI or guiding the AI to generate the desired specific output effectively. That's what this thing is about. How can you guide an AI, which is consider it a very intelligent, very well-read student or intern? How can you guide them to get the information you want out of them in the desired format? And the key goal here is that you want the information which is accurate, which is relevant, and the quality is also good. So how can you basically get that? This is what prompt engineering is all about. Fancy name, but it is not very different than asking. It is actually not very different from good communication, because when we were taught the principles of good communication, and there were lessons about 7 C's, that how you should be concise and concrete and all of that. All of these things apply. The beauty of LLMs is that the way you communicate with these machines is the way you communicate with other humans. So how can you be more specific and get the output in the right format? Why it's important? Well, we established one fact, beyond the shadow of doubt, that AI, and especially these generative AI, are very, very, very powerful as of today. We also established that they're going to be much more powerful, much more pervasive in future. So if you have some knowledge on how you can use them effectively and get the maximum value out of their strengths, then you are in a very powerful position. And there are different ways which we are all going to cover in different modules. So we'll go through how do we use RAGs and how do we use fine tuning, all of that. But the thing which is most important and which yields the maximum output is prompt engineering. And this I'm telling you from personal experience, because I have actually competed on some world-class generative AI problems with teams where there are other teams competing from Harvard and Stanford and Google and all of those. I've actually competed in those competitions for LLMs. And what I've seen is that the thing which moves the needle the most is good prompt. You could have better RAGs and you could have better fine tuning, of course, but the thing which with minimal effort, so 10% effort and you got 90% result, that is prompt engineering. You don't have to write code. You don't have to have very fancy GPUs so that you could fine tune your LLMs and any other building like a RAG pipelines. Nothing is more valuable than better prompt. And the good thing is it doesn't require any effort. You don't need any technical sophistication to be able to write better prompt. Just some common sense and some basic tips which I'm going to share in this module. And nothing here is rocket science. I remember when I started using Google search, maybe like 23, 4 years ago. So the way I would, and a lot of other people were asking Google, is that, for example, if I want to say, we want to know what is the capital of France, then say, okay, we go on Google, we say, what is the capital of France? And then we'll get some results. And this is like 24 years ago. Even Google was not like sophisticated enough that it can give you the answer currently. It does that. But then I read an article, how to effectively use Google search. And there I came to know, okay, so if you give a statement like, what is Google search? The first thing Google does is that it eliminates some of the redundant words like in and the, it removes those words. And then what it does is that it takes those keywords and it finds the presence of those in other different articles and websites, and then it ranks it and it gives you back results. And then there are some other small techniques, like if you put quotation marks around something, that it finds the exact phrase, otherwise it tries to find even similar phrases, and you can use and or. Anyway, it was a short article, took me 5 minutes to read. And from there onwards till today, the way I've been using Google has been remarkably different than what most people were using, at least back then. And the kind of return on investment on reading that 5-minute article, it was just so much beneficial for me. I hope that this module might take you an hour to complete, but it'll be equivalent of that article. And by understanding that how do you use prompting effectively, you can get the maximum value out of these AI systems. So the analogy for prompt engineering is that if you have to ask for some task to an intern who is very smart and knowledgeable, but still an intern, then how will you do it? It boils down to effective communication. And what is the relevance for today? Well, interesting enough, and you can search for these stats independently. I would encourage you. Prompt engineerings are earning 62,000 to 136,000 plus per year. And these are two very reputable sources. It's very interesting because to be a prompt engineer, you don't need anything besides common sense. It is a fancy word, prompt engineering. There is nothing engineering there. It is basically good communication, and you just have to write something, which is an ask. So why are these people getting so good salaries? One explanation is that think again about when cars were invented. There are automotive engineers whose job is to create cars. And then there are drivers. Drivers don't know much about how the cars are invented or what sort of the latest tech. They just are a good user of this technology. And they help others use that. So if an automotive engineer gets some salary, which is definitely very high, a driver also gets a salary which is not equivalent to a salary of an unskilled worker. So basically, this is, even the task is easy, it is useful. That is why people are getting good salaries. So if you have a domain knowledge, regardless of whatever domain you have experience in or interest in, and then you have good knowledge of prompt, and maybe some other state-of-the-art AI, what is available, that in itself actually makes a very good profession nowadays. So this is very interesting. So now we have defined what is prompt engineering. Let's go into understanding what does the anatomy of a good prompt looks like. Okay, so what does an anatomy or structure of a good prompt looks like? Well, again, nothing but common sense. First, you need to be very, very clear on what kind of task you want it to achieve. If you want it to create a presentation for some executive thing, tell it exactly what it is. Give a context that I want to create a presentation for executives for this kind of use case, blah, blah, blah. Explain, be clear, be concise, and then be specific. Don't leave any information just because you know it doesn't mean LLM also knows it. And again, this applies to any human communication too. Try to be specific, try to be clear. Don't assume any pre-existing knowledge. Try to give as much information as you can. Give examples so that it understands. Give context so that there's no ambiguity and things are clear. Very, very common sense. Define audience. Again, going back to the example, if you wanted to create a presentation which is aimed for executives, tell it that the audience for this presentation is going to be executives who are busy and who have this kind of prior knowledge, so that when it is creating an output, it is aimed for a specific audience. So define it. Don't assume existing knowledge. Set persona. A very simple thing, but again, I've seen it personally to be giving very good results. Just in the beginning of the ask, tell LLM what persona or what kind of person it should think of itself when it is creating the answer. For example, tell it, if you are an expert dog trainer with 15 years of experience. So that's like, it orients it in the very beginning. You are a dog trainer with this much years of experience. Then you have an ask. So since LLM has like a lot of knowledge about a lot of fields, when you sort of, in the very beginning, guide the conversation towards, okay, this is what you are, then anything which comes out of that is very good. So small thing, but huge impact. Tell it what kind of format output you want. You want it to create a slide with bullets. How many bullets? In which format? You want it to create a paragraph. How big of a paragraph? What should be the difficulty of reading? What kind of technical words it should use? Again, ties back to defining your audience, right? If you want it to be some code, some JSON, etc., tell it what kind of output you want, so that it doesn't just give you like a long explanation and something. It is in the format which you can use. Again, an interesting example of defining the audience is that generally when I'm trying to understand something, I just give it a prompt. Okay, you are an expert, for example, mathematician. Explain to me what is a Bernoulli equation, for example, and explain it in a way that you would explain to a fifth grader, for example. And that way, you don't get like some complicated equations out of it. You get like a very simple to understand, intuitive explanation. Okay, so we covered format, output. Use good delimiters. Very interesting and very important. An example is that whenever you are trying to give LLM something and you want to put in another thing, clearly divide it. Let's say if you want, say, how can I improve this sentence? Right? So if you give it and then you say some sentences, together we stand. So now when LLM looks at this together, it doesn't fully understand. I mean, it would, but still you don't want to leave things on chances. That's the thing. So you say, okay, how can I improve this? And then this thing, which is on which you want feedback, should be separate. So the way to go about this is that you say, okay, how can I improve? And then you add a delimiter, separator, clearly. So in this case, you can use anything. People use pipe symbol, which is like this, like straight line. People use quotation marks. The thing which I like the most, and it is since a conventional software engineering practice, that's why LLMs, being a program itself, is very good at understanding, is 3 quotation marks. So you have quotation mark, and instead of 1, you use 3. So I use 3 quotation marks as a delimiter, and then I give it an example. Together we stand, etc. And then you end it. So now LLM has absolutely clear knowledge that this is what you want, and this is what an example output is. And there are cases where you have to feed in multiple things from outside. For example, say, how can I improve this sentence? And then again, going back to, this is the feedback I have received so far. Right? So you tell it what is the feedback you have received so that it is not only improving it is improving it based on that feedback. And again, this feedback should be separate. So again, you add 3 quotation marks. And then you put the feedback, and then you put the 3 quotation marks again. So now LLM has no problem understanding that this is what you originally wanted. This is the target sentence. Now this is, again, some instructions, and then this is the feedback. So dividing it, everything, 3 quotation mark separators, new lines, it helps it distinguish between what you are asking, what is versus this is a different input which it should process. So that is basically high level, very easy to use, some tips you can use to improve the effectiveness of prompt. Next, we are going to look into some other techniques which you can use to further improve them. So the other 2 biggest levers you have for creating and improving some very sophisticated, very good prompts are providing good context and providing examples. Context is important for any ask, right? Especially for LLM, it has a lot of knowledge, but it doesn't fully understand your question and why you're asking it. Again, going back to the example, if you wanted to create some slides for some executive about some business problem, give it as much context as possible so that it understands the full situation before it starts creating the answer. So background information as much as you can, this is going to be helpful. And the next thing you have to do is provide some examples. And people use very fancy terms for these. So you would hear these in different AI literature: zero-shot learning, few-shot learning, few-shot examples. It's like these are some jargons to make the conversation look fancy, just like prompt engineering. There's no engineering in prompting. These terms are also just fancy terms to basically illustrate a very simple example. Zero-shot examples, zero-shot learning is basically zero example learning. One-shot learning is basically one example prompt. Few-shot learning is basically a few examples prompt. So this is what all it is. Generally, it is suggested that if you wanted to create something, you can have established a very basic baseline by giving it 0 examples. So for example, create a slide on this in this format, 5 bullets, for example. You don't give it any example. Some other example could be that if you want to create a prompt which suggests you a dish you can eat or try today, then you say, okay, you give a relevant information that you act like. So this is what the prompt would look like. So you define a persona. You are an expert chef who has deep experience in different kind of cuisines and what are some important and good dishes for each of these cuisines, etc. So you define the context, and then you say, okay, suggest me an Italian dish, and then it will give you some output. Now there are no examples in it. Now if you want to improve it, then you would give it an example. A one-shot learning would be that you give one example, that you are an expert chef with a lot of experience, and then your task is to suggest a dish I can try today, and then you give it an example. For example, if I say, give me an Italian dish, you suggest me pasta, something like that. And then few short examples would be, if I ask for an Italian dish, you give me this. If I ask for an Indian dish, you give me this, etc. So more examples, more context, generally the better the outcome is. The good thing about few short examples is that you can define the nuances of most real life things by giving different examples of different variety of problems. So then it further understands that how it can come up with an output which is acceptable, considering all these scenarios. And then the quality of the examples you provide is of paramount importance. The better quality example you give, the more nuances they capture, the better it is. If you give it very simple examples, don't expect it to perform very well on complicated tasks. So better examples, better output. And then iterate. And this is just a one line here, but this is hugely, hugely, hugely important. Don't expect the LLM to give you the right answer in the first place, in the very first iteration, the very, very first attempt. The reason some people are able to get very good output from LLMs is because they have to go through the iterative process. An example I would give is that if I say, okay, write a book on this topic, which I have never heard of, quantum physics, and it will write a book. I can say, okay, it should be 250 pages long. It should be for, young grad students, etc. It will create a book. But what would make that book actually useful and usable and interesting is the iteration process. And to be able to go through the iteration process, I need to know something about quantum physics. And I should know something about teaching techniques, etc. And that is what distinguishes the people who are pros using AI versus anyone who think that they can, just because they have access to LLMs and can create quality output. I can ask LLM with no knowledge about script writing, write me a script for this movie, this kind of movie, right? It'll write a script. But that script would actually be a piece of garbage compared to someone who has like a very deep expertise around script writing, who have been doing it for a lot of time. Because then they can ask about iterations. Okay, you missed this. Okay, maybe this character looks weak and whatever. So based on those iterative improvements, you can create something which is marvelous. So whatever you're doing, make sure that you refine it based on the existing knowledge you have. And that's where you marry your expertise with the power of AI, and that's where the magic happens. Okay, so coming to the common pitfalls, which a lot of common problems I've seen people make and how you can avoid them. This is basically a flip of what we previously covered in the last two slides. Basically, don't make silly mistakes when communicating with machines. Don't use vague language. Be specific, be clear, be concise. Don't give it overly complex tasks. Try to break it down. And this goes in hand with this last bullet, which is don't ask it to do too much stuff in one go, right? So divide things. Again, going back to the example of writing a book, if you wanted to write a book on quantum physics, don't just give one vague answer. Okay, I want to write some book on quantum physics and then create it. Go step by step. First of all, what should the book be about? If you want to brainstorm. So that is going to be one conversation. Then what should the outline look like? Just at a high level. You're defining just the chapters. Then once you define the chapter, then the next conversation is for this chapter, what are a high level things you should be covering? And then for each of these, there will be iteration. So it says, okay, you should include these 4 things. And you say, okay, now you should maybe include this thing, leave out this thing, rephrase this thing. So once you have iteration, then you say, okay, in this book, in this chapter, for this particular thing, help me write 3 pages. And then there'll be some iteration process on that. But this is how step by step you would deconstruct the big task of creating some quantum physics book. And then you actually write something which is useful. And machine is capable of doing that. Don't ignore iterations. it's very difficult to that the machine will give you something which is of usefulness right off the bat in your first attempt. You have to go through some iteration loops. Do not assume any knowledge. AI has a lot of knowledge, but it has a lot of knowledge about a lot of things. So it don't assume any knowledge. Even if it has some knowledge, it'll be helpful if you are clear on this is what your piece of knowledge or this context knowledge is. So give as much knowledge as possible, and don't forget to ask it and tell it that this is what the intended output should be, right? If you want the output to be 5 bullets for an executive presentation, or any other 2 paragraphs, 3 pages, tell it what output you want, in what format you want, so that the results are in the shape and form you want it to be. Okay, so now as we have covered some of the basics of prompt engineering, let's quickly touch on some of the advanced techniques. So the first technique we should be aware of is chain of thought prompting, chain of thought reasoning. And the basic idea is that you first of all break down different components of the task in the step of prompting. So that you say, you do this step and then this step and then this step, and for each of these you give examples. And then you ask it at the very end that think step by step, or do this and then this and then this. And this act of forcing it to think about something before it gets to the output, this gives very good results. For example, if you are trying to write a chapter on quantum physics, which is aimed for, let's say, first grade, they're aimed for grad students, then you can give it a lot of instructions about how to write the chapter and what are some examples, etc. But in the very end, you can say, okay, first think about what is the existing knowledge of a grad student who is enrolled in physics course, and then write this chapter. This act of forcing it first, that it should think about what is the existing knowledge it can assume for a grad student who is enrolled in a physics course, that helps it write a chapter which is not assuming any prior knowledge and is grounded into and is building on top of what can be assumed as the pre-existing knowledge for a grad student. So in a lot of cases, you can ask it to, in the very, very end, think about this and then this and then this, and then give the output. Even when you do not have any clearly laid out steps, or it is becoming difficult for you, just say, think step by step. So that when it's going through the answer, just adding this line, think step by step, it improves. And this is called chain of thought reasoning. The next thing is ask it for self-correction. There's a fancy word for it, reflexion. AI agents, will briefly touch on that at the very end. But the basic concept is same as we saw for GANs, generative adversarial networks, or other RHFL. You have one machine which creates the output. You open up basically a new chat, and you say, okay, this is the output of this machine, first machine, and then I want you to critique it. And then it will provide some feedback, and then you go back and say, okay, this is your feedback, improve it. And by using this sort of cycle, you can improve the output significantly. So you are asking an LLM to basically critique itself and then improve its output. Meta prompting is at a high level, even higher level than this. So you ask an AI1 system 1 to write a prompt for a task, and then you ask the other system to provide feedback on that prompt. So you are not looking into the detail of the answer, you're just improving the prompt in the very beginning, which is an easier task to do. And once you have a good enough prompt, then logically, if you feed it into LLM, the output should be good. So this is meta prompting. You will asking machine to write the prompt and improve itself. Then there is contextual decomposition, where you are basically, you are providing the overall task, writing, for example, the quantum physics book, or creating a presentation for some busy executives about some business problem. So you are creating, you're telling it the context, and then you're asking it to basically decompose or create the breakdown of all the things which you would have to do to be able to successfully accomplish that task. So that is the part of decomposing something which is very complex. And then controlled creativity. You can ask AI system to basically come up with a lot of imaginative answers for something, even speculative ones, but ask it to label whenever it is creating some speculation. And by forcing the AI system to create so much creative outcomes, you would be surprised on how many different ways the same thing can be thought about. And that goes into multi-perspective views as well. If you are trying to think about something or argue about something or come up with logic for something, there are just so many perspectives which can be taken. Every human being has blind spots, which means we don't know about the existence of even certain perspectives. So here you can use LLM to say, okay, think about this problem for as many different perspectives as possible, and that'll give you a very wide flavor of different views, which you can then further narrow down and then take the next steps based on some views which you have picked. So these are, again, at a high level, some advanced techniques. Again, there is a lot to unpack for each of these, which I'm not planning to spend the rest of the course on. But if you are interested in any of these, you can definitely Google search and you'll find plenty of material. So there are different tools which you should be familiar with and utilizing as you're trying to improve your prompt engineering skills. So first of all, you should be using some sort of platform which allows you to test different prompts. You can use OpenAI's platform or Google Gemini, whatever. Claude also has an excellent LLM which you can play around. But pick a platform, try different prompts for the thing you're trying to accomplish, so that with more practice, you actually become better at it. Iterative testing. The moment you start experimenting with some prompt, you'll realize the deficiencies in the output, and then iteratively try to improve. Try to adjust the settings. This is a little bit more advanced, but one setting which you should definitely play around with is the setting of temperature. What it basically means is that, as I explained, that what these LLMs are actually doing is predicting the next word. So if you say cat sit on the, and then it is trying to predict what is the next word, it will have, based on the patterns it learns, different candidates. For example, one is mat, the other is sand, the third is couch, for example. Then for each of these, there is a probability assigned to it, that what is most likely reasonable word to be used in this context. So let's say mat is 70% probability that it is a reasonable word, sand is 50%, and then couch is 40%. When you set the temperature to 0, and temperature here basically means how much variety you want in the output. When you set the temperature to be 0, which is no variety, it will always pick the most likely candidate here. But as you increase the temperature, it will force the machine, the LLM, to pick other top candidates as well. So one time you run, it might yield the word mat here, but the next time it might use sand, and so on. And by introducing some more variety, you would see that the LLM's output will be much more creative and unique, and will be going into different directions, which would be very interesting. So play around with these. Version control. Some advanced LLMs, and especially as you go towards using them programmatically, for example, using through LangChain, etc., there are some prompt version control libraries which you can use. But at a very basic level, just create a Word document, for example, on what are different prompts which you tried and how you can improve them over time. Keep track of that. And also generally having sort of your own prompt library is helpful, because for the same task which you have to do again and again, you can use the same prompts. The other thing is seek feedback. You can get some feedback from peers. But the best part of living in the world we are living today is that you can even use AI to get some feedback on the prompts you have written and see that what have you missed, and based on the output or based on the feedback from AI system, how you can improve your prompting techniques even further. And then, just like anything, A, the more practice you do, the better you'll become. And B, this is a very rapidly evolving landscape. Some of the things which I am sharing here might not be relevant 3 months, 6 months from down the line. So be on the lookout for what is the state of the art in terms of what are the new techniques and what are the new AI models you can use, and how you can prompt them more effectively. This is a very, as I said, rapidly evolving landscape. So keep an eye on what is the latest and the greatest out there. And just by using them, you can be very efficient compared to the rest of the folks who are not as caught up with the latest advancements in these AI models. Okay, so we covered a bunch of things. Some of them advanced, some of them basics. You might be feeling a little bit overwhelmed the next time you are writing a prompt. You might actually be becoming very confused on what are all the things you have to do. So here, I just kept in like 4 things. If you are using that, I think you are getting a lot of value out of the prompts. So to get the maximum value out of LLMs with 10% of the effort, which is prompt engineering, you can get 90% of the results. Within prompt engineering, these 4 things are the 10% which gives you 90% of the good results. So the first thing is defining the persona. Again, if you want LLM to create a presentation for executives, tell it that you are someone who has great experience building presentations for executives. If you want the LLM to write a book on dog training, tell it that you are an expert dog trainer with a lot of experience writing books, etc. So define the persona, very first thing in the beginning. And since these are generative models which generate something before what it has previously seen, just defining it in the very beginning, if in the very beginning, when you ask the question to LLM, it has no idea what it is about. So by defining the persona, you basically orient it in a certain way that you are this, then everything else is going to be around that. And that helps. One line of persona defining helps a lot. Second is just ask it, think step by step at the very end. It takes like 4 words to write. Ideally, you should tell it more like what are the steps it should be thinking about. But if you want to keep things simple, just add think step by step, just add these things. Effective use of delimiters. I talked about my favorite delimiter being 3 quotations marks. So use that. It's simple. It clearly differentiates what you are saying versus what is some input you want to provide to that LLM. And then my favorite one about providing as much context as possible. Sometimes we assume knowledge. Sometimes we forget about what is all the information we want it to know. So what I generally do is sometimes I ask, okay, so this is what I want you to do. Ask me any questions you have before proceeding. So then LLM defines the holes in my explanation and in my context, and they say, okay, tell me more about this and then this and then this and then this. And then when I am answering those questions, now the context is much more complete for the LLM to give back the response and the answer. Sometimes it just asks so many questions that it becomes like look like another task. So in that case, I sometimes restrict it. Okay, ask me up to 5 questions so that you get more clear. So that I am not like spending the rest of the day writing the answers to its questions. So this really helps LLM have more context available so that it can give you better responses. Before I conclude this module, I wanted to give a little hands-on food for thought exercise for you. So fix this vague prompt. So the prompt is, tell me about dogs. If you put this into LLM, it will give you a lot of response, maybe a very good response. But it is very vague. You should be defining some more specific things. For example, what is the task? Should it compare some dog breeds or dogs versus rest of the animals? Should it explain what are the dogs and how do they work? Do you want to list specific features, etc.? Also define what is your target audience. Do you define and explain what is a dog to a child or a veterinary student? Because a veterinary student might want to know details about anatomy of dog, etc., whereas a child just wants to know what is this animal about. Very different explanations for two different, very different audience. What is the format you want the output to be? Do you want a bullet points? You want paragraphs? You want to write a book? You want to write a chapter? What do you want this to be explained about? And then what should be the persona of the AI which is explaining this, defining that? So think about these things and how you can add these to a vague prompt like tell me about a dog. And try to do a contrast of give LLM, tell me about the dog, and see what is the response. And then when you add these things, and you are a little bit more mindful of what are the things you have to add, see how much better the response becomes. Coming from the same LLM. Again, it's just the art of asking gets you like 90% there in terms of getting the information you want. You don't have to fully rely on fancy techniques like fine-tuning and RAGs and all of that. Just by being more effective in your ask, you can get a lot of power, a lot of useful information out of these LLMs. So hopefully this module was useful and it gives you the similar kind of advantage as that 5-minute article I read about how to effectively use Google search. So just to quickly recap the things we covered. So we covered about the fundamentals of prompting. What are the main things you should be looking at? What is the anatomy of great prompt? So we looked at step by step. You should be clear, you should be specific, you should define the audience, you should define the persona, you should define the format, how do you use delimiters. Then we talked about context and examples. What are the fancy terms like few shot learning and zero shot learning and no shot learning looks like. And then what are the common mistakes which people make all the time, and just by not making those mistakes, you can actually be very effective in terms of getting the information you want out of these languages, out of these AI tools. And then briefly, we covered a glimpse of what are some advanced techniques you can use. Again, they are advanced, but they are not. It's not like you have to like take a whole semester to learn how do you use chain of thought reasoning. It's like maybe like watching a 20-minute video on each of these would give you enough information to get started with. And then as you get started and you use it, you'll get to learn more. And as more advanced LLMs are coming, even the researchers on the other side, they know that if you, for example, provide persona in the very beginning, it improves the effectiveness of the model. So they are trying to bake that information in already, right? So previously, if I have to tell, act like a dog trainer, and then tell the rest of the details about the prompt, and the researchers at Google and OpenAI, they're figuring it out. Okay, if you tell the persona, then the response is better. Then they are basically adding that step in every call. So even if you send it without the persona, a lot of LLMs, they have like step-by-step process. First, they use LLM to define what should be the persona to answer it, and they just add it to the prompt. So a lot of interesting things are happening behind the scene, which makes it even more useful and easy to use. So keep an eye on all of those. And then some tricks and tools on how you can actually learn by doing. So try out a lot of things, do a lot of experimentation. Most of these AI tools are free. There's no cost to the question you ask. So use it and keep an eye on what is latest and greatest. And by just staying up to date on what are the latest available AI models and how you can use effective prompts to get the maximum value out of that, you can basically call yourself a prompt engineer, and you can actually apply for those 68 to 130K plus jobs. This is very, very powerful. And the best part, it is actually very, very easy too. Welcome to module 5 of this course. In this module, we'll see that how we can customize or fine-tune the AI models to get even more performance gains than we can from prompt engineering. So we learned that why AI is powerful. We learned the history about it. We learned how do they work, what are different types of generative AI models we have available, how do they learn, and then how we can squeeze maximum value out of it without spending a lot of time and without getting too much technical by being effective at prompting. Now, let's talk about the remaining 10%. So in this chapter and the next chapter, we'll talk about some other little advanced techniques which you can use to get the remaining 10% value. So 90% comes from prompt engineering. The remaining 10%, let's see what we have to do to get some value out of it. So in this module, we'll cover what is fine-tuning. Might seem like a fancy word, difficult word, but it's not. It's basically updating the model for a given data set. We'll talk about what are the benefits, what is the process of fine-tuning, and then knowing when should we fine-tune and when we should not. So developing a sense around that. And then what are some different tools you have available if you want to go towards the route of fine-tuning your models. So we have a lot to unpack. So let's go to the next chapter to get started. So let's begin with answering a very basic question. What is fine-tuning and what is this hype about? So we already covered that LLMs are already pre-trained on a wide variety of data. We talked about Common Crawl being an example data set where your LLM is just going through a lot of information available on a website. But that makes it a generalist in a sense that it knows a lot about a lot of topics, but it is not expert into one smaller niche or field. And this is where fine-tuning comes in, because we want to fine-tune our model onto a specific kind of data set so that your LLM is not just a general expert, it is expert about a specific field. So this is the whole idea about base LLMs are experts in a very broad field, pretty much every field, and then you fine tune them for specific tasks so that they understand the nuances related to that. So we will see more examples around that. And then this ability to fine tune existing pre-trained models, it opens up an interesting opportunity of transfer learning. What this means is that you can take a model which is already trained on some data, and then you can modify it into doing something specialized or doing something else altogether. Now, what the model is currently capable of doing, let's say if that is point A, so this is what the model is currently capable of doing, and you want to get it to a stage to do something else, the shorter the distance, the easier it is to train the model. For example, if you want to train a model to distinguish between, to identify dogs, for example, then one option is that you start from scratch and then you gather the data and then you train a brand new giant big model for it to be able to identify dogs in the pictures. The other option is that you find if there is any other existing model available who does similar kind of job. So instead of starting from zero and getting to this stage, instead of doing that, you start from any other model. Let's say if you find a model which can identify all animals, right? So you take that as a starting point, and then with minimal effort, because if a model is able to identify animals and now you are just trying to identify dogs, it is a similar task. So with minimal effort, you can fine tune this model to become this. So this is what is called transfer learning, and we'll find many examples of that in the industry. For example, if you want to understand if what a customer is saying about your product, and it might be, one option is that you basically train a brand new model to find the sentiment analysis about your company's specific reviews. The other option is that you find some other generally available sentiment analysis model, and then you fine tune it on your company specific data. So that model, which is already has learned a lot of patterns, now you can further fine tune it to become even more expert. The analogy is that a general practice doctor is your pre-trained LLM, for example. Now you can fine tune it so that it develops a specialty. Now you can fine tune it around cardiology, and then that becomes cardiologist. Again, to emphasize that why transfer learning is important or why fine tuning is important. The other option for you to create a cardiologist is to start from ground up, right? So you have to feed it a lot of data. It has to understand English. It has to understand a lot of other worldview, and then it has to become a cardiologist. The other option is that you start with a generally trained model who has a very basic, good understanding of different health concepts, and then you slightly modify it so that it becomes cardiology expert. Transfer learning is immensely important, and it saves us a lot of compute, because now instead of training every model from scratch, as we previously used to do with the statistical conventional ML approaches, now we can just find something which is reasonably good in some adjacent field, and then we fine tune it with minimal effort to become an expert in the field of our choice. Why do we need? Because we can customize our AI responses. And there are many tools, including OpenAI's Cohere, which let you do the fine tuning with pretty much like drag and drop kind of feature. Pretty cool. And that allows your model to learn some specific things for that specific niche. And that brings us to the question of, okay, so now we understand fine tuning, but why should we bother about fine tuning? That's what we are going to cover next. So now let's talk about why should we even bother about fine tuning? I mean, what are the benefits? If we know that this is a technically slightly advanced thing, then why should we care? Well, first of all, it helps you with accuracy and relevance. We talked about 90%, you get it from prompt engineering. The remaining 10%, a big chunk, you get through fine tuning. And then there are instances which we'll see in the rest of the module where prompt engineering might not be possible. So getting better results with good accuracy, relevance, that is probably the best use of fine-tuning. An example you should keep in mind is that if you want to ask for some legal help, would you rather go to a very well-read friend who has read like a lot of books about different topics, or would you rather go to a lawyer who has specialized in that field? And fine-tuned models are basically that like specialized person, because they have seen a lot of information about that specific topic, that they are able to understand different jargons, acronyms, and other things about that specific field. They have built a better intuition around what is the relationship existing in that field, and that overall led to a much better experience as a user when you are dealing with a fine-tuned model versus a general purpose model. So this is definitely a big one. The second is that you can train it on a specific kind of persona or style. For example, let's say if you want to have an LLM, and there are two different scenarios. One is that you want to act like a teacher, and the other is that you want to act like a customer service representative, right? Customer service rep. Now, these two might even give the same amount of information and the same information back, but the tone in which they will give would be very different. A customer service representative should be more polite, indirect, shouldn't try to like be dominating in any way, whereas a teacher should be the dominating figure. They should be dictating, okay, this is what you do, and then this is what you do. Very different, but still subtle and hard to explain concepts. This is the kind of benefit you can get out of fine-tuning, because you are just exposing it on the data set where, for example, if you have previous customer service representatives conversations, so that it learns that when it has to talk in a specific voice and style and all of that. And then niche domain expertise. Again, sometimes, let's say if you want to have an LLM which is trained on different machine maintenance modules and booklets, it is very difficult to give all that context into prompt. So you have to rely eventually on model fine-tuning, because a model which is fine-tuned on those technical logbooks and mechanical manuals would understand what does this product mean and what does that product mean and how do they fit together and what could be the different problems and how to debug the error logs, all of that. So you need your model to be fine-tuned to understand all those acronyms and small things. And especially there is a lot of ambiguity around different usage of words in different industries. For example, a bank in a financial world means something else, whereas in the world of geography, it totally means different things, right? So once your model is further fine-tuned on a specific task, then it is able to distinguish between those ambiguities. And also, another sort of popular example which is given is that think of your underlying base LLM as a versatile actor, and then the way you fine-tune them is that you are basically giving it a script and the scenario for a particular role that actor has to play. So when that versatile actor is in that role, they would act and talk and walk in a specific way. So that is your fine-tuning, by giving it sort of a sense of how and what it should be behaving. It also helps with falsehood, hallucinations. So hallucination is a very important word which you would come across again and again. The basic idea is that LLMs tend to lie in their responses. The reason being that they are basically probabilistic output model, right? So every stage they are trying to predict what is the probability of this word, and they tend to lie. They tend to come up with words. And the worst part is that they lie, but they lied in such a way that it's very hard to distinguish that this is lying. For example, if you are showing it some information about different flights, about different airline, and you ask it about a question, it might make up the flight name, which is very similar to the other flight names you have. But that flight name would be total made up. And it'll make up numbers, it'll make up person names, it'll make up everything. But it'll make up in such a way that it looks very, very genuine. So this is what hallucinations are. And there are approaches to deal with it, but so far there is no bulletproof way to deal with hallucinations, which means that any output which is coming from an LLM is essentially not 100% reliable, and there is an element of LLM basically lying to you. Fine-tuning helps you significantly reduce hallucinations. How does that work? Because you train it on a data that which has a lot of examples. If this is the question and you don't know the answer, just say I don't know. Because LLMs are very good at giving all sort of answers. The one answer it will not give out of the box is, or at least it is very difficult for it to get that answer out of this is, I don't know. You can ask it any question and it'll just make up some answer. A lot of instances that will be a made up answer. And the way you reduce those hallucinations is that you tell it, okay, the information you are saying should be grounded in data. If not, say, I don't know. The other benefit, a very big, is that you can use smaller models to get very good results. Generally, if you want your LLM to behave well, you have two options. One is that you get that big, giant LLM, which is capable of doing everything with very decent accuracy. But of course, that requires a lot of compute. And to host it and to connect with it, it is like very expensive. The other option is that you get a very small model, which is just trained on a specific kind of data. And that model would be much more smaller, it'll be much more inexpensive, and it is also possible as we go towards edge computing, which basically means that we want to have devices installed in different peripheries, and they still have enough compute and resources that they can act standalone. Most of these edge compute devices would prefer a smaller model which they can host on themselves and do day-to-day tasks rather than sending everything back through internet. One example is that if you have a security camera, a CCTV camera in your house or somewhere, a lot of these cameras, to preserve battery, they have human detection. So they want to detect when there is a movement and when there is a movement of a human there. And they have two options. One option is that they just continuously see what is happening. Whatever is happening, they send it back to the servers where you have big models, and then they detect if there is a human or not. And then they send back the information, and this keeps happening. The other is that within the camera itself, you have a small model, which is intelligent enough to identify if there is a human or not in the view. And then that is just so much efficient because you don't have to continuously send back the entire video stream back to the servers all the time. So this is what edge computing is about. So whenever we are talking about edge computing, smaller models which can fit into the smaller host in a standalone way, that just makes it very expensive and very efficient. So this is a long list of why fine-tuning is very beneficial. Now let's talk about how we actually fine-tune the models. Okay, so talking about how does fine-tuning actually work, I'll give a high-level overview, and then in the next slide we'll go a little advanced. So at a high level, the idea is almost identical to how the initial base model is trained. Model, the data is the key here. So you provide it smaller, curated, high-quality data set so that the model can further adopt its weights to be able to learn those patterns. Very simple. You have your pre-existing model, which has some weights, and then you provided more data, which is well-curated, high-quality data set, because garbage in, garbage out, it applies to anything which is related to learning. Even humans, if you give them garbage input, they will learn garbage, and they start giving out garbage. Same goes for machines. So if you have cleaner, well-curated, good data set, chances are, if you train your model further on that, it learns the new patterns. And model is, when I've talked about model, it is basically sort of brain which has different weights defined. What it is, I'll go over that in the next slide. But basically, it has different knobs. It has fine-tuned. And when you are fine-tuning the model, it is basically updating those knobs, and that helps it adjust to the new thing. In this, we'll focus on what fine-tuning is and why you need it, instead of going into the technical details, because technical details sometimes could be scary. The good thing is that now there are a lot of solutions coming up which basically make the process of fine-tuning drag and drop. You don't really have to write a lot of significant amount of code and standardize the data. You can just feed in PDFs, web links, and you're able to fine-tune the model based on that data. And the process at a high level is you have a base LLM, you have the data in the right format, then you train it, and then that gives you a fine-tuned LLM. At a high level, as I said, it's just like adjusting the knobs. So you already have your existing model, which has the knob values set at some value, and then you adjust that based on the new information, the new specialized data you have curated. It's just that you are not adjusting this single knob, you are adjusting billions of them. That is the part which makes it very, very interesting. Now, there are some advanced things which I would cover briefly in the next slide, but at a high level, this is what it is all about. Okay, so now let's talk about a little advanced fine-tuning techniques. Again, I'll be going over them at a high level without writing any equations or anything. If it still doesn't make sense, no worries, because in the previous section I've covered at a high level all the intuition you need. But if you want to go a little deeper and understand what's going on, this is this section about. So we'll go into developing some intuition around how does the fine-tuning work, and then what are some advanced techniques and a lot of that. So first thing is that we say that when the model is fine-tuned, it is basically updating parameters. What is a parameter? So let's talk about an example. So we saw that a deep neural network basically tries to mimic the functionality of a brain. And just like as in brain, there are different neurons connected together, we build deep neural networks in the same way. And it looks like this. So you have some input, and then you have some output, and then you have the next layer of neurons. And then there are so many layers. And then finally you have another second last layer, and then you have the output layer. So here, the information comes in, and this is where you get the output. For example, if it is an image of a dog, so this is where the pixels, each pixel information will go in. And here, let's say if you just have these two, then it will tell you whether it is a dog or it is not a dog. Now, all these neurons, in this case, they are connected together. So this one is connected to this, and similarly, this one is connected to this, and so on. So this is how it is all interconnected. And when I talk about a parameter is a single link between two nodes. So this, for example, the connection between these two is defined by a value, a numeric value. Usually it is between 0 and 1. So let's say if it is 0.8, then the model knows that if the information here is 1, then it gets multiplied by 0.8 or whatever, and this is the output you get. And then this is how the information gets processed. Now, the ability of the model to learn that if from point here to here, the weight should be 0.8, this is parameter. And the model, as it gets trained on more data, it updates this. For example, it's after fine-tuning, says it should not be 0.8, it should actually be 0.6, let's say. So this is what parameter is, the link between two nodes. And every parameter has a value. Let's say it is 0.8. And fine-tuning means that you basically update that parameter. So the brute force approach would be that you update all the parameters in a model as you fine-tune them. Now, the problem with that is that in latest GPTs, we are talking about 1.7 trillion parameters. Now, these are a lot of parameters to be updated. It needs significant amount of resources, GPUs, to be able to do that. So we want to come up with some efficient ways to train the model. And these are called PEFT, which basically stands for parameter efficient fine-tuning. So that we don't have to train and update 1.7 trillion parameters, we want some intelligent way to be able to do it with much less resources. So let's talk about some of those approaches of parameter efficient fine-tuning. One approach which is very, very popular is LoRa. LoRa was introduced by Microsoft very recently, 2021, and it has played a very pivotal role in terms of emergence of new models because it suggests an approach with which you can fine-tune a model with much less resources. So the way it works is that, let's say this example which I created, let me create like a very simplistic version of it. So let's say this is the input, and then you have some deep learning model, and then you have output. So this is your conventional neural network in between, which I've explained here. The way LoRa works is that they add some additional layers, and these are, LoRa basically stands for low rank adapter layers. So you basically add some more layers here, and you feed the data here as well, and you keep this one fixed. You do not update these, for example, 1.7 trillion parameters. You add some more. So this is your LoRa layers, and you just update these new layers. Let me color code them differently. And you just update them so that with just these layers, you are able to update the model. And this has a small thing, but it has led to so much improvement in what kind of resources you need to be able to fine-tune the model. And then there is a lot more research going on here. We heard about adapter layers. And the way adapter layers work is that, for example, coming back to this neural network here, we introduce small layers here of adapters within the network. And we do not touch the existing weights of these existing parameters. We just update the weights of these smaller layers. And the idea is that these smaller layers, or whether it is these LoRa layers, they add a little bit of more nuance and more learning pattern than what the model has previously learned. So it sort of nudges it into another direction in which we want it to go. And then there are a lot of different variations of LoRa. QLoRa is probably the most popular one, and it has just in 2023 the QLoRa paper came in, and it has really contributed towards using smaller compute power to train very good efficient models, and that makes the process of fine-tuning accessible to everyone. Because previously, even like 3-4 years ago, only giant corporations have enough resources that they can fine-tune model. Now with these advanced technologies, it is possible for even much smaller startups and small-scale organizations to have their own fine-tuned models. So QLoRa is basically a variation of LoRa in which this fixed thing, they keep it fixed, but they make it quantized, which basically means compressed. So this fixed, let's say 1.7 trillion model here, they keep it as is, they do not update the weight, it's just that they compress it. So at a technical level, instead of just using float 16, they use float 4, and that makes this giant model to be smaller, and then more compute power can be given to these LoRa layers, and that makes it even more efficient to train. But anyway, this is a field of continuous improvement. Every single month, new research is coming. And the end goal is that we want to use large language models faster, cheaper, and more accessible so that everyone has access to them. And together, for different use cases, we can use the large language models through a specific use case we have. And the idea is that if we can fine-tune models for our specific use cases easily, then we won't have to rely on giant, massive, big LLMs, which are very expensive to operate. Okay, so if the previous module and what we have covered in this module had made you thinking, should you do prompt engineering or should you do fine-tuning, then let's discuss that topic. The short answer is you should do both. There is no getting away from prompt engineering. You should definitely have a good prompt, whether the model is fine-tuned or not. And again, it ties back to 90% of the results would come from good prompt, and remaining 10% we're talking about fine-tuning. So first step should definitely be getting good at prompt, because it's easier, it's flexible, it's sort of one-off task, and even the most, like the best fine-tuned model, if you do not give clear directions, it will fail. Fine-tuning is a deeper skill. It is more involved. It is technically a little more, slightly more difficult to implement. It needs more resources in terms of compute power. But it helps you when you want your LLM to become better at a specific task. So just think about, you have an employee and you want to send it for a specialized kind of training so that they become an expert in that. So that is the rationale here. Ideally, you want both. You want a fine-tuned model so that it understands your jargon and the relationship between different entities within your niche, and it has the voice tone of what you want it to look like. But it is also getting good enough prompt that it gives you and delivers you the results you want. So should you fine-tune or not generally boils down to, if there is a lot of background information which you have to pass in with every single prompt. Then that becomes a good candidate of fine tuning. For example, if you have, again, very technical logs and very technical product names and a lot of technical things which you have to feed in as a context every time you're asking an LLM to do a job, then it is better that you fine tune your model on that specific data set so that in every question or for every task, you do not have to give all that context. It just understands it because it has already fine tuned on it. But if it is sort of a one-off task, and for each specific task, you do not need to provide information about a lot of jargons and technical names, then maybe there's no need to go through the hard labor of fine tuning. And then you can just pass in the relevant information which is in the prompt, and then the model is able to do the task itself. And one myth I want to sort of clarify is that it is the process of fine tuning is very laborious. It requires a lot of compute, and only big tech companies can do it. As we previously talked about, there are a lot of new advanced technologies coming which are making the process of fine tuning easier. It is making it easier by requiring less compute, for example, QLoRa, and it is making the process of fine tuning without much technical coding or any other thing. You can just drag and drop data set into different models. You can select the pre-existing model. You can say, okay, this is the new data, and you press the button and the model gets pre-trained. So this is definitely not something which is not accessible. You need a lot of technical knowledge to implement it, or it is super expensive that you cannot just afford it. It is very much affordable, and it is also very accessible price-wise as well. So if, again, the litmus test is if with every question you have to pass in a lot of context about that specific thing, then probably it's better that you fine-tune it one time so that in the follow-up questions you are quick. So now let's talk about some real-world examples of how fine-tuned models can help you like big way. To begin with, let's talk about a very simplistic use case of a customer service representative bot. Again, it is a very useful application because to be able to train that customer service representative bot, it needs to understand the business context. For example, it has to read the relevant FAQs, any inside company knowledge base, so that it is aware of different workings of the company. And also it has to adopt to certain voice and tone guidelines given by the company. And one way is that for every time, whenever a question is asked to that bot, you give it all the information. The other option is that you fine tune it one time on this is all the information the company has, so that it understands the jargon and little nuances in the technical terms. And also you train it on what kind of voice tone it should be adopting to. And then in the prompt, you can just briefly mention some of those things, and it should do a very good job. The other very interesting use case is that you can teach it a style, and even a lot of LLMs, they allow you to do it now. For example, in Claude, you can give some example writing style guidelines by giving some examples of other material written in that tone and voice. But an example could be that you could say, okay, write a story like Conan Doyle, and you fine tune it on all the previous work of author Conan Doyle, and it is able to learn the patterns of how that particular writer writes and what are the particular characters in, for example, their Sherlock Holmes series. And then it tries to mimic that exact style. Very difficult to teach all of that in a prompt, especially if that author is not very popular and the LLM by default has already learned a lot of pattern out of that. It is very beneficial that you fine tune it to whatever voice guideline you want it to adopt. Then medical research. Even the base LLM, if you ask general medical questions, it will answer, but it will be much more beneficial that you fine tune it on medical related information. It will be even more beneficial that if you fine tune it on a specific branch of medicine, for example, cardiology, or even within cardiology, a smaller subset, so that the more specific the information is on which the model is fine-tuned, the better its performance would be on the relevant tasks. Same goes for legal analysis. You want to fine-tune the model on some legal information. It is very hard to convey that kind of prior background and context and jargons in a prompt. So these are all some very good, very useful, easy to understand examples of how you can use fine-tuning in the real world setting. One example use case I wanted to discuss, again, my observation was that we were trying to use LLMs to answer some company-specific technical cases. So the problem statement is that we have some technical case. This is a technical issue faced by a customer. They send us, let's say, email, and we have a customer's representative, usually a technical engineer, who answers that, right? And we want to automate it. Of course, one option is that we just automate it end to end, so that the moment this case is launched, there is a bot which just answers it right away. But since it is customers on the other side, we don't want to give out wrong information, hallucinations, and we don't want to provide incomplete information. So the way we build this is that there is this technical case, it comes in, then we have a bot, and then that bot creates some helpful answer, sends it to a human, and then human responds back after verification to that customer. Now, here I tried a base LLM, and since they're in the technical cases, the cases are technical, there are so many jargons and technical details that a base LLM just cannot capture. A base LLM won't know that what this specific device ABC means. So when I train it on the previously answered questions, because we have a lot of prior cases of this is the case, this is the answer, this is the case, this is the answer. Then there are product specification sheets which have all the technical details about each product. Just fine-tuning the LLM on that information, it significantly enhanced the usefulness and the correctness of the responses. Also, we added a lot of examples of if this is the question and there is no relevant information found, then just say I don't know. So we taught it say I don't know through that fine-tuning as well. So this is one of the examples in which you can use the power of fine-tuning the model in addition to using effective prompts to get the maximum value out of your LLMs. Okay, so as we are coming towards the end of this module, I wanted to give you some hands-on exercises. One is that try to understand that, come up with some scenarios and analyze those scenarios and see that would you rather fine-tune in that specific case or not. In case you decide to fine-tune, then what kind of prompt would it take to accomplish the same task? If you were to not fine-tune it, then what would the prompt look like? So think about different scenarios and build some rationale around in which cases fine-tuning would be beneficial and in which cases you can just get a long way without fine-tuning it just by having a good prompt. The other exercise is that if you were to create some bot, for example, you want to build a bot which answers questions based on the city you are living in. So whatever city you are living in, you want to answer a bot which can answer questions. So whatever city you are living in, you want to design a bot which can answer questions related to history of that city. Now, this is definitely a use case for fine-tuning. Let me give you that hint. The question is that what kind of data would you need to fine-tune it? So think about it. What are different data archives? Publicly available, publicly not available, freely available, not freely available, digitally available, not digitally available, and try to make a list of those data sets and then see that, just take a guess on how much help it will be to the model if it is fine-tuned on that data. Awesome. So we are at the end of this module. So to quickly recap what we have covered, because we covered a lot of things. We covered what is fine-tuning, how is it different from just prompt engineering, and then what are the benefits. We also talked about how it works, how the model takes more data, and then how it updates its weights, and then how it learns. And we talked about that this updating of parameters or weights is a very compute-intensive process. So there are some advanced techniques, LoRa, QLoRa, which makes that process more efficient and accessible for most people. We talked about scenarios in which you can you should fine-tune versus in the scenarios which you should not fine-tune and just rely on prompting. And then we talked about some real-world examples, including my experience of what are different scenarios in which you can fine-tune the model with what kind of data set and what kind of output or performance gains you can expect out of that. I hope this module was useful. Again, it was slightly more technical than the ones we covered before, but this is where we are unpacking the remaining 10%. 90% of the value you get out of prompting, the remaining 10%, this is what we are trying to capture. And in this, and also what we are going to cover in the next couple of modules. Okay, so this is going to be an interesting module because in this module, we'll cover what are some capabilities of AI to create art in terms of images, videos, audio, 3D, all of that. We briefly covered previously how AI deals with text and also briefly GANs and some other capabilities briefly on how AI creates some of these audio visual things. So this is a little bit more deep dive into that. So in terms of what we'll be covering in this module, first of all, we want to see that how different capabilities like diffusion and GANs help AI create images and video which are very realistic and sometimes exceed, actually a lot of time now exceed the capabilities of what humans can generate in terms of creating art. Then we'll touch briefly on how can we write better prompts for images and video, and how do they differ from writing prompts for text. So we'll touch on that. Then seeing AI's emerging capabilities in terms of music, in terms of voice, in terms of 3D modeling, in terms of better video generation, image generation, and some interesting historical anecdotes related to that. Then we'll realize that AI still has some challenges. It is getting better with every passing day, but still it has some limitations. So what are those limitations? What are the reasons behind those limitations occurring? We'll touch on that. And then where are we going? So this will give you, along with what we previously covered, that what is the path we have taken, where we currently are, and then a little bit into future, that what we think is going to happen in future as the AI models become even more advanced. Awesome. So we have some interesting stuff to cover in this module. So let's get started by having a deep dive into how do these AI models actually create images and then video. So let's talk about diffusion and GANs in the next lecture. Okay, so under the hood, there are two basic techniques which AI systems use to create images, and then that same logic applies in terms of creating 3D models and then videos. But let's start with basics. Let's start that how AI create images. Well, there are two main techniques. There is diffusion modeling, and then there are generative adversarial networks, GANs. We previously briefly touched on that. GANs came about 10, 11 years ago, so they are a little bit older, but diffusion models are recent, and that's why we are seeing that a lot of new AI image generation capabilities, they are powered with diffusion. Diffusion is becoming very popular and very good in terms of creating images which are like very photorealistic. So DALL-E, Midjourney, all of them are using diffusion models behind the scene. So let's briefly cover on what is diffusion modeling and how does it help AI create images which are very, very good. So the basic idea and the name diffusion, it comes from the theory of thermodynamics. So in thermodynamics, there is a diffusion that if there is some particles, and because of that, if they are diffused, which means they get scattered, then what happens? So this is like the whole science behind this diffusion modeling. That if things were in order before, so let's say if this is order where you had things organized, or maybe it was one thing in its good shape, and because of some external event, if that gets scattered into chaos, then what happens? So this is what the theory of thermodynamics captures. How do we go from order to chaos? And the same learnings apply here, and a lot of researchers very sort of cleverly thought about how about if we want to go from chaos to order, then what does it happen? The main idea is that in diffusion modeling, you start with a very static, noisy starting place, right? So if you want to create, for example, an image of a cat, you always start with very static, noisy picture, which is just randomly scattered dots, just like you would see in old televisions if there is no signal. So you would see this white and black scattered plot. And then from there, the model tries to see, okay, if I want to create image of a cat, then let me try some combinations. And if the new combination I try looks a little bit more like cat, then let me keep going into that direction. So this is basically the main idea of iterative refinement from noise to prompted image. If you start with noise and then briefly you go towards creating more image of what was asked in the original prompt. If you want to like imagine, the analogy would be think about a sculptor who is trying to get a model carved out from a rock. So you start with a boulder which has just very rough shape, and then you gradually chip away pieces and carve out something which looks beautiful. So the same logic applies here. You start with a static noise with just random things on the screen, and then gradually we start to make some tweaks. And then at every refinement, the model tries to ask itself, okay, now is it looking like a cat? If the answer from the previous random thing is slightly better, then it's say, okay, let me do a little more of that. If not, then let me go in some other direction. So the model will keep trying different aspects and different things so that it could gradually move towards something which looks like a cat, if the ask in the prompt is to create a cat. Now, to further better visualize what I'm trying to explain, think about if you are in a very big library. So there is a very big library, and it is in 2 dimension, which means you can go left, right, all of that. Also, it has many floors, so you can go up, down, left, right. So you can navigate that space in the library. And within library, there are different sections. So there is a section related to animals, and within animals, there is a section related to cats. Then there are sections related to automobile, and within automobile, for example, if you have like cars and bicycles, etc. So it has different sections. And the way model starts is that it is randomly placed in one place in the library. And then it tries, let's say if it wants to create an image of a cat, then it tries to move in one direction randomly. And then it'll say, okay, am I going towards cat section or not? And if it looks like that it's going towards cat section, it'll keep going in it. If not, it'll try to move into the other direction. So this is an analogy where you have 3 dimensions, right? So you can go left, right, you can go up, down. But in reality, when you're talking about these image modeling, you're talking about sometimes hundreds, sometimes thousands of dimensions. It is impossible for humans to think beyond 3 dimensions. That's why I'm trying to give an analogy where you're constrained to 3 dimensions. But if you understand that, then the same concept applies beyond 3 dimensions. You're trying to navigate the space, and every step you take, you try to say, okay, am I becoming more of what I want to become or less? If it is more, then let me keep becoming more and more. Let me keep going into that direction. If not, then let me try different direction. And the good thing about computers is that since they are very efficient in computing, every iteration of taking a step and then seeing if I'm going in the right direction or not, it is very quick, which means that if you have good enough GPUs and compute power, computer can take thousands of steps within a second. So that becomes very powerful, which means you can try a lot of things and see, are you becoming more of what you want to become? And again, going back to the analogy of a library, if you want to paint a picture of a cat, then you keep going into that direction, try to see that if I'm painting cat or not. And also, since there are so many things in that library which the AI has learned, which means there are different sections in the library for all different things. If you say, okay, image of a cat on a bicycle, then it'll say, okay, cat is in this section of the library, bicycle is in this section of the library. What is one point where I can go so that I have both of those? So it tries to find a good middle ground so that it has some elements of a cat and then some elements of a bicycle, and then the images you get looks like containing all the elements you have asked. So this is the concept of latent space. It's a technical concept you would realize in a lot of machine learning and AI terminology, but essentially this boils down to how do you navigate the space effectively. Then there is a concept of control knobs. Some of the AI models, especially when you're coding them and using some libraries, they allow you to tweak some parameters, tweak some knobs. 2 important ones are steps and then guidance scale for images. Steps basically mean that you want to, how fast you want to go into that direction. Let's say if you start from a random spot and then you want to move towards creating a cat, how big of a steps you want to take, right? If you take very big steps, chances are you'll get very soon towards the point you want to get, but there is also a chance that you might overstep. So if your step is like 20 feet, for example, in the case of a library, one step you're 20 feet towards the cat section. The next 20 feet, you might go beyond cat section, and you miss the point which was very optimal. So that is a drawback of having very big step size. And if you have very small step size, then one, it takes you a lot of time to get to where you want to go, which means you have to take a lot of steps. The second problem which generally happens is that since the model is taking very tiny steps, at some stage it thinks, okay, now I think I'm becoming like a cat, and it takes next step, and it's like, maybe I'm going a little away. It'll settle on that point, whereas the actual good cat section is still far away. And the second thing, the knob is guidance scale, which basically means sometimes you'll heard the term CFG as well for this, which is classifier free guidance. And this is basically telling the AI model how much creative you can be with the outcome. So if the score here is like very low for the CFG or guidance scale, that means you are telling the model, I want you to paint a picture exactly of this kind of cat. And if you have high guidance, then you are basically asking the AI model that, okay, I want an image of a cat, but this is generally what I think I want. You're allowing it some room to be creative. The backstory behind this is that when we were training the AI models to create images, it has some training data based on which it has learned, okay, what is cat and what is dog and what is bicycle and all of that. And if you give it a prompt to create something which it has not previously seen, the models used to come up with not a very good thing, because it has not previously learned the pattern about it, especially when the data was not, the training data was not very big. So if you ask something new, it will give you something which is not very good. And by having this parameter, it's like a very good control you're giving to the people who are using the model, that, okay, how much, if you have like a low CFG and you are very strict and you're not getting good results, then try to loosen it up a little so that the AI model can create something which might not be exactly what you have asked it for, but something which is more nearby of what it has learned before and maybe is better. Also, when it comes to creating AI output, it could be text or audio, video, whatever, you want sometimes it to go beyond what you have specifically asked, because you want it to give you some ideas which you have not previously thought about. So that is like a big intro to diffusion modeling without going much into the coding stuff. Briefly, I wanted to show you, if you come here in Gemini, I've asked it to create an animation, sort of a small video, to show that how you can go from a static noise to something which looks beautiful gradually. And it has created this nice looking 8-second video. So this is, you start from very static noise, gradually you build something step by step, like a beautiful modern futuristic city. Now coming back to GANs, we previously covered them. They are very powerful. They were sort of the initial models which help us build AI images. And we previously talked about the backstory, that how Ian Goodfellow came about the idea of having basically two networks trying to fight each other. So we have a generator model. So this is generator, and then we have a discriminator. So now we have a discriminator, and these two guys are supposed to fight with each other. Generator initially is like, of course, doesn't have a very good idea on how to create art. So when it creates an image and sends it to discriminator, discriminator has no problem trying to identify that it is fake, and it'll give feedback, hey, this is fake because of this and this. Then generator will learn, okay, so I'm spotted as fake, let me do better. And then it creates another image or whatever art. So these two models, they fight with each other. The goal is that you want to get discriminator to be 50% right, which means 50% of the discriminator has like no idea that if it is fake or not. And once you get to that, it means that discriminator is actually confused. And this is how basically these two models are put together to create images and audio and other visuals, which are very, very real. GANs are still relevant today because they have sort of a competitive edge when they are trying to produce something which is fake, but trying to convince others that it is not fake. And we see that it has a lot of applications in style transfer. For example, if you have an image of a person, let's say if it's a painting, and you want it to be painted like a certain artist, then GANs are very good at that. Another website I wanted you to have a look at is This Person Does Not Exist. So this is powered by GANs, and you can see that these people which it creates, they are like very, very photorealistic. And every time you refresh a page, you get a different person. Every time you refresh a page, you get a different person. These are, as you can see, it has style GAN2, a specific model, which they have used to create these images. Very, very photorealistic. And a little interesting anecdote is that in 2018, this portrait of Edmund D. Bellamy, it was sold for $432,500. It was generated by GAN. And this became sort of a new thing that AI has created an art which is good enough that people are willing to pay hundreds and thousands of dollars. So definitely sort of the first time in history that we thought that AI has become so good at creating art which is actually deemed valuable. Also, it sort of sparked an interesting debate in terms of who has the rights to claim or get the money from the art which is AI generated. And this is generated by 2018. Must be a good art. I'm not like an expert in appreciating the details of why this image is worth so much. But the new LLMs we have, you can see that I try to ask it to create a similar painting, and this is what it created. And this looks like much more, maybe a better image than this one. But again, they are improving in performance with every passing day, literally. New research coming, we are improving in terms of the data we have available for training. And also the compute power, new GPUs coming, like more powerful GPUs coming like every passing month. So this is very good. Another thing I want to show you is this image of a teacup and a cozy house. So again, going back to the analogy of a library. So there is a section in that library which is related to houses, and then there is a section about teacups. And when you're asking AI, what would be a teacup, which is also a house, it creates something like this. Because it says, okay, these are the two sections. Let me find a point which is in the middle ground so that it has a bit of both. And then you get something like this. So it's a teacup as well as a cozy house. Pretty neat stuff. So I hope this intro about diffusion modeling and generative modeling would give you at a high level what these two models are, how AI creates these very photorealistic images, videos, etc. Next, let's talk about how you can use these AI models to create better images, videos. What are some prompting techniques you should be aware of, and how do they differ from the prompting techniques which we covered previously for text? Okay, so now let's talk about how you can write some effective prompts to create images and videos which fulfill the purpose you are looking for. So it is a little bit more different than text because we are very good at, especially I think I personally am very good at writing prompts for text than when it comes to images and video, because it is a totally different way of looking, and that's why I want to have like a little bit a high level overview of what are the things you should be mindful of when you're creating prompts for images and video, etc. Because when you're writing prompts, for example, for images, you have to think like an artist, you have to think like a movie director, and there are a lot of things which we do not very consciously think about when we are looking at a picture. But when we are asking someone to create that picture, there are a lot of things we have to be mindful of. So let's look at some of those briefly. The first thing, which is like very, very foundational, is subject and action. This is very important because think of it, if you're trying to build a house, this is like the foundation, the main foundation of it, on which all the other details sort of get attached to, right? So subject is, what is that image about? Is it about a person? Is it about an object? What are you trying to basically showcase? And then let's say if it is about the person, then what are they doing? What is the action they are taking? Are they sitting, standing, walking, running? Same goes for objects. If it's like on is the object flying? Is the object placed on something? What is the condition of that? So that become the number one thing which you should be clear in your mind as well as you communicate in the prompt. The second one is artistic style. Just because you say, okay, create an image of a cup, there are different ways in which the cup can be created. It could be oil painting, photorealistic, and you can also tell, okay, create a cup of coffee created by some artist. So then it tries to understand, okay, for that artist, how would they create this image, and it tries to mimic that. Some interesting side note on this is that this by artist is becoming so much popular on different image and video generation AI tools that now those artists who are popular are becoming concerned that why people are using their form of art without getting permission. And then this is leading to like a lot of interesting debate and features, because now if I am an artist and a lot of people are trying to mimic my style and copy my style and using AI to create images in my style, then I can go and register on those AI tools and ask, do not allow an image created by which mimics my style. Anyway, interesting world we are living in now. To show you briefly how these artistic styles differ, so I asked it to create these two cup of coffees, steaming cup of coffee on the wooden desk. It's same prompt. It's just that one is oil painting. So this is an oil painting, whereas this one is photorealistic. So subtle difference. This looks like an actual image, whereas this is an oil painting, and you can clearly see that. So all these subtleties you have to define in your prompt. Then compositional logic. Do you want it to be like wide shot, close up shot? How do you want that that image to show up? What are the things you want maybe in the background? So you have to explain all of that. Then lighting and atmosphere, very critical. Again, if you do not have like a good exposure to images, video, etc., especially the creation part, then we tend to overlook this, but this is very important. Whenever you're explaining, for example, a cup of coffee, how much lighting should there be? Is it in a dark room, lighten up room? Is it like natural light? Or what's the source of light? Where is it coming from? What is the intensity of it? What is the color of it? So a lot of details to be explained there. Then we have camera lens perspective. Again, if that image is coming across as taken by some camera, then what is the camera lens and perspective? Is like fisheye, bokeh style. What is the style? Then again, a little bit control you can get with defining the weights. So for example, by default, any object you mention should have a weight of 1. But if you want to emphasize something, you can increase the weight. For example, in the prompt, if you have brackets around red car, brackets and then say red car and then 1.5, that means it will give more importance to that red car. It might be bigger, it might be more prominent as compared to the background. But this is a tool you have, a very nice tool. You can just put in one word on a thing which you want to become more prominent in the image, and it will give more emphasis to that. Very cool. Then there is art of negative prompting. If you see that there is an image which is created and there is something which you don't like, just mention that don't include this in the background, or don't have this kind of light, or whatever you want to exclude from the picture. You have control on that. In an interesting example is don't use hands, don't show the hands, because as we'll see in some follow-up slides, AI tends to have its limitations, especially when it comes to like finer details like creating fingers and other stuff. Also, you can give it an image and say, okay, modify this image or use this image as inspiration and create something. For example, there are a lot of tools where you can create basically just a simple headshot of you, and then you can ask it to make it more professional so that you could use it in your LinkedIn profiles, etc. Then there is in painting and out painting. So in painting is that you show it an image and you say, okay, there is this person sitting in the background, can you remove it and replace maybe with some flower, plant, or whatever. So it can cut out a piece of your image and then replace it with something else. A lot of photo editing tools nowadays are supporting that. And then there is out painting, which is like, this is a very close up of me. This is what my surrounding area looks like. Can you expand and broaden it up? So it will see what are the patterns. If, for example, I have a bookshelf here, if it is getting cut off, it will say, okay, how can I extend it? So this is the concept of out painting. So essentially, you have a lot of control. If you are not coming from a background of photo creation, like painting, or even like if you are not a professional photographer, then we tend to ignore these details. So if you are a little bit mindful of these things when you're creating a prompt, you'll do a much better job. Also, just like text, any prompt is a refinement process. The good thing is that now you have AI tools which are very inexpensive or free, and they are very fast. So you can try as many iterations as you want very quickly, very cheaply, and most likely your first prompt won't give you the result you're looking for. So then you have to add some refinement per these guidelines. And then most likely with some effort, you'll get something which is very close to what you want, because AI has come to that stage. It can deliver you pretty much anything you have in mind as long as you're clear in your ask. Cool. So now let's talk about how AI is transforming the music and voice industries, and how those learnings can actually be beneficial for us as well. So let's talk with music generation. It has been a goal of humans for a long time that they want AI to, machines basically, to create music. And the rationale behind that is that if you look at music closely, it is actually a science, right? Because there are, um, the music notations. There are patterns in it. There are individual building blocks of it, and then you can put them in different patterns to come up with something which is very pleasing to hear. And we cover the work of Charles Babbage and Ada Lovelace. This is mid 1800s. And it is interesting that in some of the literature which Ada Lovelace has written, she pointed out that if we were to fully implement the initial vision of Charles Babbage's analytical engine, then it would have the capability to write music as well. So since music has some patterns which machines are very, very good at learning, even so we are talking about mid 1800s, the work of Ada Lovelace, right? So for 200 years, researchers have been sort of aspiring towards this goal that we can ask AI to create some very pleasing to hear music, and it is capable of doing that. And we can tell, okay, create jazz music similar to this artist with these lyrics and create a song, and it does that. So we are almost at that stage. 200 years ago, a vision started. Now we can actually see the implementations of it. So you can be creative with your prompts. Again, it takes you to appreciate the music a little bit and understand the nuances of it so that you can craft better prompt. If you are good at figuring out those details, then you can write some very good prompts. For newbies, sounds like this song or this artist is probably like an easier way to begin. But as long as you're clear with your ask, usually you would get the music which is very similar to what you want to get out of it. And then AI is becoming very good for musicians themselves, because just like for writers, the biggest problem is coming up with the first initial draft. If you're writing an email, writing a book, regardless, it is called writer's block for writers. It is called creative blocks for other creators. AI helps you create that first draft. It can be rough, but you can refine it. Also, you can use it to brainstorm, just like when you're writing or you're coming with business ideas. You can use AI to help you brainstorm. Same idea applies here. You can ask AI, hey, if this is sort of where I am, what should be the next step? And give me 10 variations of that. And then you can pick and choose. So it is helping a lot in terms of coming up with new ideas which are better. So it helps musicians as well. And then a lot of these models, again, we have a little bit of problem here that we do not have as much training data available as we have, for example, for text, but we still have sufficient, and it is becoming better and more data. But we still have sufficient that we are creating very good music. And a lot of these models are trained on music theory patterns and MIDI notes. So these are musical notes, notations. So machine can basically learn from those musical notations and infer the patterns behind them. Again, it is very interesting that these machines, all machines, basically think of things in binary, whether it is 0 and 1, and then how do they translate the learnings from, for example, looking at a musical notation for a song and then converting it into a binary output and then learning from that. That's just very, very fascinating. Okay, now we also have voice synthesizing and cloning, another feature which is becoming very popular. For anyone who has seen the evolution of how this text-to-speech has evolved over the course of years. So we used to have any words or phrases or sounds coming from machines would seem very robotic, just like 5-10 years ago. Before that also. So a robot is saying something, you would like clearly understand that it's coming from a robot, right? So it'll be like, I am a robot. It's like every word is different from the prior one, and there is no ups and downs of human speech and emphasis on certain words. But now, when you converse with any machine, for example, if I were to invoke Gemini in my phone, let's see if I can quickly do that. It is talking in a tone, and I can pick the tone. It could be male, female, aged, young person, and I can pick the tone, and it is very good. So let's try it out. Hey Gemini, what kind of questions can you answer for me?
I can answer all sorts of questions. I can look up facts, explain things, or even just chat. What's on your mind today?
What is the capital of France?
The capital of France is Paris. Did you want to know anything else about France?
When was it made the capital?
That's a bit of a tricky question. Paris wasn't declared the capital on one specific date. It kind of evolved over time. By the late 12th century, it was pretty much the political and cultural heart of France. Want to hear more about its history?
Do you think it will remain the capital for the next 100 years?
That's a fun question. Paris has been France's capital for a really long time, and it's a major center for culture, business, and politics.
Yeah, so you can see that its voice is coming across as very just like a human-like voice. And I was trying to ask it little off-the-script questions, which it definitely most likely hasn't heard before. But you still notice that its emphasis on certain words and the ebbs and flow of the tone, it was very, very good. So we have definitely come a big way, starting from a robotic, this is the band, kind of a robotic, monotonic sound to just like human-like voices. Then there are capabilities of voice cloning. Again, there are like significant ethical issues coming up, but it is considered to be useful as well. For example, especially if you have sort of lost a loved one and you want to have some application talk like your loved one, people might want to do that. You can basically train Gemini, not now, but maybe in future, to use the voice of someone, maybe a voice of you or someone you want. Same goes for GPS, Google Maps, etc., to give directions in that. But this is leading to a lot of deep fakes, and consent is a big issue. You might be using someone's voice to fake, fraud, all of that. So this is totally different aspect, which we'll cover in the last module. And then in terms of applications, one of the biggest is coming up in animation voices and also translating and dubbing movies, etc., into different languages. Previously, it used to take sometimes hundreds of thousands of dollars for a movie to be dubbed in different language. Now, with the AI model so smart, very soon it'll be just clicking of the button and you can translate it and dub it in different languages. YouTube has already launched this feature that for any video, they sort of try to dub it. It's still not like very, very good, but see how far we have come. And for things like this, anything which is based on tech, you see a starting point which might not be very good, but very soon you come to a point which is like awesome. So think about playing with video games. I've played video games like maybe 30 years ago. Back then, you would know that there is this pixelated character and everything was like very, you can spot it from a mile that it is a computer game, non-real. But look at the video games now. It's like watching a movie. Every character, every detail, it's like so much beautiful. So things evolve at a very fast pace. If things look sort of not fully there right now. Think about how much it has improved in the last couple of years, and where would it be in the next couple of years. That would be very surprising. Okay, so now let's look briefly at what AI can do within video and 3D. So in video, you can have text to video. So text to video is becoming very good. I showed you previously a prompt I gave to ask Gemini to come up with a video of a lady looking at baby shoes, etc. Very photorealistic. So again, you have to be aware of the prompt you are giving in terms of lighting, in terms of placement, in terms of camera angle, all of that. But it does a pretty good job in terms of creating videos which are very photorealistic. And I think we are already there. In the next couple of months, you would see entire movies written by, directed by, created by AI, fake characters, but they'll be very good. And how does that impact the billion-dollar Hollywood industry? We would have to see. Because if someone sitting in some small village in some part of the world is just creative enough, they can create movies like James Cameron on a $0 budget, almost $0 budget. So that, yeah, we would see where it goes. AI in video editing. Video editing is I have been doing some of my video editing myself. It's like a very time consuming, very boring, very repetitive task. Perfect for automation. And we are already there that we can basically use AI to edit the videos. And then in terms of future potential, as I said, AI can come up with, if you talk about movies or any other piece of like art, video art, it can come up with ideas, it can create the storyboards, it can give you details, suggest details of different shots within that video. It can come up with prompts which you can write to get those shots. It can do a very good voiceover. It can create those video styles. It can put all of that together. It can edit it. All of that, all those steps, it is there that it can do it itself. And in future, we will see more and more art, which will be coming entirely from AI, and also even for people who are currently working in the industry, a lot of that would be automated. AI for 3D modeling, again, might not be very obvious, but it's like a very good, very big use case for using AI. You can use the text prompt to create 3D models, which you can use in your product design, your game development. Metaverse is a big one. My tenure at Meta, this is where Meta changed its name from Facebook to Meta. All hands with the executives, all Q&A with Mark Zuckerberg. It was all about metaverse. So I've seen that space evolving very quickly, while inside Meta and even outside. One of the biggest thing was that how do you create and render a lot of 3D objects? It could be person's avatars, it could be the surroundings, etc. for games. So now you have the backing of AI to create all those 3D models which are needed for all of these aspects: metaverse, game development, product design. And you can just create an effective prompt, and within seconds, you'll have it. So now let's talk about a little bit shortcomings of AI. One thing which is becoming very popular, sort of a trend on internet, is weird hands. And the backstory is that a lot of times when AI is generating images, though at a high level, it'll capture the details right. But if you look at the finer details, for example, if there is some text mentioned, you would see that it looks like a text, but it is not a text. And if there are like hands and fingers and nails, it will sort of do weird things with them. The main reason for that is machines are still, though they're getting much better, and we'll see an example of that, but machines still are generating an image or video in terms of like probabilistic changes. Again, going back to the analogy of traversing that library, a 3D library, which you can go up and down, left and right. It basically moves into certain directions and try to see if they're moving into the right corner of the library where it should go to. But these smaller things where it does not have enough data, it tends to make mistakes. So it can make mistake in terms of consistency. For example, if you want to use the same character again, the hair might be a little off, nose might be a little off. It does problem with counting. For example, if you say, okay, create a cat with 2 tails, it might create 3. So these smaller details, AI is still sort of struggling, and it is predictable. So when we are dealing with the AI system, we should know that this kind of mistakes are prone to happen, and use these mistakes actually to come up with ideas which we have not thought about, right? Again, going back to that example of how much creative the AI system is actually powerful, because that means it will help you go beyond what you have initially envisioned, and then you can see different variations which you have not even thought about. So this is a shortcoming as well as a strength, depending on how you look at it. But again, whatever the output of the AI model is, it's not set in stone. You can ask for refinement. Sometimes you can manually edit that. For instance, if you want AI to create a banner image or a YouTube thumbnail or something, AI is very good in terms of setting the right background and putting the right things and people in place. It might struggle with text. It might struggle with other details. So you can ask it, okay, don't show hands, for example, if the fingers are a problem. And you can manually put text instead of it to come up with the text. So you can use that refinement process, some manual interventions to come up with what you want. But again, things are improving. This is like a very popular image on internet that if you ask it to create hands, this kind of hands it creates. So pattern wise, it is almost there, but look at the fingers, they're like all over the place. This is created by a stable diffusion model. But today I was asking it to create a detailed photo of group people who are basically waving hands at an outdoor event, trying to see that where does it mess up with hands. But look here, this image is like very good, very, very good, very realistic. Look at the characters, the details, fingers. I see no problem at all. The only thing which is a little bit off is the text on the banners behind. That looks like text, but if you look closely, it's not. It's like maybe in some alien language or in some languages I have no idea about. But other than that, it is becoming better, right? From the fingers which I've shown you to what I'm seeing here, there's already like a remarkable difference. And with passage of time, as I said, as we have more data and compute power and better algorithms, will definitely further improve in refining those details. But even today, if you are a little bit mindful of spotting those details, come up with better prompt, you can still get a very, very good outcome out of this. Another aspect I want to cover when we talk about AI creating art is that there is a big fear that AI will replace humans. I see AI revolution to be similar to any previous big revolution we have seen. When we went through industrial revolution, we saw that there were a lot of manual jobs which were not more there, and those jobs were replaced by machine. But then very soon we saw that there were a lot of new jobs to operate, to create, to maintain those machines. And eventually, the world has become a better place by introducing more efficiency. So again, going back to the analogy of industrial revolution, though it was a little bit painful on the spot, especially if you are a manual labor whose job got automated. But think of how far we have come as a humanity, right? We have better houses, we have cleaner water, we have better food, we have all those facilities which we didn't have before. The same applies for AI, AI revolution. And also, even today, it is not like a fully replacement of humans. It's more of an aid. So again, reminding of that popular quote, it's not AI which will replace your job. It is someone using AI. So if you go through courses like this and are aware of what is the cutting edge technology available out there, you can be very good in using generative AI and other forms of AI to become more productive and create better art if that's what you create. It can help you with ideation, it can help you with brainstorming. These two things used to take a lot of time. You can do very rapid prototyping very inexpensively, right? And very fast. And from that perspective, all technological advancements, as they're becoming more accessible to everyone and they are becoming cheaper, I think they are very good sort of a democratization force, if I've used the word correctly, because going back to the example of Hollywood, if you need to have connections and money to be able to create an image, to be able to create a video, to be able to create a movie, which costs hundreds of millions of dollars. Now, someone sitting in a small village of a small country, as long as they are creative enough, they can create similar kind of movie using AI. So now it is not about resources and about your family background and how much money you have. It is about how much creative you can be. And that is the ground on which you would be competing. So it's a good thing from that perspective as well. It can augment human skills with all of this. You can basically use it as an aid to whatever skills you already have. Again, if you are creative enough, use these video and audio tools to create some beautiful videos for us to watch. It'll open up a lot of new ways for humans and AI collaboration because there is better voice. I just showed you how you can interact with Gemini, right? If it feels like I'm conversing with humans, it just is more effective. Then there are some ethical considerations we should be mindful of. Copyright and ownership. I showed you the GAN image, which was created in 2018, sold for $400,000 plus. Who created it? Who should own the copyright? And there's a lot of legal debate evolving that, okay, if it is entirely coming from AI, then you cannot create like copyright for that. But if there is a human input significant enough, which it helped, then maybe you can ask for copyrights. But how much is enough? It's like a big debate. Then style mimicry and artist rights, again, if you are using someone's style of photo generation, if you are using someone's style of creating art, if you are using someone's voice to mimic, then there would be consent issues. Deepfakes, again, as AI is becoming so good, it is hard to distinguish from reality. It is leading to a lot of deepfakes, another big problem. And then opportunities and anxieties in terms of it impacting creative professionals. It can create audio, it can create songs, it can write movies, it can direct it. So all of that, it's like a very interesting and ever-evolving landscape. So now for a little bit hands-on task, I wanted to show you this image, which I've created using AI. Your task would be, just think about if you were to guess what the prompt would have been in terms of the object, in terms of the action they are taking, background, lighting, all of that, then what would you sort of guess by looking at the picture? So just spend a couple of seconds thinking about this, and that will help you internalize how you can create better prompts to come up with images which look just like this. Okay, so we covered a lot in this module. I hope you found it to be very fascinating and interesting. So a quick recap. So we covered what are the image generation capabilities currently, what are the core concepts. We talked about GANs, we talked about diffusion modeling, how does it work at a high level. We talked about effective prompting and how do they differ from the prompt you need to create text output, and you have to be a little bit more mindful. We talked about different multimodal AI models to be able to create music, voice, 3D, videos, all of that. We talked about AI's current limitations in terms of creating finer details, but still there is a way you can think positively about and see that how that can actually be a strength if it is coming out of the box solutions. And then where do we stand in terms of human AI collaboration and how AI can be seen not as a threat, but as an aid, which you can use to be more effective. We talked about the ethical dimensions of using some of these new AI tools to create deepfakes, to create content, which looks like you, which talks like you, which is using your creative methods and signatures, and then what are the attribution rights and copyright issues related to that. And then we talked about a hands-on experiment where how can you sort of backtrack a prompt by looking at an image, that how would you try to direct that image if you were to give a text prompt. And I think this is an interesting exercise, and I would invite you, if you have enough time, to basically, whatever you think is the prompt for the image I showed you, see if you can come up with something which you think would explain that in detail enough that AI can create an image out of it, and try it and see that how close or how similar the new image is which is coming out of your prompt. So that was all for this module. From next module, we'll go into a little bit more detail in terms of using RAGs and then agentic frameworks. And we are coming towards the end of the course, but there is still some very interesting and very, very useful material we still have to cover. I'll see you in the next module. Welcome to module 7 of this course. Well, this is where the fun actually begins, because now, building on all the theoretical and historical knowledge which we have gone through in the course so far, we'll actually be implementing and building some very fascinating stuff. So very exciting module. Briefly touching on what are the things we'll be covering. We'll go through what is sort of the process from idea to actual execution when we are trying to build some AI app, for example. We'll see that what are some no-code tools available out there, which makes the process of building some actual AI capabilities with no programming knowledge at all. And this is where the beauty of modern technology shines in, because technology now is accessible for everyone. So even if you do not know Python or any other programming language, you can still benefit from these no-code AI tools. So we'll cover on that. We'll be touching on RAG, which is the main focus for this module. What is RAG? Why it is beneficial? Why we use it? We'll go on all of that. And then we'll be building some basic AI helper. So it's like a small project which you'll be actually building without using any code, and using some online tools which are very easy to use, which are very, very inexpensive, like almost free, and still very powerful. And they are production grade systems. You can deploy them for actual industry grade applications. So we will see how it works, and then what the end-to-end AI workflow looks like. So there is a lot we have to cover. It's a very hands-on module. But before we get into the hands-on component, there are some theoretical things I wanted to just lay the foundation of before we jump into the project. So let's cover some of the theoretical things, starting with what are the things you should keep in mind when you're trying to build any application, and especially if there is any generative AI related application. What are some things you should keep in mind? So let's go to that. All right, so let's say you have decided that you're going to build some application. What are some things you should keep in mind, especially if it's your first time you're building some automated application? To begin with, you should always start with a need first. So you realize what is the need for a solution. It might sound obvious, but trust me, in practice, I am also guilty of it, and I've seen thousands of people making the mistake of starting with technology first. So you start with the technology. I want to use this RAG framework, for example, and then you try to find application. You are much better off if you just start with a need. So start with a need and then identify what is the technical solution you can build. A lot of times, the complexity of the technical solution actually needed to serve the purpose might be much easier than if you just start with some fancy technology and try to find opportunities for implementing that. The other thing you should keep in mind is you should always start with user experience first. That what would be the steps a user has to take to facilitate their user experience. So clearly laying it out, writing them down. If you have some sort of a UI mockup, create those mockups first. What would the interaction of a user experience look like? And once you have nailed it down, then going towards the technology, trying to see that what you can do to facilitate that user experience. Then you design the interactions. If they click on this button, then what happens? If they go on this page, then what happens? So all of those interactions you should keep in mind. And clarity of the purpose while you're going through all this is a key, especially if you have many pages and many possible interactions and it all gets very complicated very fast. So having a clarity on what is the purpose we are trying to serve here is very important when you're trying to create any sort of app. So these are some high-level guidelines I want to put in place before we go into implementing a little bit of theory on what is RAG and why we use it. All right, so if you have been consuming any kind of AI, especially GenAI material, you might have heard the word RAG. So what is RAG? Why we use it? This is what we are going to cover on this slide. So RAG stands for Retrieval Augmented Generation. So we are talking about generative AI. Everything is about generation. But what is this retrieval augmented, which we have added before that? So basically, we want to augment our generation process by retrieving some useful information. And the analogy you should keep in mind is that your LLM, whether it is OpenAI or any other LLM you're using, your LLM is a student who has a lot of knowledge about different topics. But what RAG does is it basically gives this student an open book test. What do I mean by an open book? Is that though the student is already very knowledgeable, but to further assist the student to answer the question correctly, we give it some useful information along with the question, right? For example, if this is a calculus question we are asking that student, though the student might already know the answer, but to further facilitate it, we are giving the student the chapter on calculus along with the question so that the task becomes even easier. How it happens in reality, we'll come to that very soon. The reason we do that is that it helps boost relevance. So when, along with the question, we pass in relevant information, it ensures that the answer is very relevant and to the point for the given question. And there are many different use cases for RAG. You'll see it deployed pretty much in every generative AI application. You can pass in product manuals so that the generative AI can answer better questions. You can pass in companies' internal databases into the RAG so that any question the user is asking, along with the question, the relevant information is passed on, which helps with the accuracy and also grounding the answer to the information which is available. So there are a lot of benefits of using RAG. And this is one of the techniques we use besides prompting. So we use better prompts. Then we saw we can do fine tuning to further improve the model performance. And this is the third technique. Prompts just tell in a very clear way what is expected. Fine tuning helps improve model learn more knowledge so that the model is more knowledgeable about the question and the expected answer. And RAG is basically cheating. RAG is that we give some information along with the question so that LLM has very easy job of just looking at that information and then give you the answer most of the time. So a very critical, very easy to implement, but still very, very useful thing. And we'll see how we actually implement it without writing any code. Okay, so last thing before we go towards our hands-on, before we implement anything, we have to pick some tools. And this is a slide about that. So we have to pick some tools, of course, to make things beginner-friendly and to focus on accessibility. I'm trying to use tools which do not require any sort of code so that you can just drag and drop and implement very fancy, very sophisticated thing, which is very, very powerful. You will see that in just a bit. When you are looking for AI tools, you would see that there are a lot of sort of ready-made AI tools versus platforms, which allows you more flexibility. Of course, the good thing about using ready-made tools is that you can just plug and play and it starts working. But the downside is that it does not allow you a lot of flexibility. So a middle ground is some platform tools which are very easy to get started with, but still have a lot of functionality to support you as you want to make more customization. So the tool which we will be looking at today is Langflow. And the reason I really like this tool is that, first of all, it is a no-code tool. You can just drag and drop. Second, it is industry grade, very powerful, have a lot of customization and integration capabilities. So very, very powerful tool. Third, it is part of the bigger umbrella of other generative AI tools like LangChain, Langsmith, LangGraph. Langflow is part of that. So there is like a very seamless integration with a lot of other generative AI tools. And it is the most popular no-code generative AI tool out there. And also it is absolutely free of cost. So that makes it almost a no-brainer to start using with Langflow. And then once you get some expertise and you see how things are happening, feel free to try many different other tools which are readily available. So with that said, let's go to the laptop and start building our first project. Okay, so this is the website for Langflow, langflow.org. You come here, you can get started for free. Basically, just click here and that will ask you to download the application. You can download it in your computer. It takes 2 minutes. And once you have downloaded the application, then you can open it up and sign in with your email. It is free of cost. And you will see a screen like this. So I already have some things which you won't have. So basically what you do is you create a new flow. And it will give you some options to help you get started with some ready-made flow out there. We are interested in building RAG applications, but before we do that, I want to build this basic prompting engine so that you could see that what are different components, how do they work, and then we'll come to the RAG application. So to create a basic prompting workflow, you just click on this and it initializes this screen. Now, there are a lot of things here. Let me quickly go through that. First of all, on the top, this button here, if you click, it will take you to the main page. This is this project. Let me rename it to my first prompting flow. And I save it. You can see the name is here. It is saved. On the left side, these are all the components which this flow supports. There are a lot of very powerful components. Within each of these, there are many options. For example, if you click vector support, you'll see there are a ton of vectors, DBs, which it is supporting. Same goes for models. You can use Anthropic, Azure, Google's, Hugging Face. So it has a lot of options. Very powerful, very flexible. This is a README, just to give you a sense of what is happening and how you can benefit from this ready-made flow which it has created for you. And otherwise, it is just drag and drop. You can see there are different components. They are connected together. There are inputs and outputs, how it is all working together. Very easy to understand, very easy to follow. Now, to use this, we need OpenAI API key. You can use any other model as well, but since OpenAI is the default shown here, it is also very inexpensive and one of the most popular LLM out there. So you would have to go on OpenAI to create an account. Takes 2 minutes, and then you have to generate an API key. So we come on OpenAI API page. We do login with API platform. It asks us to log in. I have already logged in. It'll take you to create an account. It's free. But then you can pick which model you want to choose. And based on that, you can generate an API key. The way you generate API key is you come here on the settings on the left, then you come on API keys, and then you can see that I have already created some API keys. You can create a new secret key. Let me create one. I'll name it as my first key. And then you don't have to assign it to a project. Let me assign default project, create secret key. It has already copied to the clipboard. So this is the API key which I need. Okay, let me go back to the Langflow and let's see. It says add your open API key here. So let me come here and enter the API key. Now there are a bunch of things here. I will go into that. First of all, let's look at the README file. So the README file basically says that you can perform basic prompting with an OpenAI model, or add your open API key, and then open the playground to chat with your model. Next steps, experiment by changing the prompt and the OpenAI model's temperature to see how the bot response changes. Awesome. So we can see this is the chat input. We can put anything here. This is the prompt, which tells the LLM what to do with this chat input. These two things go into the OpenAI large language model. We can choose any of these. It's good that you experiment with the pricing. I know that the cheapest one probably is Foro Mini. I don't need to ask it very fancy questions. I think this is just fine since it's like very inexpensive. Okay, so for the input, we get this chat input, whatever we have put in. The prompt goes into system message. We know this is the model. We have put in the key. To begin with, we have put temperature as 0.1. Now the temperature we briefly covered in our prompting module. Also in the image generation module we covered something similar. Temperature basically tells you how precise or how creative the answer should be. If you make it precise, then it's like very much to the point. And if it is creative, then there's a little bit room for it to come up with some creativity. And then this is the output. So very simple flow here. You get chat input that gets into prompt. These two together in OpenAI gives you the response. So let us now hit the playground. And let me say hello. Okay, so some issue with OpenAI component. Let me go back to, okay, I've copied this. Okay, now I think I have the right key. Let me go back to playground again. Let's say hello again. Yep, this time it is working. Awesome. So we can see it is coming from GPT-4o Mini, which is the model we have chosen. And we can ask it any question we want. For example, what is the current population of South Africa? And it gives us an answer. That is, it says that it was last updated in October 2023. And this is the answer based on that. But the good thing is that we can give it some new information if we want to get some output which is grounded in recent facts. We can just pass it in using RAGs, and that is what we are going to do next. Awesome. So we have built a basic flow where we ask a question to an LLM and then we get the answer within LangFlow without using any code. Now let's take it one step further. So this is what we previously built. Now let's go back to my projects and now create a vector store RAG. So let me click on this. Again, this is a little more advanced, so that's why you're seeing a lot more boxes and a lot of more inputs and outputs. I'll cover the structure first, and then we'll start building it together. Okay, so first of all, let's look at the README file. Load your data into the vector database with the load data flow, and then use your data as a chat context with the retriever flow. So there are basically two flows here. There is one data load flow, and the other one is retriever flow. So you can see the data load flow has 1, 2, 3, 4 components, a smaller one, but this is what we have to do first as per the README file. And then the second one is a little bit more longer, and this is where we will get the actual answer from the question which we'll ask. Okay, let's go back to the README file. What else it says? Add your open API key as a global variable to easily add it to all the open API components. Quick start, run the load data flow, run the retriever flow, experiment by changing the prompt, etc. Awesome. Okay, so we know that we have to put in our open API key into a bunch of places. So let me go back to my open API console, copy this key again, come back here, and let me put it in a bunch of places. So this requires open API key. Then we have an open API key here, and then we have an open API key here. The other thing which we need is some key for this Astra DB. So we have to create an account for this as well. Let's first do that so that we are done with the logistics, and then I'll walk you through what this end-to-end pipeline is doing, how you can further customize it, and see how powerful it actually is. Now, to create an Astra DB account, you have to go to Astra DB website. The account creation here is free of cost, so it doesn't cost any money. You just come on this website, you do get started. I've already logged in. After you log in, then you come on this page. From here, you can get the API key you want. So you go to settings, and then within tokens, you ask it to create a new token. So you come here, you can create an administrative role so that if you have good permissions, you do generate token. So, and here, the part which we actually need is just this token part. We don't need all of this. We just need this token part. So let's copy that and go back to our LangFlow. Okay, so now let's go back to our LangFlow. And here, now we can put in Astra DB application token here, as well as in this box. Okay. So now let's talk about what this flow is doing. As it says, there are two different flows happening. They don't have to happen simultaneously. They can happen one after another. But first, you need to have some sort of data available. this is where you can put in the file, which is basically the open book, which you can pass in along with the question. But with the actual question, we will not pass in the entire book. We'll see what we do around it. So here, let's say if I want some questions to be answered based on a fact sheet, then I will select files. It is asking that I can drag and drop some files. I have previously uploaded this New Jersey state facts. It's like 6 to 8 pages. So let me select that, select files. And then the next stage is splitting text. So here it will take the file and it will divide it into chunks. So let's look at the file first so that it makes more sense. So this is the file which I have uploaded here. You can see it has 6 pages and it has some information about state of New Jersey, about geography, climate, central zone, demographics, economy, etc. What text splitting does is that it splits the text into different buckets. The bucket size will depend on this parameter here. So we say the chunk size should be 1000 words. So it will divide it into 1000 words. And also you can have some overlap within the chunks. You can have no overlap. I'll leave the settings to default. So basically the first stage is getting this file, which you can see here. And then the next stage is splitting it into 1000 words buckets. And the reason we want to divide it into buckets is that when we send the question to the LLM, if we don't want to send this entire 6 pages, we just find the most similar, most related chunks, and then we send that to the LLM. Because here it is 6 pages, it could have been 600 pages, it could have been 6 million pages, right? So we don't want to send all that information into the LLM because one, it'll be too much information, and two, models do not allow the prompt to be too big. So there is this context size which dictates how big the prompt can be. So within the prompt, we can include some stuff, but we cannot throw in like Wikipedia, for example. Okay, so going back to the graph. So now we have provided this file. We have asked it, okay, split it into 1000 word chunks. And here we are asking it to create the embeddings of these chunks. And the reason we are asking it to create embeddings is that we want the text to be searchable. And this is one way of doing it. We are putting these 1000 word texts into the OpenAI embedding model, which creates some vector form embeddings. And to think about it, let's talk about the analogy I gave in the last module, which is there's a 3-dimensional library. So you can go up and down, there are different floors, and it's a very big library. Then there are sections for each kind of book, right? So if there is history section, there are books on animals, that has a different section. So what this embedding is doing is it is basically giving the coordinate of how you can find a book. So for example, it'll say, okay, 2nd floor, 3rd aisle, rack number 5, right? So this is within 3 numbers, you can provide the precise location. And the reason we want to create embeddings is that when we're trying to search the nearest related text, it makes it very fast, it makes it very easy. Okay, so if you want, I won't go much into the embeddings since it's like a very detailed topic in itself, but this is basically a numeric representation of text, which helps us with finding text. All right, so we have OpenAPI key, which can help create embeddings, and then we put things here. We have provided Astra DB application. The reason we want some sort of database is because we want to store these embeddings somewhere. So for example, if we have this text and we have created some corresponding numerical representation, we want to store it somewhere so that when we search, we have a database where we can search. All right, so after you give the application token, which I've explained to you that you can get it from here, then it will ask you to select a database. I've already created this database. You can create a new database right here. Just tell the name, cloud provider, Amazon Web Service, US East 2, new rag db, and you can create it. But I've already created it. It takes a little bit of time for the database to be created, so I'll skip that part, and I'll just pick what I have already created. And with that, I think we are good to go to trigger this. So when I run this component, because it needs input from the previous components, and then those need input from the previous component, all of this pipeline which you're seeing here would start running. Okay, so another thing which it is saying, the collection is missing. So here I have put in the collection. You can create a new collection as well. The default option it gives you is NVIDIA. You have to create an account for that as well. But the better option is that you say bring your own, and then you can put in whatever dimension you want. For example, 1024. You can name it, and then when you create it, the default is has a cosine similarity, so it will automatically default to that. It is free of cost, and that's just more efficient. So I have created this test cosine collection. These are the two steps you have to take, and then you are good to run the flow. Let's see if it runs this time. So it is running, and now it is successful. Okay, so this is the loading of data flow. Again, a brief recap. We started with a file. We split that file into different chunks. For each of the chunks, we created a vector representation, a numeric representation, and then we stored that numeric representation against the text into this DB. That is all we have done so far. Now next, we'll go to the next flow and see that how it works end to end. When we are trying to actually ask a question, then what happens? Alrighty, so we covered the load data flow. We saw that how from file we splitted the text, we created its vector embeddings, and we stored it into database. Now comes to the main meat of this project, which is asking a question and having an LLM answer it based on the file. It has some of the components which we are already familiar with. So we have a chat input. This is a question you can ask. Then we have vector database, AstraDB. You can use any other databases here. For example, here you can see we have a lot of other vector stores and a lot of other embedding models. But AstraDB is free, so let's use that. So we have put in the application token for AstraDB as well as OpenAI embedding. We have to select the same database which we selected because that is where our data is stored. That is where our embeddings are stored. So RACDB, and then collection. For the collection, this is test cosine. These are the collections which we have created, and this is what we are going to use because this is where the data has already reached within this collection and then this database. All right, so what is happening is that you give a chat question. What is this document about, for example? It comes here. It creates the vector embedding of the question. So previously we saw that in the previous step, we took these chunks of words from the document and we created a vector representation of it. The analogy of library, it is third floor, fourth aisle, fifth bookshelf, for example, right? So we created that. Now for each question, we have to do the same thing again. So for each question, we say, okay, if this is the question, and if we have to put it in the same library, where would we put it? Depending on the kind of question, LLMs are smart enough that they would say, okay, go put it in this shelf on this floor, etc. And when we find the coordinates of the question, where would it fall in the library, then we say, okay, what are the nearest available texts out there? And this is how the nearest neighbor search happens. Okay, so We take the question, we create its embeddings, and then we go find it into the database. And then this database basically gives us some search results. These are the nearest neighbors. And then we put these into the parser. What this parser is basically doing is that it is saying, okay, these are the nearest neighbors. These are the text. Let me convert it into a string format. So it converts it into a string format, and then we pass it into the prompt. So our prompt becomes, this is the context. So these are some chunks which are most related to the question asked, and then this is the rest of the prompt. So this is the information from the document. Given that context above, answer the question as best possible, question, and then this is the question and the answer comes after. So this is basically what your prompt is. Once you're done with your prompt, then it goes to the OpenAI API. It gets the answer, and then it displays this. Again, zooming in and at a high level explaining what's happening. You start with chat input. You create its embeddings. You go to the vector database to find the nearest neighbors. You take those nearest neighbors. You convert them into text string so that you could put it into your prompt. So here you're creating the prompt. This is what is relevant information. Now for this question, answer it based on the context above. And then that goes into an LLM to generate an answer. Very simple, to the point. And now let's go to the fun stuff. Let's hit the playground button to see if it actually works or not. All right, let's ask what is this document about. Let's hope there are no errors. It is running, which hopefully means no errors. Okay, yeah. So the document is about this hazard mitigation plan, state of New Jersey, blah, blah, blah. Very, very cool. Okay, let's see if we go to the document and find some information and ask it about it. So it says Delaware River is the largest river in the state. Okay, let me go back. What is the largest river in the state? So now I've not specified the state, but because it knows that this is the document I'm talking about, hopefully it'll be able to answer. But if you ask the same question to any other LLM which has not seen this document, then it'll be confused. But let's see what this guy says. Okay, so it says Delaware River because it is grounding its facts on the document which I have provided. Let's ask some more questions. Let me go to economy or demographics. Okay. Okay, what percent of population has bachelor's degree or higher? The answer should be 29%. Okay, what percent population has bachelor's degree or higher? 29%. Awesome. One more question. Okay, what was state product, total state product in 2024? What's the total state product in 2024? Okay, so 416 billion, awesome. Now you can see that with no code and a little bit of effort, you have created an awesome, very powerful API, very powerful end-to-end working flow, which you can actually leverage. So this is what you can deploy in actual production grade setting. And here, if you publish, you can see that there are different interfaces it is provided. You can embed it into a website, and there is an API access too. So you can access it through Python API, JavaScript, CURL. So if you know how to program, this is something which you can use into your other programming applications. Very powerful. And also, as I explained before, there are a lot of very powerful tools here using different models, vector stores, embeddings. You can put in some agents here, which we'll see in the next module. And then a lot of tools as well. So overall, very easy to use, a very popular and very powerful application. So try to play around with it. It is absolutely free. The only thing which you have to pay for is OpenAI API key, because every call to the LLM, it costs you some money. But I've added $5 here and it lasts me so long. Usually I just use it for my type projects. For my work, I have different work LLM servers, but just put in $5 and use a 4 or mini model for your experimentation, and that $5 which you would fund for the open AI API would last you quite long as you intelligently use it. Also, the good thing is that there are prepaid credits, which means that you're not just giving it your credit card. It can charge you whatever. You just put in some funds. When it runs out of that, then it doesn't automatically charge you unless you ask it to. Okay, so the exercise I want you to leave with is think about what application you can build which would actually be useful using this drag and drop functionality in Langflow, and put in $5 for OpenAI API usage, and the rest is free. So get your hands dirty. You have no excuse of needing any programming knowledge or any other background knowledge. What you have covered in the course so far is sufficient. So now experiment it. Put that theoretical knowledge which you have built into practice and build something which is fascinating. Build something which you are proud of. Build something which you can put in your resume and which actually impresses the hiring managers. So that is all for this module. In the next module, we'll build some very cool agentic AI workflows. Again, we'll be using some Langflow and building some capabilities which would be even more powerful and even more exciting. I hope you're liking the course so far. We are almost reaching towards the end. So stay with me for 2 more modules so that you not only get some more knowledge and some more hands-on experience related to generative AI, but also so that you can get that nice completion certificate which you can put in your resume. Hello and welcome to module 8 of this course. This is the most interesting and hopefully most useful module of all which we have previously covered, because in this module we are going to build on the foundation which we have laid in the last 7 sections. So we started with a very gentle introduction of generative AI, history of it, different use cases, and in the module 7, the previous module, we touched upon an actual hands-on exercise of how you can build RAG-based LLM workflows with no code at all. And in this module, we are going to build on all of that, the foundational theoretical knowledge, as well as the hands-on exercise which you did in the last module. And the reason this one is most interesting is that there is no theory to cover here. I think you have most of the knowledge required to build these fancy, very powerful LLM capabilities which we're going to build in this module. So no theory, it is going to be just hands-on. We are going to jump right into Langflow and start building some fascinating and interesting stuff. Okay, so what are we building today? In this module, if you look at this tweet, it has a very catchy intro about some story about Columbia University. It has this accompanying image to attract attention. And this is a Twitter thread which has some other interesting aspect about that story, and then very good sort of ending with a moral of the story. All of this is created by an agentic AI framework, which we're going to implement in this module using Langflow. So as you can see that it has created accompanying emojis, and the language is very easy to understand so that a lot of people on Twitter can understand it and follow it. So this is what we're going to build. So let's go into Langflow and start implementing it. All right, so we are in Langflow, and let's create a new flow for this. Since we will be using an agentic framework, I showed you how to build a basic prompting flow and a vector store RAG flow in the previous module. In this module, we are going to take it one step further and build a very sophisticated agent-based workflow which can, for a given topic, come up with tweet ideas, it can search the web, it can do a lot of fancy stuff to come up with an interesting tweet ideas, and then it will write and refine that Twitter thread, and it will also give us a prompt which we can use to come up with an interesting accompanying image, and all of that we can then just post into Twitter. So let's start by building a simple agent so that it gives us some things which we can get started with. Right now it has very bare minimal stuff and we'll be modifying it. So the current flow is that you start with a chat input. So this is something the user inputs that goes into the agent. And the reason agent is different from a model is that agent have tools, and using those tools, it can make back and forth calls and do the task which it is given. For example, here we can see it has two tools. It has a calculator tool which it can use, and it has a URL tool. Calculator is pretty self-explanatory. You give it some expression to evaluate, it gives you the answer, and the URL tool gets a URL input, and then it goes and fetches the content of that URL. Both very interesting. And then within the agent instruction, it is given that you are a helpful assistant that can use these tools to create and perform some tasks. Okay, so for our use case, we do not need calculator. So let's delete that. What we need is web search capability. So let's go to tools section here. And here we can see that there are a lot of search APIs. We have Bing, we have Google search, there is this search API. We have a lot of stuff. So what I'm going to pick for this is Twilio search. And the reason I'm picking Twilio is that it is basically an easier to use search API. It is similar to Google, but it is created and optimized for LLMs. As you can see, Twilio search is a search engine optimized for LLMs and RAG aimed at efficient, blah, blah, blah. So we are going to use Twilio as a search engine. And to be able to use anything as a tool, you have to do this. So when I click this, now it becomes a tool. If I do not do that, then you can see that I cannot attach it to my tools because it has different inputs and outputs. But at the moment I change it to tool, now it is very easily pluggable to my agent so that it can use it to make decision. So what have we equipped our agent with? So we start with a chat input. The agent has two tools now. One is a search capability, and the other is this URL content extraction capability. So given a URL, it can get the content. And I think these two are sufficient for this agent. First of all, let us add our open API key here. Let me go back to my OpenAI and copy the key, come back here. Let me paste the key. I don't want GPT 4.1, it's a little expensive. So let me go for the cheapest, 4 mini. For the purpose of this exercise, it is fine. And then as for agent instructions, I have to give it a little more instructions. Let me expand this here and let me bring in the instructions I have written before. Okay, so I'm going to change this with this copied text. You are a helpful assistant that can use tools to find some interesting and relevant historical anecdotes related to the given topic. The output should be in the following format: topic name, anecdote 1, 2, 3, 4, 5. So the reason I am starting with anecdotes or historical interesting incidents is that storytelling is a known tactic to not only get attention but also retain it. It's a fascinating way to communicate the message you have. So if we are trying to create Twitter threads, then why not first find some interesting stories and then we'll create some Twitter content around that. So that's why the first step is to basically use search and looking at the search results and the other websites to find some interesting stories. So the task of this agent is to basically use these tools to come up with stories. That's it. And then in the output, it will give the topic name and then what are the stories it has selected. Okay, so let's keep it at this. One other thing we have to get is Twilio API key. For that, you have to go to Twilio website. You can see its pricing. It is free for a pretty decent amount, 1000 API credits per month, sufficient, no credit card required. And then you can do login with your Google and you'll get the API key. I already have the account. Let me get the credentials and come here and let me put it in my API key. Okay, so now I think we have everything we need to experiment with how our agent is working. So let's go to Playground. Let me give it a topic. So let's say data science. Okay, it is processing. We can see that it's going through different steps. We can see that it got that input. It queried. It is querying multiple times. Fetch content, text, fetch content, and this is the final answer. So it looks like there is some problem happening with the URL. So let me see if I can remove this, and then the search results should still be sufficient to give us the required information. Let me do again data science, and let's see if it is working this time. Yeah, we're getting results. Okay. Okay, so it got some interesting stories out of that. Data science, selected anecdote. Data science began in 1960. Then this second one, third one. Okay, let me change the prompt a little. It should be topic and then this. Okay, finish editing. Let me run it one more time. Let me try different topic, Columbia University. It is processing. Let's see what is the content it is fetching. Okay. So now for Columbia University, it found different historical anecdotes. Awesome. So as a next step, we want to use these created stories so that we can write some tweets. But before we write the tweet, the one thing which is very, very important is coming up with that initial hook, the first sentence, and it should be catchy enough that it grabs users' attention. So we're going to write that. Now to be able to write that, we need another LLM. Let's go to models. Let me get OpenAI here. We'll remove, okay, let me move this one here, bring this here, delete this connection. Now this will become an input here, and then the output would go into message. Okay. Now here, the output of the previous LLM would become its input, and in the system prompt, let me bring this. and paste here. So this is going to become our system prompt. You're an expert tweet thread writer. You're given a topic and some relevant historical anecdote. Given a list of stories related to topic, do the following. Pick one which seems most interesting and has higher probability of going viral. Write a very catchy up to 5-word hook for the first tweet which grabs attention. The output should be, let me also say topic name, selected anecdote, catchy hook, up to 5 words. Okay. Finish editing. Let me go get my OpenAI API key. Put it here. What else? GPT-4 mini. Because it is cheap. Let us run it one more time. Let me again give data science and see. Now it should give me one selected story, the topic name, and the first sentence, which is a catchy hook. Okay, so we have topic is data science, selected anecdote is John Snow, a pioneer in public health, used data visualization in 1850 to map cholera outbreaks in London, demonstrating the power of data analysis to resolve real problems. Catchy hook is the original data scientist. Okay, that seems fair. Let's keep going. Now let me bring in one more LLM to actually write the content of the tweet. Again, OpenAI. Let me delete this connection. This will become its input, and the output of this is going to go out. Let me get my OpenAPI key. It goes here. And as for the prompt, let me bring in what I've previously written. Okay. So you are an expert tweet thread writer given a topic, a historical anecdote, and a catchy hook. Now write the content. This is the expected input format. You have topic, you have selected anecdote, you have catchy hook. Your job is to create a compelling narrative out of the given anecdote to drive a strong moral. Write a tweet thread. Each thread should be less than 280 characters. The output should be in the following format: tweet 1, tweet 2, tweet 3, and so on. Let's do that. Model again, GPT-4 mini. Run playground. Again, data science. It is processing. As we add more stages to the LLM, of course, it will become slow and it will take more time to go through the processing. But we are using a smaller LLM, so it should still be pretty quick. Okay, so the original data detective. Let's dive into the John Snow, into how John Snow pioneered public health, blah, 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 blah. It is separating each tweet with this. This is fantastic. We are already there. Let me just bring in one more so that it can provide some critique and evaluate a little and improve. Also, we want it to generate the prompt which we can use for the image. Okay, so let me bring in one more OpenAI. Let's move here. Let me delete this connection. Oops. Let me delete this connection. Input goes here. Output is here. My OpenAI API key. Copy. Bring it here. 4.0 mini. And then for the last one, this is the prompt I'm going to use. You're a viral tweet writer. You're given a tweet thread in this format. Your job is to make the content as catchy as possible to increase the odds of tweet going viral. Also suggest an accompanying AI image generation prompt, which can be used to create a very related and curiosity-inspiring image from another LLM. The output should be in this format, tweet 1, tweet 2, tweet 3 onwards. And then at the end, after these pound signs, we want the prompt to generate the image. Finish editing, playground, data science, again. So now since we have added one more stage, it will take some more time. Okay, so now it is similar to the one before, but now it has given us a prompt as well. Looks pretty interesting. And this we can use to create the final output. Now, since I'll be actually publishing it on my Twitter, let me get the most sophisticated LLM it has, GPT 4.1. Also, there is GPT 4.5 preview as well. Let me look at its pricing. How much expensive is it? OpenAI API pricing. Okay, so 4.1 is $2, whereas GPT 4.0 mini is 15 cents. So you can see what the difference. Ooh, GPT 4.5 preview is $75. So definitely I'm not going to touch that. GPT 01 is $150. So be very mindful in terms of what LLM you are using. Okay, let me try GPT 4.1. It's a little bit expensive, but let's see. Okay. GPT 4.1, 4.1, and that is, I don't know this one too, 4.1. Okay, so now this will get me a bill of maybe $2-3 to run it, but let's hope that the output is it is worth it. The amount of money it's going to cost is, let's see here again, 4.1, $2 versus GPT 4.0 mini, this guy. So in the input it is 2 divided by 15, sorry, 2 divided by 0.15. So it is 13 times more expensive in the input, and as for output, it is 8 divided by 0.6. So again, 13 times. So this is going to be 13 times more expensive. Let's see if the output is 13 times better or not. Okay, playground. So this is what we got with GPT 4o mini. Let's see for the same keyword, what is the output with an expensive LLM. I'm still not using the $75 one and $150 one. That would be ridiculously expensive. Okay, this might take a little more time as compared to the previous one because the models model there was smaller. This one is a little longer. This one is a little bigger. Okay, so let's do a side-by-side comparison. The original detective, let's dive into Jon Snow, the map that stopped death. I think the GPT-4.1 tagline at least is more catchy. How one doctor's obsession with data saved an entire city. London, 1854, sorry. A deadly cholera outbreak. I would say the writing is much better. The tagline is much better. Let's look at the vintage style map of 19th century London highlighting cholera cases. This is about a map, whereas here it is a street scene. So it is definitely better, but 13 times better, that I don't know. But anyway, let's get this and get to our Gemini to create a new image out of it. a new image per following instructions. Okay. It is generating image, and we can download that image to bring it up in our Twitter. Okay, let's do one more time. But this is pretty good. Someone has like a map of that, and then they're trying to analyze it. Whereas there is this, I think represents blue dots around a water pump and a doctor with hand. Okay. I would pick this one. So let me download. And let's go to Twitter. And let me post a new thread. Okay, so now we have added the image. Let's go back and bring our tweets. Okay. Okay, so this is a different tweet. Post. Okay, after that, and let me just keep posting replies. Actually, this is one complete tweet. Okay, so you got the idea that how we can use this AI tool to create some fascinating stuff. It is very creative. You can create images, you can ask it to do research on Google. It can do a lot of stuff. And we have just scratched the surface. As you start delving into these tools, and as these tools become more popular and more powerful, it is only your imagination which is the limit. You can do a lot, especially in the coming days. So I hope you liked the exercise we did in this module. And before we wrap up this course, in the next module, I wanted to touch on some of the moral and ethical aspects of AI and how to use it responsibly, and what are some potential downsides if the AI power is used without proper responsibility. I'll see you in the next module. All right, so welcome to module 9 and the final module in this course. In this module, we are going to talk about AI ethics. And I know this is sort of a boring topic and not something maybe you signed up for, but I still wanted to include this in this course because anytime you want to go for any kind of weapon training, one thing which is a must in that training is how do you safely handle weapons, because weapon is a very powerful tool and anyone who is dealing with it should know how to handle it properly. I think AI is maybe even more powerful tool, and if you are embarking upon a journey of using AI, you should be mindful of some key considerations there. And this is what this module is about. Now, to keep this sort of boring topic a little bit more interesting, I have used a lot of actual, real stories which have happened in the past and tried to communicate what their impact in real life had been. And the reason I want to use this approach of storytelling in this module is that one, it is sort of a dry topic. Second, there are a lot of things being said about how AI can be used safely, and without actually seeing the impact in real life, it doesn't really resonate with you. Also, you would see that what is the real impact in real life as you go through a lot of these stories. And our goal here is that to demonstrate some of the things which have happened in the past. You can verify them independently if you want. And then based on that, arrive to some conclusions on how AI should be used responsibly and what is going to be your role as an AI practitioner, someone who is using these powerful AI tools to make sure that whatever you are part of building is something which is using AI responsibly. Okay, so now let's come to our first story in this AI ethics section. Amazon in 2014 started a very good, daring new initiative. The initiative was, how can we basically automate the process of hiring? The key idea was very simple, very straightforward, that every time Amazon has to do new hiring, they get a lot of applications because this is a big company. And there are a lot of humans involved in terms of going through their resumes, finding out who is a good fit for the company, who is not. And then some people are called for interviews and so on. And the key idea was that since a human has to look at the resume and nothing else to make a decision, why not we teach a machine to be able to do that? And this idea had some merits because humans sometimes are overworked and they tend to ignore certain kind of resumes. There is some bias potentially coming into their decision-making process. Also, it takes a lot of time and effort. So why not outsource it? And the best part was that they thought they had some training data based on what kind of people were previously hired, what kind of people were previously not hired, and then you train an AI model based on that and let it at least shortlist some candidates so that they could be brought for the interviews. So based on that information, they built this AI recruiter whose job was to basically shortlist good candidates when they receive a lot of applications. One thing which sort of popped out and a lot of people started pointing out is that in the resumes which this AI recruiter was shortlisting, most were male, most were white male. And when they tried to sort of debug what's going on, they realized that because in the past, most of white men were hired, that is why whenever women are applying or whenever people of color are applying, the AI system is not qualifying them as good candidates because in the training data it has seen in the past, there was very little representation of women and other minorities. And they tried to sort of correct it by excluding some keyword terms or by not feeding in the gender of the person. But they realized that the model has learned so many patterns. For example, even if there is a mention of a college, which is all women college, it will give lower weightage to that resume. Similarly, if there is a mention of any women chess club mentioned in the resume, it would give it lower weightage because it has learned that in the past, not a lot of women were hired. So maybe women are not good as men. Anyway, in 2017, they halted the project because because biases were so much ingrained into this model that it was very difficult to totally take them out. Now let's talk about another very interesting event which happened pretty recently, 2019, in New Jersey, not very far from where I'm living. So there was this person, Nigir Parks, and he was arrested because of shoplift and an assault on a police officer. So the backstory was that there was some person who went into a store, they shoplifted, police was called, and that person assaulted that police officer and then flew. Because police tried to identify that person through a video CCTV footage, and they ran it through a facial recognition system, and they found a match. And the matched person was Nigir Parks. He was arrested, he was put into the jail. Even when he provided an alibi that he was actually not in the city and was actually 30 miles away, police did not release him. It was only after a couple of days that police found the CCTV proof of where he was. Luckily, at that very instance, he was in another city and he was making some money transfer, and that was captured on a CCTV, and that was good enough alibi for to get him released. But otherwise, if he had not that kind of strong alibi, he might still have been in prison. And this highlights that a lot of these facial recognition systems, they are trained on white people, mainly white male. And that is why, since they do not have a lot of training data on people of different races, of different colors, of other genders, it tends to misclassify them. And this is a significant case in point that what could be the consequences of misclassification when it comes to these facial recognition systems. In another very interesting but tragic event, about 39 million Australian dollars were transferred to some malicious actors because they deep-faked CFO and other higher-up executives. The backstory was that some employees working in the finance of this Aurup organization, which is based in Hong Kong, they got an email from the CFO that CEO has to make an important and a very confidential transaction. And when the orders come for that, it should be pretty quick. So the people who were asked to do that were still a little skeptical, but then they got a meeting invite in which the CFO and other executives were present with video, audio, and it was all deep faked. And in that meeting, the instructions were again given to make this transfer of 39 million Australian dollars, and they made the transfer. It was only days after that they realized that everything was fake. The email they got was fake. Somehow they were able to hack into the company systems to set up that meeting invite. The videos were fake, the audios were fake, everything was fake. And $39 million were lost, never to be recovered again. And this is not an isolated incident. There are many other incidences of smaller amounts, bigger amounts, where people are trying to portray and impersonate someone of authority, someone you love, and asking for money. And it is very natural for you to fall, and it is very natural for people to fall to that kind of scams. And this is another important aspect of how AI could be a very powerful thing when it goes to wrong hands as well. Another interesting lawsuit which is currently in the courts is that there are some artists who have come together to sue some of these AI image generator companies. And the lawsuit is that there are billions of images. These AI generator images have scanned and used in the model training without consent. And this raises a big question in terms of what is the fair use of AI. And just because an AI image or other video training model can be trained on any data, does it mean that you can use anyone's creative work for creating or fine-tuning your model, because the output is similar to what the training data you have used for the training? And even some of these images would have some sort of a watermark on it. But the thing about these diffusion models and GAN models is that once they're trained on the images, they learn the overall patterns, and you can clearly ask it to remove the watermark. We'll see what the courts decide on these cases. But whatever the decision is, it's going to be a landmark in terms of deciding that what the definition of fair use is going to be. Pretty recently in 2022, there was an incidence of chatbot messing up with some information. So for Air Canada, someone tried to ask on their website, on their official website, there was a bar. Someone tried to ask them a question about what is their bereavement policy and does it apply retroactively. The bot, having access to some information, basically mixed up some policies and gave the answer that yes, bereavement fares do apply retroactively as well. So the person took the screenshot of what the chat bot said and he filed a claim, and upon inspection, Air Canada basically denied that claim because it was against their policy. Then the person went to a court with the screenshot that this is what their bot said. And airline came up with their defense that, first of all, it is not their policy. Second of all, AI bots can tend to make mistake, and they have sort of must have mentioned it somewhere in the bot user interface. And they even tried to argue that the AI bot, since it is made up of some AI technology, it should be treated as a different legal entity. But the court did not buy all those arguments, and they gave the decision in the favor of the person and asked Air Canada to honor whatever the AI bot has said, even if it was not in their policy. So this basically establishes that whatever the AI bot is saying on your official website, the companies have to own that according to this lawsuit. The bias which we earlier talked about also manifests in different scenarios within medical field as well. Just like any other training data, most of the training data available on which these new AI models are trained, they are coming from certain countries, first world countries, where the majority of the population is white. And also for women and other minorities, there is not enough data, which means that these models are not as good in terms of any kind of classification or prediction as they are on white men. This leads to unequal care because the AI models, when they are trying to make diagnosis, they might be very good when they are dealing with white men. They might be not so good when they're trying to, for example, diagnose a woman of color. Also, what was interesting is that a lot of time when it comes to giving a diagnosis, these AI tools, they are relying on factors like race and gender instead of just disease, because it has learned in the pattern that this kind of person of this color tends to have this kind of disease more. And this is leading to a lot of silent problems, because if AI is saying there's no problem and there is no human verifying it, that problem can remain undiagnosed, which could become a bigger problem. And it is much bigger of a risk when we are talking about human lives instead of some other classification where AI is involved. Okay, so what are the key lessons we learned from all these stories? First, the bias is very, very pervasive. Pretty much any sort of data you touch, you'll see that it almost never have equal distribution. And it becomes a problem when we are talking about humans. And we saw that in the case of Amazon hiring using AI. We saw in the case of Niger Park wrongly arrested. And we talk about medical AI as well. The second aspect is that automation's edge, it is a double-sided sword. On one side, it has enormous benefits, which you can get pretty quickly, pretty cheaply. But the downsides are also almost equally important, which we saw in the case of Arup losing 39 million Australian dollars, and in the case of Air Canada as well. The other thing which we learned is that explainability in the models is crucial, because till they remain black boxes, till we do not know what's going on behind the scene, you cannot figure out if the model is actually biased or not, if the model is actually grounding its results into some sort of reality. As long as they remain black boxes, they will make mistakes, and we would have no clue on why they are making these mistakes. Humans' presence is critical. We always need human oversight and judgment when we are dealing with AI models, because without that kind of oversight, AI tends to make mistakes. And in the critical areas, when we deploy AI, the mistakes it can make sometimes are irreversible. We also saw that these AI tools, though they are powerful, now they are very accessible for everyone. It is a good thing and it is a bad thing too, because if these AI tools go in the hands of malicious actors, they can use this with a lot of sophistication to make some very big damages. And Arup's deepfake example is a big one. that some people who just had access to deep fake technology, they created a very sophisticated, actually heist. It's sort of like a bank robbery. It was as organized as that. So as these powerful AI tools become accessible to many people, a lot of these concerns definitely arise. Okay, so now coming to the most important question. What is our responsibility in terms of using AI responsibly? First of all, data matters. So whatever data you are given when you're trying to train a model, just make sure that if it is being deployed in some critical things, it has diverse data. If it is especially about humans, then make sure that diversity is present in the data you are using for the training. Second, test rigorously. See if you can test your model in different scenarios, especially think about how, if this information goes or if this model goes into the hands of some malicious actors, what are the checks in place? So you want to make sure that your AI model is robust enough that it does not allow any sort of problems down the line. Third, seek transparency. So as we go towards these very giant neural network based models mimicking human brain, one thing which is becoming problematic is that most of these are so big and so giant that they are almost black boxes. So see how you can push for some explainable AI systems, even if they are less accurate. If they are explainable, that means you have a very good amount of control. And seeing the inner working of the model, you can divert some problems in the very early stages. Fourth, maintain control. Automation is good, but there should always be human oversight, especially if the AI model is deployed in some critical situations. And then it's not the responsibility of the AI team or AI person to make sure that AI is being used responsibly. You have to collaborate with other teams, other stakeholders. Everyone has to brainstorm and come together as a team to make sure that whatever AI model you're using, however you are using it, it is safe, it is responsible, and it is used for overall human good. And that brings us to the end of this module. I hope going through all these stories, you were able to see firsthand that what could be the consequences of AI models if they are not used responsibly, and how you, as a person who now knows how to use AI, should be mindful of making some mistakes, which could turn out to be very expensive. Well, thank you so much for completing this course. Statistically, for a course which is like this lengthy, there are less than 3% who complete the course. So if you are one of those 3%, I really wanted to say thank you from the core of my heart for spending so much time with me. And I really hope that I have delivered, to some extent at least, on the promise I had made in the beginning of this course, which was, one, to make this course as beginner friendly as possible so that anyone who does not have very technical background, who doesn't know how to code, can still benefit from the contents of this course. And second, to keep this course comprehensive enough that now you are at least aware of the bigger picture about generative AI. You have a good grasp of what is the history has been, what are different key peoples, key initiatives, which got us to the current state where we are, and what are different kind of generative AI models when it comes to images, videos, 3D modeling, and text, of course. And you have made some hands-on exercises that now you can actually start using this power of generative AI for whatever use cases you want to work on. So I hope I have delivered to some extent on that promise I made. Now, I really hope that this bigger picture which I have painted would not only be beneficial for you to start using generative AI, but also now you have a map, and any new terminology which might come up in the future or which might already exist but I haven't covered in the course because it was a limited course. Since you have the bigger picture in place, any new thing which you hear about, I hope now you would have a sense of where you would put it in the map. and how you can make sense of it. For example, if now you say a new image generation model is launched, you would know that, okay, now there are basically two main kind of image models. There are GANs and then the diffusion models. So is the new model a category of within these two, or it is a third category? And also when you hear a lot of acronyms like RAG and GAN, you know what they mean. So this was the main hope out of this course, that you get a good understanding of the bigger picture and you are familiar with these acronyms and these terminologies, and you can see how it actually gets implemented, as we implemented in the module of RAG, and then we build some cool agent system. So where do we go from here? Well, there are two paths. One, if you started this course because you wanted to embrace this new world and improve your skills in AI in whatever you're doing, then after this, I would encourage that you keep using some hands-on tool to actually use and deploy different AI solutions to whatever you're doing. I think Langflow is an excellent one. One, it is a drag and drop, very easy to use. Second, it is one of the most popular no-code AI tools out there, which means it has a very good integration with a lot of LLMs and vector databases, and you have it. So keep an eye on that. Keep using Langflow, and hopefully by staying hands-on and having a little bit of knowledge about different AI terminology, you would already be years ahead from your peers who are just thinking about AI and how it's going to change their life and take out their jobs. So that is the path. If you are working in a non-technical field and you want to embrace AI, then just keep using LLM for whatever you're using. The other path is that if you want to make a career in AI, in data science, in machine learning, then there is a lot to unpack on that. The only key takeaway I want you to have is that a lot of people, when they want to embark on a new career, especially if it's a new shiny career, there is an inclination to start with the top and start learning the new fancy tools, because that is what everyone is talking about. But if you are planning to make a career, my suggestion, based on my years of experience in the field, would be that you build your knowledge ground up. So if you want to become an AI engineer, ML engineer, data scientist, start with the foundations, start with Python, start with SQL. So as I said, there is a lot to unpack if you want to make a career in that. You can look at my YouTube channel where I try to boil down what is the easiest path to get into the field of data science and what are the problems people run into, all of that. So look at that. I have shared many roadmaps in the past, and I'm going to continuously share roadmaps as I learn about new tools, new technology, as the job descriptions evolve and the kind of skills people are asking in the job listings, they change. I try to keep updating the roadmap guidelines. So all of that you can find on my YouTube channel, absolutely free of cost. And yeah, that's it. Again, thank you so much for spending so much time. You are among the 3% people who started this course. So I really admire your dedication towards learning. And I'm pretty sure that whatever this new AI world brings to us, anyone who is up to date with the current knowledge and is trying out the new stuff and is keen towards learning them would be in a much better position than the people who either deny that the world is changing or are just so fearful that they do not take any action. Thank you so much, and all the best for your future endeavors.